Good morning, good afternoon, good evening, everyone, wherever you are, either in Aula Magna here in Granada or in Cosmos Auditorium in Strasbourg, or wherever watching us from all over the globe. Have a great welcome from all of us to you from International Space University. Welcome, ladies and gentlemen, to the final deliverable of this year's Space Studies program, which is the final team project presentations. I am Göktuğ Karacaloglu, the director of the SSP, and it is my great pleasure today to act as the master of ceremonies for this very prestigious event. So this has been, as I'm sure, I hope, a majority of you had followed, been a long journey. It has been actually 9 weeks, but probably for our participants feeling a bit more than that. And if you would recall, at the very end of June, we had kicked off this program, similar to this one in an interconnected manner. And from that point on, there had been, a roller coaster ride. We had so many core seminars, fundamental workshops, elective workshops, and then our teams dived into the departmental activities for the on-site groups. And for our online participants who were also with us, they started their team projects. A couple of weeks ago, to be precise, exactly 3 weeks ago, we had the team project presentation for our online program, and we concluded that program that Friday. And since then, for the last 3 weeks, both here in Granada and in Strasbourg, our participants have been heavily working on, I should say probably like 27, heavily working on their team projects. And today is the day of excitement where they will be presenting their team projects. So just to mention, this deliverable, which is an academic deliverable, the presentation is not their only deliverable. Just a couple of days ago, each of the 4 teams that you will hear today indeed had 2 more deliverables. They each had a 126-page report on their project, as well as a 16-page executive summary. So within an hour of time that you will listen to them, obviously, it's not enough to tell everything about the project. So I want to urge you to go in a few days to the ISU library website and download the report and its executive summary and read them, because you will then get a much more comprehensive understanding, insight to what they have been doing since 9 weeks. Okay, so I'm sure for the people who are from the ISU community knows this, but if you're watching us for the first time from wherever on YouTube, just as a quick heads up. So as you can see on this stage, there is, lots of probes and accessories, which kind of tells you, I think, that you will not watch something, in a traditional manner, an academic presentation where, there is the PowerPoint presentation and somebody is presenting. Rather, what we do in the ISU team project presentations is what we call an academic theater, where, and during the program, by the way, we talk about, the storytelling aspects of it, because, the ISU programs are interdisciplinary. We are not only looking into the technicalities, but we have lots to tell and also try to see how better to tell our stories. So with this information, our participants will actually put together, present to you an academic theater in exactly 1 hour, their team projects that they have been working on so far. So, but I'll not give more spoilers, so let's wait and watch. So one quick information, we have been definitely in a COVID summer, and which is still ongoing. So we have been doing very regular testing, both here in Strasbourg, Granada and in Strasbourg. And this has been so all the participants and the guests currently sitting in our both auditoriums has been tested just yesterday and received their negative results. And also for the participants who will be coming on stage are tested. So we will obey all the social distancing rules. However, we will have also give them the flexibility to take their masks off as they come on stage for their acting. So before we begin, and I see that the presenters are excitedly waiting, a brief timeline for today. So we will be starting with Strasbourg. So they will kick off with their first presentation in a couple of minutes. And then after 1 hour of presentation, we will have our jury asking questions to this team for half an hour. And then we will take a half an hour break as the second team prepares the stage. And then we will start at 11 European time here in Granada for our second presentation, which goes to 12. Until 12:30, we will have the Q&A session. And then we have an hour lunch break. At 1:30, we reconvene again. We go back to Strasbourg from 1:30 to 2:30, and then the Q&A will be from 2:30 to 3. And finally, after half an hour break, we come back here at 3:30 European time for the presentation of the final team project. And I will repeat this order once again when we are into the day. So finally, before I start, I would like to thank very much for our juries who will be acting as jury members either for one or multiple presentations that you will be watching there. Some of our jury members are in person with us. Some of them, or majority of them, are virtually contributing to this event. So thank you very much for everyone who has signed up as a jury member as well. With that, the first presentation, as I said, is in Strasbourg, and Mr. Gary Martin, who is the Strasbourg director, is waiting for us in the Cosmos Auditorium. So Gary, I'm handing over to you at this point for the first presentation. Good luck to all the teams. Thank you.
Thank you, Gaktu, and we're very excited about getting started on this important day. And we're going to start right away with the chair from TP Mobility, Pete Warden. He's going to introduce his team.
Well, good morning. This has been a very exciting and challenging summer, to say the least. Between COVID and personal tragedy, it's been a real challenge. However, the TP Mobility team has really done a spectacular job. I'm not going to belabor things too much, other than saying that, you know, I live in Silicon Valley part-time, and that's where the gold rush began. And not much money was made when people did the mining of gold, but a lot of money was made with the people that built trains and transportation systems. So the mobility is a very important aspect. This decade, we will see humans living on the moon. We will see massive amounts of economic activity there. And TP Mobility is going to tell you in a very entertaining way how that might unfold and how a lot of money could be made and a lot of cool science and technology done. Without further ado, let me introduce TP Mobility.
Hello, everyone. Thank you for joining us today. My name is Julia, and we are co-leads for the Moonport project. Our project focuses on developing cislunar space transportation system. And we are going to be your hosts for today. We would like to introduce to you our amazing team, which consists of 17 members from 14 different countries. We have engineers, business professionals, legal and medical staff. We have combined decades of experience in developing space systems and bringing products to the market. We also have subject matter experts in propulsion, in robotics, in developing businesses and other key areas. So we really believe that with our dedication and with our passion, we can really develop a great in-space transportation team project.
Hello, everyone. My name is Grant, and I'm co-lead of Team Mobility. Today, through the format of a television program, we will be telling you the story of Moonport. These are the major television segments that will introduce our project. We'll start off with a news broadcast, then we'll dive into the Investors Dragon Den, then we'll show you a customer promotional video, followed by the Cosmos Engineering Show. Then we'll look at a nice Rob Boss painting show, followed by the Victor's Campfire talk show. Then we'll conclude and dive into some questions and answers. So we will be acting as viewers today of a 1-hour television program about Moonport. So without further ado, we welcome you to join us on this journey. Please enjoy the show.
So Grant, what do you think would be the best way for people to learn more about Moonport and what it would take for it to become a reality?
Well, I heard that a news broadcaster did a great news segment about Moonport. Let's check it out.
This report looked very familiar, but anyway. So I would be really interested to get to know how to make a business case out of it. So apparently there's like a TV show where entrepreneurs go on it, and then the panel of investigators really dig into the business idea. So apparently the leader of Moonport went there recently to raise the money. But unfortunately, I can't remember the name of the show. So does anyone in the public maybe remember how it's called? Dragon's Den, that's it. Let's check it out.
Today, in the Dragon's Den, we have Mark, an entrepreneur with big ambitions to boost the lunar economy. He is aiming high when it comes to valuation of his company. But will the Dragons, Gwyneth Shortwell, Ricardo Bronson, and Euro Muller, be convinced that his enterprise can really enable a thriving economy on and around the moon? Well, let's hear from him.
Hi, thank you for having me on the show. My name is Mark Multiverse, and I'm the co-founder of Moonport. Today, I'm here to ask you for $1.5 million investment in exchange for 10% equity stake in the company. But first, I'll give you a short pitch. So, what is the problem that we're trying to solve? Rocket launches to low Earth orbit are abundant, but cislunar space is still not easily accessible due to the lack of frequent and cost-effective transportation services. So, how do we address this problem? Our solution is Moonport. It is a three-phased development approach over a number of years where we build a family of vehicles with increasing performance, starting with the 350 kilogram class and eventually building up to 2 and 8 ton capable payload vehicles over the subsequent phases of the business. First phase is 2022 to 2026. Second phase is 2026 to 2032. And the final phase is 2032 and onward. So we address markets from geosynchronous orbit all the way to lunar orbit. But you may ask, what market is there for this type of service? Well, we took a market research approach to looking at potential market segments and discovered that there are hundreds of missions going to both geosynchronous in the small geosatellite operator class and small lunar satellites and lunar landers over the next decade. In addition, there are billion-dollar programs that are building a developmental roadmap towards the moon. So we've identified a market in the first phase at $200 million annually, growing to $400 million by the third phase. So how do we build a business to execute on capturing this market? Well, first, we establish partnerships with launch companies. Moonport offers to customers that are seeking more cost-effective launches to low Earth orbit with new access to geosynchronous and lunar orbits. Next, we focus on spacecraft development by minimizing in-house technology development, procuring commercial off-the-shelf components, and integrating subsystems to expedite our commercial spacecraft production. Then we engage in direct sales, providing a high-touch customer success roadmap from mission planning, integration, and launch services support to operations. Finally, we have a diversity of revenue streams, including advanced booking and multi-year contracts for both single missions and satellite constellation customers, where we offer clear upfront dollars per kilogram pricing. So you may be wondering what it's like to invest in the space industry right now. Well, this is a good time because over the past decade, a number of companies in the space industry have grown significantly. In the past year, 2021 alone, at least 6 companies have gone public in multi-billion-dollar deals, with a few just in the past month. In fact, Virgin Orbit announced a deal to go public via a $3.2 billion special purpose acquisition company merger just on Monday. So this is why we believe at Moonport that now is the time to invest in space. Thank you. Happy to take any of your questions.
Finely tuned pitch from Mark has shown his expertise. Now our investors would like to know more about Mark's knowledge of the industry.
Ricardo here. I've been investing for 10 years in the space industry. It's not an easy industry. What's your experience here?
Well, I've spent the last decade in the launch industry, and I'm now very tuned into these markets. I've seen a lot of momentum going towards the cislunar economy.
You say markets. Remind me, what's your first market that you're going to address?
Well, our initial market is small geosatellite operators who are early customers that we serve with our first class of vehicles. This is just our first market to validate the approach with our minimum viable product. It was strategically selected to fill that market, and then we later expand it as our solution grows to serve cislunar domains.
But serving two markets, isn't that twice the competition?
Well, there are different types of competitors. Space tugs are more direct competition, and launch vehicles are more indirect. Tugs offer precision transportation, although many of these services are still in development, whereas launch vehicles offer more bulk transportation, are overall more expensive, and get you into the general area. However, we focus on a singular market for in-space transportation.
And then the second market, it's the moon. You talked about billion-dollar customers and programs. Who's your real commercial customer there?
Well, there are a number of commercial companies building and sending lunar landers to the lunar surface, as well as small satellites going to the moon. This includes both government and commercial customers for scientific missions, technology demonstration, and then eventually commercial operations. Additionally, they're building the infrastructure ahead of future crewed missions to the lunar surface.
Mark has impressed the Dragons with his knowledge of the market, but will he be able to defend his financials? Will he get a solid reception from Gwyneth?
All right, let's check your financials. Give me the first phase revenues and how many missions will you launch?
Well, we're launching 50 missions to geosynchronous orbit over the first phase, and then expanding that with 20 more missions to lunar orbits. In this first phase, we have a contract pipeline built out to $200 million with expectations to grow that and ramp up to $1.5 billion by the second and third phases.
You're still in the development. How much money it will take you to actually enter the market?
It will cost about $75 million over the first 5 years for the development of the tugs, as well as operational support and production. Then we expect to break even by year 5.
Okay, how much money do you search for in general, and what's your valuation?
Well, right now we're raising $1.5 million for our seed round of investment in exchange for a 10% equity stake in the company. This values us at about $15 million.
How much money will your customers pay for LEO and GEO?
Well, we offer very straightforward pricing, so $38,000 per kilogram to geosynchronous and $151,000 to specific lunar orbits.
Time is nearly up. 2 Dragons have their answers, and now Ricardo wants more information on the company's strategic partnerships.
Mark, I think you spotted the moment to jump in the tugs business. But can you tell me, why do you want to include Virgin Orbit in the strategy? Do you really think you can make money with them?
Well, we see an opportunity for a strategic alliance between Moonport and Virgin Orbit, where Virgin Orbit offers reliable and highly responsive access to low Earth orbit for small satellites, and Moonport extends that responsive access for Virgin Orbit's customers to domains beyond low Earth orbit. Additionally, our reasonably priced cislunar transportation solution for Virgin Orbit Launcher 1 customers is enabled by a space tug that has rendezvous and docking capabilities for repeat customer deliveries, and a long-term solution that includes refueling, extending operations of vehicles beyond the propellant life on board. This significantly will drive down operational costs, allowing for savings passed on to the customer.
How do you compete with the SpaceX Starship, or do we see a space collaboration here too?
Well, we see SpaceX as addressing a different market segment. Starship can offer really low prices eventually, but that's for mass transit to a general orbit. Moonport provides precise transportation to a specific orbit. It's an analogy of taking a low-cost bus fare versus a taxi to a very direct destination. In addition, we do expect to collaborate with launch providers such as SpaceX Starship in order to launch our space tugs.
So in the end, what are the main advantages of Moonport and what's the key value proposition?
Well, firstly, we help to abstract away the complexity of ride sharing while also offering flexibility on time and destination. We offer a cost-effective solution that is focused on cislunar transportation specifically, and we also are able to offer geographically diverse launch options via our partnerships with launch companies like Virgin Orbit.
Well, Mark did his homework, and now it's time to see, will one of the dragons decide to invest in such a highly technological product?
I really like your idea. I see that the Moonport stands in competition with existing market solutions, but clearly addresses the target segment of the market. Most of your competitors are currently in development, which is good for you. But talking about heavy and medium launch vehicles, you will have to fight for your market. However, I'm coming from the different market segment and I'm out.
Mark, I got a solid business case for you. I know a company, Astronis, and they are launching small satellites to GEO. I really believe the concept of Moonport and the flexibility in price that you offer will be a game changing for them. But this is the area which is not within my field of interest. I'm sorry to say, Mark, I'm walking out of it.
So 2 out, that leaves me. As I said, I've been investing in this industry for a long time. I've spoken to a lot of funds, and I'll be willing to make you an offer because I really believe this is a growing market. We're going to go to the moon for the next 20 years. So this has the potential to grow to $1 billion business. So I'll be willing to give you the full investment, 1.5 million, but there's still a lot in development. So I'll give it to you for 50% of the company, 50% of the company, valuing you at 10 million.
You know what? You've got a deal.
Mark has done it. He has a chance to build a multi-million-dollar future.
Well, it was really great to see what the investors think about the Moonport project and what it would take to make it commercially viable.
Yeah, I can't imagine what it would have been like to be that guy. He must have been sweating.
So we've got an idea about the business opportunity now, but how do we sell it to the customers?
Well, how about we watch one of their customer promotional videos?
Well, looks like they've had a really great value proposition and a unique selling point.
Yeah, that was a great overview of the solution they offered to the market. I'm curious how they developed the technologies for such an innovative solution.
Yeah, I've heard about a guy who does all the deep dive in engineering. So I think let's ask him.
Good morning, everyone, and welcome to the Cosmos Engineering Show. Woohoo! Today, we are gonna explain you how to reach the moon and get back. So, the first thing you have to do is to write some equations. No, that's false. First thing you have to do is to ask for money. So, we have here Mrs. Paula Breda, which is chief engineer at Moonport, and Mrs. Tapia Barroso, which is chief scientist at Moonport. Thank you for being here with us. So the first thing you have to do when dealing with a space mission design, you have to define an architecture for your product. So the architecture of Moonport, as far as I know, is really peculiar. They have made an architecture tree for trade-off with 3 levels. So level 1 involves the choice of a certain type of launcher. Level 2 involves the choice between a tag and a carrier, and level 3 involves choice between disposable and reusable vehicle. But let's pass the word to Paula Breda.
Yes, please. So let's have a look together to the slides. We will see in this architecture tree that we have 3 levels of architecture. The first one, we are going to decide whether we're using launcher 1 or a third-party launcher. In the second level of architecture, we're deciding whether we're using a spacecraft as a tag or a carrier. So what is a tag? A tag is actually a spacecraft which is bringing you a spaceborne asset from one orbit to the other. A carrier is a spacecraft which can be launched from the Earth, and it's containing several payloads which will be deployed afterwards in one orbit. The third level architecture, we decide whether our spacecraft is disposable or reusable. In case it is disposable, we would just leave our spacecraft somewhere in the orbit and in the graveyard orbit. Now that we have the architecture tree, we have 8 possible architecture. We have to assess them. And we propose 6 different criteria, as you can see on the bottom table, which are cost, mass, power, compatibility, reliability, and return. So we assign a weight to each of these 6 criteria, and then we make the final count. So as you can see, our final architecture is letter E, which consists of a third-party launcher and a disposable tag. Now that we have our design, we have to decide the requirements.
Thank you, Mrs. Breda. Exactly. So requirements are the first step for the design of a good space product. You see these weird codes on screen. So if you don't know what they are, MP stands for Moonport, F stands for functional requirement, and the numbers are numbers. Then M is a letter that indicates the priority of the requirements with respect to the mission. So M stands for mandatory. It means that you have to consider mandatorily in the design this kind of requirement. Let's make an example. So the spacecraft shall be able to travel from LEO to GEO. It means that you have to consider a trajectory that enables you with a certain delta V, with a certain expense of propellant to travel from a point to another. Or the second, the spacecraft shall be operational by 2024. This implies that you have to use a certain technology level for your product. And there are also some other requirements about the size. For example, your spacecraft shall be bigger than a mouse and smaller than an elephant, but this is another story. So let's see more in detail, which are the concepts of operation for the first phase of the Moonport project.
Thank you, Mr. Nye. Let me talk a bit about the concept of operations of the first phase and tell you a bit more about the technology that we will use. In this first phase, we will service payloads to geostationary orbit, and these payloads will have a minimum mass of 350 kilograms, and we will perform this with a tug of 830 kilograms. The tug and the payload can be sent separately into space, and this tug is called Oscar. This is a cylindrical, non-reusable spacecraft which can be sent into space as part of a rideshare launch.
Thank you, Mr. Tapia, but I didn't hear nothing about science in this explanation. So let's go for a more detailed explanation about what's the science behind. I mean, how about trajectories? So the trajectory of the first main phase on Moonport is very peculiar, actually, because scientists decided to go for a hybrid approach. So they first launched a spacecraft in LEO orbit. LEO stands for low Earth orbit. So in LEO, what happens? There is docking operation. And after docking operation, the spacecraft and the payload move with a certain chemical burn on another orbit. This orbit is not random orbit. It's an optimal orbit that enables the less expense of delta V of the other type of propulsion that Moonport has. And there's also another reason why they combine two certain types of propulsion. It's because of the Van Allen belts. So these are belts of radiation that surrounds the Earth and very dangerous for spacecraft. So they can degrade your electronics, they can degrade your solar panels. So with some fancy calculation, not to go into detail, but Moonport was able to enable a transfer time of 30 days. What's more important, they use this combined chemical electric propulsion.
Did someone say electric? Because you will be shocked to know that the Oscar unit is capable of performing these maneuvers using this chemical electrical propulsion system. So let's have a look to the propulsion unit in the slide. Look at that, it's beautiful. So you have a central ion engine, which is driven by xenon, provides 3,200 seconds a specific impulse, and requires a power of 2,300 watts. And then we combine 4 chemical engines, which are using monopropellant hydrazine for a total specific impulse of 375 seconds. But the propulsion unit is not the only one. There are other subsystems.
Indeed, there are other subsystems, Dr. Breda, because we cannot only get to the moon with propulsion, am I right? We also need to communicate to our spacecraft. That's why we have 4 S-band helix antennas on board Oscar. We also have a 3-axis stabilized system, which has sensors to see the sun, track the stars, an IMU, which is an inertial measurement unit, GNSS, cameras, and of course, lasers. We can control the position of our spacecraft using control moment gyros and chemical thrusters. And how do we keep our system toasty against the coldness of space? Well, with our structure and our active thermal control system. And all of this is powered through our electrical power subsystem, which contains 142 watt-hours on battery energy and 4 deployable solar panels.
Wow, that's amazing. So would you mind to go ahead with the explanation of the phases?
Yes, let me explain you phase 2. In phase 2, we have 3 separate launches. We have 2 Oscar units, which are sent by a third-party launcher. And then we have 2 separate launch from launcher 1, which are taking a maximum payload of 700 kilograms to LEO. Once the units arrive to LEO, we perform docking, and then we have the transfer towards GEO. In GEO, we will release our 2 Oscar units. They're going to be disposed, and we will release our GEO payload. So what happens to the second payload? It's a surprise. It's not a payload. It's another electrical propulsion unit. It's called Hermes. Hermes has an electrical propulsion system and is capable of bringing 250 kilos of payload to the moon. So what about the trajectory?
Thank you, Mrs. Breda. It's all about Mr. Newton here. So what you can do with trajectories usually is to consider two-body problem. So two-body problem is a problem in which there is a primary body which is very massive, and you have a small spacecraft that makes a cycle around the stuff, an ellipse. But if you consider more massive bodies, things change. And there are some equilibrium points in the middle, they're called Lagrangian points, that you can use actually for exploiting new kinds of orbit. And that's what actually the second phase of Moonport does. So you can see on the right a picture of the trajectory with different segments. And you can see in the middle of the picture, there's a small ellipse that corresponds to Lagrangian point. On the right-hand side, you can see a specific view of the trajectory because it's like we are rotating with the line of sight of the Earth and the Moon. On the left-hand side, instead, the reference frame is fixed on the Earth. So you see actually the cycles. What's important about this trajectory? So first of all, there are future developments about the L1 that will be explained later that Moonport wanted to exploit. But most important thing is that exploiting this kind of trajectory that are called low energy with specifically low thrust, you can obtain a lower delta V with respect to conventional transfers. And moreover, transferring from GTO to low lunar orbit just takes 51 days, which is amazing. So let's move ahead now and let's exploit other boring thing like the third phase.
Thank you, Mr. Nye. Indeed, let's go and talk a bit about the third phase and the concept of operations of this third phase. Because then we are making our beloved Oscar, or giving him an upgrade. We are making Oscar refuelable, and therefore its name changes to Roscar. And why do we do this? In order to go from GEO to low lunar orbit and come back. We make the spacecraft reusable, and we can refuel it by putting a refueling station either in GEO, in low lunar orbit, or more conveniently in the first Earth-Moon Lagrangian point. Together with Oscar or Roscar, we can dock with multiple Roscars in GEO and then propel spacecraft to the Moon. And here we can see actually two Oscars docked together, a payload for GEO, the Hermes, and a payload to low lunar orbit. And what is the main difference between Roscar and Oscar? That this time we've added two fuel docking ports to make Oscar refuelable.
So thank you so much to my guests. Thank you so much to you for having us, and let's see each other for another episode of Cosmos Engineering Show.
It was really amazing to see all the engineering details behind the project, from the technology evaluation to spacecraft design to mission analysis.
Yeah, it's really a fascinating solution and impressive to see how the team put this all together. Although sometimes I feel like I get overwhelmed with all the details and I just want to watch a show about a guy painting a picture that really just connects us to the humanity of it all.
Well, it's fun that you say that because I have a very good friend who is a creative artist, and he actually commissioned an art on that exact topic. So shall we check out how it turned out?
Absolutely beautiful. What a great way to pair the arts and the sciences.
Well, that's true. That was really inspiring. And I can't wait to get involved into making spacefaring human race a reality.
So, speaking of the spacefaring human race, what are all the human factors that we have to consider with Moonport? And what are the scientific and political implications of Moonport?
Well, I think for that, we'll need an interdisciplinary panel. And I think I know of just a group of people that could help us with that.
Good evening, everyone, and welcome to Victor's Campfire, our late night talk show that is all about space travel and the people who make it happen. I'm your host, Victor, and with me this evening, I have 4 very charismatic representatives of the Moonport project. From right to left, we have Smith, principal investigator, Federico, who will talk to us about the human performance factors, Antonio is our expert on space applications, and last but not least, Marion, who is representing the legal team. Okay, let's begin by getting to know each one of you a bit better. Smith, I gather that you are the main scientist for this mission. What fundamental questions about the universe are you trying to solve exactly?
Well, we have a lot of research areas right now in magnetospheric and lunar science, and there are a lot of phenomena that are not fully understood yet. So we believe that our spacecraft is equipped with a lot of sensors, and that can help us to collect that unprecedented data, and that we can use in future missions and understand the cislunar environment. So we are most interested in the Van Allen belts, which are located at the altitude of 1 to 2 Earth radii and the 7 to 8 Earth radii.
Before we get too far into the details, for the non-experts among us, what exactly are these radiation belts? And I guess even more importantly, why should the general public even care about their existence?
A very good point, Victor. So the Van Allen belts are in the Earth's orbit, there is a region because of the Earth's magnetic field, it traps the charged particles like electrons and protons, and which can cause a very high radiation environment. And this is very extremely harmful for our spacecraft and especially for humans. So our sensors will help us to collect that valuable data and help us understand the phenomena like magnetic field strength, electron temperature, and proton density. And we can understand that phenomena and then we can work on it.
Okay, I can see that you're going way beyond the physics textbooks. Oh, sorry, Federico, were you about to add something?
Yes, thank you. As Smith was saying, understanding the behavior of the radiation belt is crucial to protect our astronauts during their travels to and from the moon. In this way, we can better predict the effects of the radiation on the human body and also better decide when to abort a mission in case the radiation levels become threatening.
Right. Okay, I think I understand. And also, I think the psychological effects of space and deprivation on astronauts are also quite critical to you.
That's for sure. We are planning to have many vehicles resupplying the lunar station, even more often than the ISS. And this will bring a lot of comfort to our astronauts. They can have more diversified nutrition and even receive personal items from the Earth every few days. Beyond that, however, we are also trying to look into more long-term psychological factors. Roskar, for instance, can be repurposed as an emergency return vehicle in case anything goes wrong on the lunar station. And this will certainly provide an extra layer of psychological safety for the crew up there.
Okay, I can see that this mission of yours is very multi-layered. And I think you also, except for the astronauts, of course, you also have critical people on ground who are supporting you, like the operators, the pilots of Virgin Orbit who are dropping a rocket mid-flight.
Yes, indeed. Well, in this regard, let's say we have been trying to be just as innovative with our personal scheduling as with our technology. This implied scattering many ground control centers in different time zones and also equipping them with special sensors that are able to monitor the well-being of the operators in real time.
Fascinating. Now, back to your final destination. The moon is far away, and I'm assuming you also need a very robust communication infrastructure too. be able to send those commands and get the valuable data that Smith is expecting. So Antonio, maybe you can enlighten us a bit on how you're doing that.
Yes, indeed. Thank you, Victor. Communication is very, very important, especially we are having a look to laser communications, which is very disrupting nowadays, and especially in the infrared band. And these will be very, very important to have a high speed and very reliable communication link, especially when we are bringing cargo back and forth from the moon. And the Moonport can surely test these technologies in real missions.
Wow, laser communication, that sounds very advanced. And what about figuring out where the spacecraft is at any point in time? How do you do that? Is there such a thing as Google Maps in space, for example?
Well, that's not unfortunately completely true. We are going to do that in the future. Moonport can be a very important factor because it allows us to test very innovative satellite navigation systems, and especially when we are going to have multiple spacecraft going back and forth to the moon, especially in phase 3. And we will have multiple roscars that are going to have such infrastructure, and the Moonport can definitely be an important factor in that. So as you can see, the future looks very bright, and we are very looking forward to join it.
Yes, absolutely. And with all these advanced technologies of yours, I'm assuming quite a few of them imply restrictive legal factors as well. Marion, can you tell us a bit about your work?
Yeah, of course. So, you know, it's often shocking for engineer and program manager to hear about all the legal constraints to be considered when you are trying to launch a carrier for one side of the world and launch a satellite from a different state or attempt to dock autonomously. So for each one of these, you need to protect yourself and third parties against the liability damage in case anything goes wrong. Another important legal issues is the export control, since we are launching for many countries and we have diverse nationalities in our team. So this puts more regulation and constraint into the project. But by the way, did you know that you need to insure your spacecraft?
Spacecraft insurance? No way. Are we that far into the future already?
You know that insurance costs are getting lower because now we have more reliable hardware. But you need to know that launching a state is always liable to compensate the victim in case the satellite of its company caused damage. So it's for that a lot of countries actually make it an obligation for the company to get insurance. And to refer to my colleague expert in human performance in space, it's not possible now to insure crew missions because it's too risky.
Okay, and assuming that everything goes right and the satellite is approaching the end of its life, what needs to happen then?
Okay, so on this topic, we have a few new guidelines from the UN Corpus helping us in the space debris mitigation. So for our Oscar, which is going to GEO, it will not be possible to take it back to LEO. So we need to use the graveyard orbit. But for our lunar missions, we will receive the spacecraft back to LEO so we can desorbit it. And actually, it's the best way to do it.
Right, fascinating. I feel like I've learned a lot this evening, and this also marks the end of our show. I'd like to thank my guests for their presence here this evening. And now we have to hand over back to Yulia and Grant. Have a good evening, everyone. Thank you.
Well, there's so much to consider while creating Moonport, and it seems like the team really figured everything out.
Yeah, I feel like we've gotten a great, well-rounded perspective on the Moonport solution from a wide variety of experts weighing in on all the key topics.
So that's the end of our presentation. Thank you very much for the attention. And we would like to thank our sponsor, Virgin Orbit, the chairs and the ISU staff members for the support on the project. And we would also like to thank other ISU participants for sharing this amazing ISU experience with us. And now we would like to invite all of the team members on stage.
Please join me in a big round of applause for everyone hard work on the team project and presentation. All right, thank you everyone for joining us today on site and online. Now we'd like to open up the floor for any questions you might have for us.
I think that was really excellent. You had a lot of information in there and it's really well put together and entertaining at the same time. So I really enjoyed it. I was wondering if you could talk a little bit about where you are in the technological readiness levels for Oscar and Rosker. Are these all known technologies, all space qualified, or are there technological areas that you need to develop?
We have a great question about technology readiness levels. For that, we'll go to our engineering team.
Yes, if you allow me with the mask. So we based our research on the current technologies, technology readiness level 9 for the Oscar phase, which is phase 1. So basically the technology you have have been proven in flight and in space, the chemical propulsion system and also the ion thruster. We do have a combination of this multi-mode propulsion system, which is, according to my knowledge, you may add more information on that. It has been tested and we based our calculation also on existing papers from 2015, which was also quite recent, and 2000, something like this. When we go beyond on phase 2 and 3, we include some technologies that are currently TRL 7, which have been tested on ground, not fully completed in flight. And we will increase, for example, the level of efficiency of the chemical and electrical propulsion system. And we would like to move in phase 3 to a fully electrical propulsion system. So this is the summary of the whole technology right now.
Thank you. Do we have another question from the audience? Yes. We have another microphone.
Thank you very much. It's Joan here, also in Strasbourg. Two very brief questions. The first one is about the requirements that were presented. One of them says that the TAC must be launched by a Falcon 9 or equivalent. This seems to me at least more like an imposition, imposing a solution rather than stating a requirement. So maybe you can elaborate. The second question is on the use of hydrazine, which, as we know, is toxic and generates cancer. There are regulations coming up that tell us that hydrazine should not be used in the future. So maybe you have an answer to that. And my third question is, great congratulations for a most dynamic, entertaining, and instructive presentation. Excellent work. Congratulations.
Thank you very much. For the first two questions about, we'll go to our engineering team.
Thank you so much for the question about requirements. Well, the fact that actually we impose like this Falcon 9 is not an imposition. It was more to give, let's say, a feeling of which is the size of the launcher we are searching for. And it was also based on price consideration per ride share launch. So when dealing with concurrent engineering with the business team, we came out with a business solution that is feasible only if we satisfy certain requirements in terms of price per launch. So we are kind of forced, and this imposition helped us in the design of the spacecraft because constrained a lot our size, since we are docking our spacecraft to a standard ring, 24 inches that is provided for the radar share launch of launcher Falcon 9. So thank you. And I think Paul address.
Yes, I will address hydrazine. You're absolutely right. Hydrazine is toxic. It's not easy at all to handle. So we're not on the environment-friendly wave right now. In any case, as I said before, we base right now the TRL technology readiness level 9. And this is the monopropellant which can give us the required specific impulse of 350 seconds, what we need. There are studies, still current study, technology readiness level 7, related to the use of green propellants, for example, ADN, also in Europe and the US. They have been tested on ground, it's still ongoing. For flight, we are gonna wait for the next year, but definitely this is one point of technology that we'll achieve, maybe we will achieve in 10 years, and we will be able to integrate for phase 3, for example. Thank you.
Just to develop a bit more on that point, well, we have also put a lot of effort into using water and in situ propellants for our future phases from the moon. And that is a further point towards sustainability that we're considering. Both our electrical and chemical technologies perform reasonably well, even with these alternative propellants. So we won't have to change as much the technology once greener alternatives become available and cheaper.
Thank you. Do we have another question from the audience? Yes. Just at the top, there's a mute button.
Okay, we'll swap it out. Thanks, guys. That was a really, really well done presentation. You should be extremely, extremely proud of the work that you've done over the last 9 weeks. It's been challenging, and you should really give yourselves a big pat on the back for that. I'm going to continue the environmental line of questioning here. I was really fascinated by the part where you had Oscar in orbit and you were capturing payloads launched and then taking them onto different orbits. Have you guys investigated the possibility of a spin-off technology into orbital debris management? Because if we are going to start moving into lunar orbits and other different orbits, this is going to be a very real possibility and a very real issue that you guys will probably need to deal with.
Thank you for the question about future orbital debris considerations.
Yes, in fact, when we were working on the docking and rendezvous technologies for our payload, we had the option between outsourcing some of the effort to the customer and having cooperative docking. So then the target would also have to expend some fuel and cooperate with us. But we went for the fully passive payload docking. So in our current methodology from the first launch, we're gonna dock autonomously with the payload. And this is very similar to the scenario of space debris removal. So a lot of the technology will be able to be transferred directly. All the algorithms, all the sensors are ready to go, even to deorbit an upper stage that is currently causing headaches to other people.
Thank you. And I want to open up the floor to anyone online has a question.
If I may, I have few questions. Is Maurizio Nati here from remote?
Yes, we can hear you.
Okay, good morning, everybody. Congratulations for the excellent presentation. And first of all, I acknowledge that the business case is really well done and quite thorough at the very beginning. I am an engineer and I would like to move a bit to the engineering aspects. I have few questions. First of all, it's mentioned GEO. It's clearly said that this is a test case for Oscar, but it's not clear to me why the GEO is maintained also in the case of Hermes and Roscar, because I mean, the transfer lunar orbits are elliptical and typically they don't go to GEO, so must be a reason, and I really would appreciate to have this reason explained. Second, that's a comment, but maybe you have some counter argument here. The architecture is quite well described. However, is asked also by other colleagues before, the system approach, the description of how the system is supposed to work is a bit shaky or not thoroughly done. I mean, some option like, for instance, the hybrid propulsion, why? Is any justification for that? Feasibility assessment, project plan, critical path is not addressed. It looks like a bit that everything is at TRL 9 and you can really do space business by going to the supermarket, buying off-the-shelf subsystems, plugging together is a Lego game, but I mean, I think an investor would like to have a bit more insight on that. And then my two very short final comments. One, you said Oscar could be used as an emergency recovery vehicle, but Oscar is not built as human rated. So in case of emergency, won't be easy to convince somebody to use a non-human rated vehicle to move people. And last, really minor, in the executive summary, and also in the report, I read all the report yesterday, page by page, well done, but still with the same comments. You mentioned several technological items and you listed them under science. They are not science, they are technology. That's all my list of questions. Thank you very much.
Thank you. Thank you very much for your comments and questions. We'll go to our team to address your first few questions now.
Thank you. Okay. Sorry, thank you so much for the question. So if I remind correctly, you're asking why we are keeping the path from LEO to GEO also for the future phases. Well, the point is we test first Oscar's technology to reach GEO orbit. Then, in order not to change our standardized spacecraft, because it has a docking port also on the side, so we decided to exploit the concept of modularity. So trying to merge the concept, joining the spacecraft, we aim to bring an higher mass in GEO, and then from then we can offer double service to the customer. So we can both deploy in GEO, and we can deploy also the spacecraft that with Hermes, which is a separate platform, it's autonomous and can reach the moon with low trust capabilities. Another point is about the Van Allen belts. So when we mention like combined chemical electrical propulsion, well, we use this kind of technology because we don't want to have a spiraling trajectory through the Van Allen belts for too much time, so that we found out it will degrade our solar panels too much. So we won't have enough energy to power our electrical system. For the second question,
Yes, there was a lot of questions, but I think the second question was related to the spacecraft subsystems. Why is it not so a detailed analysis of all the spacecraft? Well, the reason is simple. We had in our mission statement where we tried to propose a solution based on a business case, and we did not declare anywhere that we're going to have a preliminary design review on this proposed architecture and not even a critical design review, which means we base our consideration to build the spacecraft and the relative subsystem first in the development phase based on what we have right now with technology, and also trying to extend what could be available in the next 5 to 10 years. So this is why the level of details is not great, which we will also continue to investigate because this project is really interesting. As you also mentioned, the business case is valid, so it could be a potential for improving the whole subsystem.
And add-on, because I just remembered another part of question regarding the human transportation. So this is, I mean, very important, and thank you for the question. So, of course, we envision future scenarios, and mass capability will grow in time from our investigation, and we'll be able to transport in the second phase 250 kilograms to the moon. So it means that if we want to make a travel back, it will be more or less the same. So an human being could fit actually in a very, very small capsule, or anyway, in a properly designed spacecraft. So, well, it's legit to, I mean, give this question, but let's say it's an envisioned scenario. Yes.
Thank you. And we're happy to address additionally any questions about design, business, human factors, political, legal, or scientific implications as well. Do we have any other questions from the audience? Yes.
I saw a specific impulse number on the chemical propulsion, which was 375 seconds, which seems high just for hydrazine alone. Are you planning a biprop? Because that pushes the boundaries of even like soft cryo.
We have a question about propulsion.
Love this question. Because yes, you're right. Meaning that the capability in terms of efficiency we provide here, it's a bit boost in the sense that our research and development phase will take 2 years, and in this time we aim to like kind of expand somehow the efficiency of our rocket motor. Of course, we know there are limits that can just be overcome with a bipropellant, but as you know, or the audience maybe doesn't know, this will imply an improvement in the mass, which is too huge to be accepted. So this is, say, a provisional solution we adopted in order to, you know, make our spacecraft like a good system, but it's a bit high number, and we will consider this in future. Yes, thanks.
Thank you. And one more time, do we have any other questions from the online group joining us today? And any other questions from on-site in Strasbourg? Yes.
Thanks. I just had a quick question because in one of your last stages of your TP, you talked about being able to take humans as well. I was just curious about if you guys had thought more on this topic, because for the most part, it seems like the operations of Roscoe and Oscar are more on the automated side rather than a manual controller. I know in most spacecraft, if not all, if I'm not going crazy, if they're ferrying humans, there is a manual override. I'd just love to learn more about how you plan to keep people safe in case of an emergency.
Thank you for the question.
Yes, thank you. So in terms of using it to transport people, in our design, a lot of the benefits that we are providing to customers as well as our hardware in terms of the quick access to the moon and avoiding the Van Allen belts do lend themselves to transporting humans. So we have considered it from sort of an early stage there. In terms of the manual override, so this is going to much towards the final phases. This would be, we don't expect to use the exact same hardware because as people have pointed out, it needs to be far more reliable and needs to include these extra additional safety nets. But the plan is to, if, in the case of transporting humans, treat it much more like a kick stage as you have for, say, the Orion capsule, where it is just attached onto the compartment for the humans. So it would be able to have the similar interface going on there.
Thank you. Any other questions? Yes.
Yes, I was wondering, I saw that you put up some of your architectural design study, but I'm really interested. So you came down to these designs that won out from your analysis. Could you bring out any kind of overall like recommendations in this kind of architecture that would go back and forth to the moon and go up to high orbits? Like commonalities, like a recommendation for future people who are designing these kinds of systems. I'm just trying to see if we got any, general recommendations that came out of that.
Thank you for the question.
Yes, thank you. So in terms of, just to clarify, it's more of the lessons learned going through the process as how we would recommend an organization to design such a tug. So one of the major hurdles we found is that there is no single space tug. There are different sized markets for different types of consumer. There's an emerging interest in sending small payloads, such as small landers or satellites to the moon. And there's a completely separate category, for example, of the CLIPS program with NASA, where they're planning on sending much, much larger payloads to, and like cargo runs and things like that. Each would require its own size tug just to get the efficiency aligned, because if you use too big a tug for too small a payload, it doesn't work. And then if you do the reverse, it takes too long. That is one of the major lessons. Other things that we found is that the Van Allen belts have been mentioned in depth, but it is incredibly important. It was every time we pass through the Van Allen belts, you receive a massive decrease in your solar panel efficiency. And if you're planning on using electrical systems, that's a massive problem. So there's some of the major hurdles. I believe engineering would like to add to that.
Yeah, so I think that John kind of summarized very well. The point is, one of the major bottleneck we found out is about propulsion for this kind of tugs, for this kind of spacecrafts. And that's why we came up with this solution that is combines electrical and chemical, mostly because of Van Allen belt. But also there's the trade-off you have to perform about the time of the transfer. And this is strictly related with market research that the business department had done. Also the exploitation of certain low energy trajectory could be a way to overcome limitations in our technology and in mathematics, basically, because delta V doesn't change that much when dealing even with n-body problems. So it's very big problem. Well, I think that one good recommendation for the future would be to enable on-orbit refueling, and this will game change the market. Yes.
Yes, and a final extra recommendation. Some have already been mentioned. A lot is done on market research, where the engineering proposed a solution, market team looked at the market and said, is this really a viable option in economic manner? And for that, the suggestion that I made earlier was concurrent design. We really came together in the end to form an engineering team and a management and a business team that came together and really iterated fast, a lot faster than in the beginning. So it's this finding balance between engineering and market that is really, really important. And definitely with the refueling case, that was also partially focused on for the sustainability, the reuse. So it's also business-wise a very, very interesting option to explore in the future.
Thank you. And do we have any other questions from online or on site? Yes.
This is a ConOps question, concept of operations question. What fuels do you use for certain operations like RPOD for chemical, xenon for big transfers, et cetera? And how does that affect the fuel distribution within the overall tanks?
So we have a question about propellant usage for different types of transfer operations.
Yes, we have in a report, we made so very little calculation about that and the mass budgets required for that, and also related to the specific impulse required for docking, maneuvering, graveyard, deorbit, and that kind of stuff. We didn't get into details in any calculation of propellant transfer and sloshing and that kind of problematics. We will do probably later on when we have more details on the subsystem. And yes, we hope with both propellants for AOCS and also for the main thruster to have a refuelable station for both xenon and hydrazine, or later on for green propellants directly in GEO or in lunar orbit or in the Lagrangian point 1. Depends again on the development of the refueling business.
Thank you. All right, we just have 1 or 2 minutes left. So if we have a final question, please come forward. Yes.
Hello. So you might know where this is going. Regarding nuclear power supplies or any use of nuclear, what were your considerations during the project on this subject? Thank you.
We have a question about nuclear power or propulsion.
I will start from the engineering part, and maybe Marion will continue for the legal part. From the engineering part, you have technologies for that. The problem is, how do you bring it up there, and how do you make it safely? Because if it's already there in space, then we can build something there, and then there is no problem going to the moon, going to Mars, going whatever you want. But we also do not want to have a fatality, an accident, and just blow a potential nuclear bomb in the atmosphere while we are going there. So this is one technological aspect where probably we as population, we are not ready to accept. And now we'll go into the legal aspect.
Thank you for this question. Actually, on the legal aspect, it's very complex to have nuclear in a spacecraft. There is a lot of regulation with the ITER. And it's complex to consider the nuclear as just a propulsion and not a weapon. So yes, we decided all together to, if it was possible, to don't go with this because it's really complex on a lot of things and on the legal part.
Thank you. All right, that's all the time we have for our Q&A session today. Thank you very much all for your attention and for giving us the opportunity to present our Moonport solution with you. Have a great day.
Thank you. Thank you very much, Team Mobility. Such a great presentation. We are also clapping for you from Granada. All right, ladies and gentlemen, that was the first presentation of the day. We looked into on-orbit mobility. So now we have half an hour break. In 30 minutes, we will come back and then listen, this time from Granada, TP Agriculture. So they will be telling us more about the fruit production on Mars. So stay tuned. See you in 30 minutes.
Okay. Hey, everyone. Can agriculture come here, please, if it's possible?
Test, test.
Everyone in Team Agriculture, can you come to the stage?
Divya, Melody, Divya, Cyril. Lucas as well, please. Sarah's in the bathroom. Who's the rest of the team? Thanks for that, man. I forgot to ask you yesterday. We'll ask.
Give you the mic so that we have the, I don't know.
We're using the yellow one.
Yona, can you come and help us, please? Is someone behind stage that can turn the lights on? Johannes? Johannes there? I don't know. Lydia, can you turn on the backstage light? Shane, what do you need? Yeah. Nobody knows where it is. So, like, you stay by the front. By the stage.
Yes.
What do you think? What's next? Shane, is the headset here? Headset?
Headset mic for Patrick. We're missing a headset mic. It's not bad.
I want to have a quick sound check with Francois. Francois, can you hear us?
G2, can you let us know when you're going to start? Jules, are you guys going somewhere? We need to have a quick conversation before everything starts. Everyone in agriculture. Is everyone people outside? Or?
Francois, this is a cross check for you. If you can respond, if you can hear us, please.
Agriculture de la CR. The game, finalists get in the zone.
Lydia, Johannes, and see you.
Texture of them would lose appetite.
Show you today and have focused my dish on a
Some of us are strong.
innovative.
Yes. Okay, 1, 2, 3, mic test. I'm talking, and I don't know if you are able to hear me. 1, 2, 3, mic test. Mic 1, 1, 1. Is it working better now than yesterday? Is it loud enough, or is it too loud? 1, 2, 3, 1, 2, 3, mic test. Mic check, check. TP agriculture is the best TP. Is it okay? No?
Algen gedijen gelukkig juist goed in zo'n
Plants and insects. Yes. This is what they are going to eat?
They will need in a
Impacted by such omnipresent organisms on Earth.
Okay, can you hear me well or not really? 1, 2, 3. Okay. And the videos, Leticia? The sound of the videos? So Juliana, can you play a video or something? Because Leticia is connected online.
Of the human species.
It's my pleasure to introduce to you our wonderful hosts, Divya and Patrick.
Bepaalde microalgen gedijen gelukkig juist goed in zo'n omgeving.
Appliquer, vous l'utilisez et ça.
from organic waste will be most relied on.
Okay. So. To the stage, please. Thank you. Okay.
Hello? Jules, can you hear me? How's it sound? Is it loud enough? A bit louder? Louder? Can they, do you want to make it louder there? You want me to talk louder?
It's quite loud.
Test.
Very loud.
I think
They're
it's a bit
saying
louder for Divya. A bit louder for me?
Yeah.
Okay.
Not your voice, yeah.
Okay. Otherwise I'll be shouting
I will
on
bring
stage.
Just wait till Yona's right here fixing something, so
Okay.
wait till he goes up and he'll adjust it.
All right,
Do
cool.
the sound check with all the mics now.
Brilliant. Are you ready? Born ready. You're born ready, yes.
Test 1, 2, 3, it's okay? 1, 2, 3. I think these are fine. Patrick, when you're walking around and not talking, you may want to turn your mic off.
That's fine. It's cool.
Guys, can I say something? I know that not everyone is here, but for Q&A,
We need to have face masks. If we are all in the front, please don't.
Oh, you can sit anywhere in the crowd.
cellules immunitaires de notre corps sont situées dans l'intestin. Lorsqu'il va mal, c'est tout notre organisme qui va perdre.
Do a very complicated maneuver where we're going to transform the SS process from a vertical position to a horizontal position. That is important to enable the on the side, the SS process side, and they are going to verify that everything is ready, that everything that was installed properly, and we are then going to tilt the vehicle. So I'm now going to talk with the crew, see that everything is ready and performed nominally, and we'll talk in a few minutes.
This. I'm talking with an astronaut on the moon. Astronaut Charlotte, can you hear us?
I can hear you loud and clear. Hello, Earth.
And hello to the moon. Oh, I've always dreamt to say that. We are very honored to have these few minutes with you.
It is so nice to hear you, and I can't believe that this is such a milestone that is happening now. As you may notice, we have some bandwidth issues because we still need to set up some subsystems. And in addition, we have the 2.5 seconds delay because we're on the moon.
Yes, we hear that you are very, very busy up there. And this is exactly why we wanted to talk to you. Today, you will be entering the horizontalized empty rosa space for the first time to refurbish it. How is it going to go?
So today we're gonna open up the hatch. And when we have opened up the hatch, we're gonna go inside the tanks, inside the fuel tanks, and actually connect the tanks. Because that
All right, we are back live. Welcome back, everyone, to the second team project presentation of today. So this morning, as you know, we have heard about on-orbit mobility, and now here from Granada, our teams will tell more about TP agriculture. So we have two team project chairs, Vanessa Martos and Francois Spiro. Vanessa is with us. Vanessa, please proceed to the stage, and Francois is joining us from Paris online. So let's hear from the TP chairs a little bit of the project, and they will hand over to the team. Vanessa, welcome.
Thank you so much. Thank you so much. Good morning, everybody. I'm very happy, very excited. And thank you so much, my dear co-chair, Francois Piero, for National Center for Space Studies, and of course, dear TP, Anderson and Jorge. Thank you so much for your support, help. Our TP Agriculture and Nutrition for a Long-Term Mars mission and benefits to Earth. The team project participants have studied the most appropriate food types and food production techniques suited for a permanent Mars settlement. The engineering, legal, financial, scientific, ethical, and physiological aspects of such endeavor have been addressed. The team projects propose the next step to the future of agriculture with the application of new technologies. This includes advanced remote sensing by drone or satellites, artificial intelligence, and vertical farming, without widely used of earth-based agriculture at present. Conversely, the development of agriculture on Mars may lead to terrestrial application. In particular, growing plants in greenhouses on Mars could lead to a spin-off for similar activity in extreme environments on Earth, which may unfortunately increase because of climate change. More globally, new opportunities for Earth-based business application may arise. For example, the optimizing of food production with sustainable agriculture for increasing population. The possibility of terrestrial application combined with the importance of the topic for future space settlements demands that food application. Please, thank you. Last but not least, we would like to comment that 19 team project participants for 10 countries for their enthusiasm, motivation, and hard work. The participants brought with them a diverse and rich perspective. In addition, we are very grateful for the invaluable support provided by the University of Granada, the International Space University, and the many sponsors and visiting lecturers of our team project. Enjoy this wonderful presentation. Thank you so much. Thank you, Francois.
Hello, everybody. Can you hear me?
Yes, of course.
Great. Thanks a lot. Thank you very much, Vanessa, for your very nice words, which I completely subscribe to. If I may add a few more words on what you just said. First of all, it was a pleasure to work with you, Vanessa, and to work with our associate faculty member, Anderson, and with our assistant, Jorge. So we were a very nice team. But the biggest pleasure was to work with the 19 participants coming from all around the world. What we have been able to see with Vanessa and everybody is that there was a very good team spirit, that the students, the participants were very motivated, very interested. There were good exchanges in this team project. We tried with Vanessa to offer a good mixture of lectures, professional visits, interactions between the participants and us. All together, it was really a nice time that I think all of us spent together. And it's our pleasure now to introduce the participants, the TP participants, to present their work on agriculture and nutrition in a Mars settlement. Dear participants, the floor is yours.
Thank you so much. Thank you.
Humankind is driven by a sense of curiosity, inspiration, and by the long-term survival of the human species to search for other planets that can sustain life.
Welcome to the Mars edition of the Early Night Show. It's my pleasure to introduce to you our wonderful hosts, Divya and Patrick.
Welcome, welcome, welcome. It's August 26, 2041. And guys, we've made it. You've made it. Thank you for tuning in. We have a band here for you. And although I have just arrived here, I must say that you're the best audience we've ever had on our early night show. Let's applaud this. Well, I must say that tonight is your lucky night because we have something special for you. Our entire show is fully dedicated to human agriculture settlement on Mars. Sounds exciting, right?
It does indeed, Patrick. Shall we get the show started?
Let's kick it off.
So welcome, everyone. P and I were talking earlier, and we were discussing this whole Mars settlement business, and we thought, is it really possible? And you know what? I'd really like to know a lot more. How about you, P?
Well, I don't know about you, Dee, but I'm quite skeptical about it. Is it really feasible?
Oh, well, that's why we're here today. We've got lots of experts on the show. We're going to speak to the Mars 100 settlement, and hopefully we'll find out a bit more and get our questions answered.
I have to say, it all sounds quite science fiction to me. We have first 10 settlers on Mars already, right now. I mean, people, we have right now 10 humans walking on the surface of the Mars. Huh? Let's applaud to this. Yeah, and it is not some strange Hollywood production sort of a Total Recall starring Arnold Schwarzenegger. Well, however, I'm a little bit not convinced if we technically are prepared to have 100 settlers on Mars. And do we actually need to have that many humans over there? Just think about it. How will we be able to sustain them there? And imagine providing food for all of them. It's not like they can order a takeaway, right?
Come on, P, isn't that a bit cynical? Why don't you believe a little? You know, great things can happen when you believe. We've been sending rovers to Mars for decades. Technology has really advanced, and we understand the Martian environment a lot better as well. And I don't think we're too far off. We sent a golden record in the 70s, and we're currently planning to send the next one, which is called the Earth's Eternal Echo. So there's a lot happening in space exploration.
Yeah, I agree. I suppose that most technologies, they seem impossible before they are released. So just take a look at how advanced our smartphones are these days.
Exactly, P. I'm hopeful that we're going to turn you into a believer tonight. And well, on that note, we've got some fantastic guests on the show, lots of great clips, and a lot of fun, all supported by science. So let's get started.
Whoa, hang on a minute. Did you just put fun and science in one sentence? Well, before taking our tractors to Mars and plowing away, let's find out more from our expert. Our first guest to the show is Leonardo DiCaprio of science. Please welcome Zarya. Can we have a round of applause, please? Hey, Zarya. Please take a seat.
Hello.
Welcome, Zarya. How are you today?
I'm doing great. Thank you for having me.
Thank you for joining us. I'd like to start with a question that I have. So can you please tell us what's stopping us from packing up our cows and starting a farm on Mars?
There's a lot of issues, really. So first of all, we all know that the time to get to Mars is at least 6 to 7 months. So you have to think, how are you going to keep a cow in like a space shuttle for that much time? You have to feed it, and obviously in this much time, it's going to grow as well. And obviously space is very scarce and there's rocket ships, so we have to think about all these things. And considering the weight of the cows as well, we have to realize, are these really the most efficient way to get food there? And then on top of that, we have considerations like radiation, what are the effects on the cows under microgravity? And all these questions are really unanswered. And honestly, we have much better alternatives as well that we can look at.
Hang on a second, Mr. I Know It All. So what should we take instead?
Okay, not to get too scientific with you, P, but we have to look at a ratio called the FCR, the food conversion ratio. So this is essentially how much meat we can get based on how much food is required. So for example, for 1 kilogram of cow meat, they need 10 kilograms of feed. So as I said, the resources on Mars are very scarce, so this is hard to do. Whereas on the other hand, I propose that we use fish, yeast, and insects. So insects, for example, you only need to give 1.75 kilograms to get 1 kilogram of protein, and that's 10 times less. And that 1 kilogram of meat has twice as much protein as the equivalent one for cows. And then if you combine all these three systems, aquaculture with the insects and the yeast, then they all work in symbiosis and they don't compete for resources either.
Wow, he really does know his stuff, doesn't he?
Yes, he does.
So shall we now look at the interviews with 3 of the first Martian settlers?
Yeah, that sounds good. As you know, there's a delay between Mars and communication delay. Therefore, we have asked the 3 settlers some questions before the show. And I've just got the information from our producers that the answers came in. So let's roll the clip.
Well, due to the international and intercultural nature of the Martian settlement, we've asked our settlers to speak in their mother tongue. Our first question was to Coco de Boer from the Netherlands. We asked her about the Martian environmental conditions and how it's possible to have agriculture and biodomes on Mars. So let's hear what she has to say.
Dank jullie wel voor de vraag. En ja, in vergelijking met de maan biedt Mars zeker meer mogelijkheden als het gaat om grondstoffen in de bodem en in de atmosfeer. De atmosfeer bestaat namelijk met name uit CO2, wat kan worden ingezet voor fotosynthese van planten of micro-algen. De atmosfeer bevat wel erg weinig stikstof, maar met een specifieke biotechniek kan de stikstof uit de atmosfeer worden gehaald en worden omgezet in een kunstmest. Daarnaast bevat de bodem veel silica, Wat anders is dan op aarde. Bepaalde microalgen gedijen gelukkig juist goed in zo'n omgeving. En deze microalgen zijn een belangrijk onderdeel van ons agrarisch systeem. En last but not least, het water op Mars bevat veel zout. Na een bacteriële behandeling kan dit echter worden ontwild en ofwel direct worden ingezet om marine organismen te kweken, ofwel worden geïntegreerd in het closed-loop agrarisch systeem. Dus nogmaals dank voor jullie vraag.
Thanks, Coco. Well, thanks for your great insight. Well, Zaria, as you probably know, my scientific career ended in 5th grade or something like that. So do I understand correctly? We need to create some specific conditions to grow plants on Mars. Is that right?
That's absolutely correct. That's just what Coco was saying there. So the environment that we have on Earth is very different from the one on Mars, but fortunately we can apply relevant biotechnologies to recreate this environment in an enclosed dome or biodome on Mars so we can grow our crops there.
Well, great. We have also asked another settler, Melody Green from Israel, about the different crops that are grown on Mars in the biodomes and why they were selected. Let's see what she has to say.
En deze microalgen deelt en ofwel
כשמתחילים לתכנן את הפן החקלאי, חשוב להבין קודם כל מה המטרה שלו. בפרויקט הזה, הכוונה שלנו הייתה לספק קודם כל תזונה הולמת לאסטרונאוטים שחיים במאדים. בגלל זה היה חשוב שנתייחס קודם כל לערכים התזונתיים שהגידולים מספקים. האם תכולת האנרגיה שלהם תתמוך בפעילות אנושית לזמן ארוך. אלמנטים נוספים שלקחנו בחשבון זה למשל הצרכים השונים של הגידולים, כמו נוטריאנטים, דישון, תאורה, טווח טמפרטורות שמתאים להם והשטח שהם תופסים בכלל. חלק מהגידולים שבחרנו זה למשל חומוס, תפוחי אדמה, פולי סויה, בטטות, דברים שהוכחו שמתאימים גם עבור אספקה של תזונה מתאימה לאסטרונאוטים וגם שמסוגלים לחיות בתנאים שאנחנו מספקים שם. חשוב לציין שבשלבים הראשונים של המושבה שלנו אנחנו הולכים להשתמש בסופרוויד, זה בעצם מינים עליים מאוד אגרסיביים עם זמן מחזור חיים קצר מאוד, שבכדור הארץ הם לפעמים נחשבים בעייתיים, אבל הם הוכחו כמתאימים לשלבים ראשונים בהתיישבות באיזשהו גרם שמימי, לכן בחרנו אותם גם להתיישבות שלנו במאדים. בשלבים מתקדמים יותר של המושבה שלנו אנחנו הולכים להשתמש במערכות גידול שונות כמו מצע מלאכותי, גידול הידרופוני, לספקטרום מאוד רחב של גידולים.
Well, fantastic. Thank you, Melody. Well, as you can see, we have technology advanced that much that we can send humans to Mars, but we haven't figured out everything on Earth yet. Z, would you like to add anything to this?
So yes, like Melody mentioned, there's actually a lot of considerations when it comes to selecting the appropriate crops. So as well as the nutritional requirements, we need to consider some other requirements as well. So like I mentioned before, we need to be very efficient with the space that we're using. So we need to pick plants with a very high calorific content for the volume that they take. And then on top of that, we want to have a diverse range so that our astronauts don't get bored of the food they're eating. They need to have a bit of biodiversity, you know? And then last but not least, we need to have lots of crops so that we can satisfy as many vitamin requirements as possible as well.
Thank you, Zaria. It's true, I get bored of food quite easily as well. So last but not least, we have spoken to our aquaculture expert from France, Cyril
Barbon.
Thanks, P. About how it's possible to have fish and shrimp on Mars. So please, let's take a look at his answer.
Bienvenue dans le centre d'aquaculture martien. Notre question est comment est-ce qu'on peut nourrir les poissons dans cette base martienne? Eh bien, nous utilisons deux types de ressources. Des ressources qui sont élevées sur des ressources locales et puis des ressources qui sont élevées sur des déchets de l'agriculture de la serre martienne. Alors, quelles sont ces ressources? En premier lieu, il y a les bactéries, les cyanobactéries, ainsi que les algues, qui vont pouvoir nourrir les poissons. Et ces organismes-là sont cultivés à travers l'injection de CO2 atmosphérique ou d'azote atmosphérique, ainsi que le silicium issu du régolithe. Ensuite, nous avons deux types de nourriture pour les poissons qui sont produites dans le système fermé. Il s'agit des levures ainsi que des insectes. Ce sont deux organismes qui sont nourris avec les déchets de la serre, c'est-à-dire des feuilles, des tiges, ou alors des fruits qui sont pas matures ou qui ont pourri. Ensuite, nous avons une troisième source, et cette source-là, ce sont des vers. Ces vers servent à quoi? Ils servent à recycler les fesses des poissons. Et les poissons sont très friands de ces vers-là, puisqu'on leur redonne vivants, ce sont des proies vivantes, et ça marche très bien. Et enfin, la dernière source, ce sont tous les restes des cuisines, des repas des humains, qui sont directement donnés aux poissons et aux crevettes. Alors ici, l'ambition, c'est de pouvoir donner 2 fois par semaine un filet de poisson aux membres résidents de la base de Mars, ainsi que 4 crevettes. Et nous sommes très heureux de constater que ce système martien, aujourd'hui sur Terre, vous l'avez appliqué, vous l'utilisez, et ça permet de préserver la nature, l'environnement des déchets, mais ça aussi, ça implique l'augmentation de la sécurité alimentaire sur Terre. Ici Mars, à vous la Terre.
Thank you for your insights, Martian settlers. It's really exciting to see the first 10 settlers have landed on Mars and that the agricultural system is up and running. It seems to be quite promising, doesn't it, P?
Well, yes, indeed. I must say it is a little bit mind-blowing to see and hear the Martian settlers themselves. It is starting to feel quite real right now. So Zaria, the future of the Martian agriculture is looking bright, is it not?
Yes, the developments are super exciting. I can't wait to see what's coming up in the future. And I hope we managed to convince you that it's not as unfeasible as it might seem, P.
I think we're getting there, Zaria. Let's give Zaria a big round of applause. Thank you so much. Now, you may have seen our next guests on the popular quiz show, Space Brains. They battled out a tough finale some years ago in the space agriculture themed series, and they've begun working together. Before we introduce them, let's watch their TV debut again.
On the finale of Space Brains, our host Selene quizzed our 2 finalists with 8 space agriculture questions, with the winner set to take away the coveted space sailor. Our first finalist is Carol Sparrow. She's an ambitious space enthusiast who loves a challenge. When she's not cold water swimming, she likes to run marathons backwards. Our second finalist, Toju Crow, is a sweaty, sleep-deprived engineer with way too much student debt and space agency merge. If space engineering doesn't work out, he wants to start his own restaurant. Before the game, the finalists get in the zone. Each takes a moment to breathe and focus. With so much at stake, the pressure was on. By the end of the game, someone would be walking away with the space sailor. When the game finally begins, Carol races into a strong lead.
Question 1. Name 5 types of data relevant for plant growth, which sensors acquire.
pH level, electrical conductivity, relative humidity, light intensity, and water temperature.
And let's go on to question 2. Martian regolith contains toxic elements such as perchlorate. What is the preferred technique for detoxifying this regolith?
It's a biochemical process using enzymes which detoxify the process's perchlorate into breathing oxygen.
After a first half massacre, Carol was 4-0 up and feeling good. She could taste her opponent's blood, and it tasted amazing. Meanwhile, Toju was feeling the pressure. He was 1 question away from losing it all. He needed a miracle.
Question 5. Combining detoxified Martian regolith and compost from organic waste to create plant-friendly soil is an example of
in-situ resource utilization.
And correct! Question 6. How can insect powder obtained by either wet or dry milling techniques be integrated into cuisine?
Got this. 3D printing.
Correct again! Excellent answer. And that's a second point for Toju.
Soon, he was within touching distance of Carol. After another correct answer, the game was 4-3 with one question remaining. Carol couldn't believe what had happened. A miracle had happened. Toju was back in it. He'd come so far and could tie the game with the final question.
Toju, Carol, question 8. For 100 or more people settlement on Mars, what power source will be most relied on? Carol.
Tough question. Solar power?
On the last question, Carol incorrectly suggests solar power as the most relied on power source for a Mars settlement. Toju had the chance to tie the game, which he does.
Is it nuclear energy?
That is the correct answer!
After a frantic game, the finalists shared the Space Sailor Prize, and with it, the opportunity to design an interplanetary agriculture system.
Well, some truly interesting minds. Space Brain is my favorite TV show. By the way, someone should tell this guy to invest in a deodorant.
I agree.
Well, you know what? We have a little surprise for you. As a matter of fact, we have them backstage. Shall we bring them on? Well, please welcome to stage Carol, Sparrow, and Toju Crow. Well, welcome to both of you. Great to have you here. Tell us, when you met on the show those years ago, did you expect to be working together this long afterward?
Hi, it's so great to be here. And you're absolutely right. Back in those days, we were rivals, opponents, but we had deep respect for each other's knowledge.
Well, it looked like it got quite hot and sweaty, quite intense. I would not have liked to be one of those opponents, but it looks like you've managed to build a professional partnership out of this.
Yes, most definitely. Since then, we've gone on to really go into design and making some really cool concepts for space agriculture.
Well, great stuff. Speaking about the design, we actually have one of these, I believe. Well, this looks pretty complex to me. Can you walk us through it?
Yes, well, as you can see, we fully agree with our scientists. We think there are just so many benefits and we need to have fully integrated systems. There are lots and lots of benefits of having different cultivation techniques. As engineers, we think the most important for one is just redundancy. In case of failure of one system, we want to be able to have backups in other systems.
Toju, what do you think about this?
Exactly. And one of the key concepts within this, as you can see here, is vertical farming. So this maximizes the efficiency of space and resource use. And within this, we propose two solutions for our plants to be held in. One will be soil, which will be a combination of Martian regolith and biomatter left from the human habitat. And the other will be hydroponics, which holds the plants in motion, and then the roots are treated with nutrient-rich water when they're needed. As well as this, as you can see, these are benches here, and these will be automated, so they will come to the farmer when necessary for harvesting. And you'll also see the LED lighting. As you'll know, on Mars, there's not much sunlight, and dust storms can cover the land for long periods of time, so you won't get any light at all. This LED lighting will be perfectly pitched for the plants as necessary.
Wow, that sounds really interesting. And what's that beautiful image to the right, though?
Well, I'm glad you asked, Divya. That's actually one of our novel concepts that we proposed. In essence, what we're trying to do here is emulate as much as the Earth gravity as possible with a kind of a centrifuge structure where the spiral will rotate round and the plants will be subject to lighting as well. So it'll go through like a night and day structure as they would on Earth.
This looks pretty complicated to me.
Mhm.
Can you, Carol, elaborate?
Don't worry, of course I can. You know, we think these biodomes are going to be very relaxing, probably, and a lot of settlers, I think, would quite enjoy having a stroll, you know, amongst the trees and the fishes, but actually they'll need to be working. They can't all be farmers. And so we really, really want to make all of our systems very automatic. And to have that, we're going to deploy sensors throughout our crops, measuring all of those important variables we talked about in our show.
Yes, and to begin with, we'll start with local systems using Bluetooth connectivity. And then once the infrastructure is in place, we can start to introduce internet. And within this, we can use big data analytics so that all the sensors Carol mentioned can come into one place, be analyzed, and then through feedback loops, we'll know what plants need attention and how much attention they need.
So now we get to the crunchy side of things.
Yes, well, as you saw in the first loop, one of the very big aspects of our agriculture is insect farming. And we plan to focus first on black soldier flies. They already show quite promising results here on Earth, and not using only the flies themselves, but the larvae. Now, as you can see, there are quite a few steps to process them, but the end result that you get is a very fine powder, and that can be used for 3D printing. And with that, you can make very complex geometrical structures. You can supplement and really have tailor the nutritional needs for your settlers. You can add, for example, essential nutrients from yeast and create these beautiful structures. And then the next step beyond that, that's even more interesting, is using 4D printing. And you could have, for example, self-replicating tacos or sushis.
Wow, wow. But insects, really? What happened to the old beef cheeseburger?
Well, actually, a lot of people are already actually eating insects on Earth today in many different communities. And there's many ways you can prepare them. You can roast them, ferment them, marinate them, smoke them, all with different flavors and textures. And for those meat lovers that can't resist a cheeseburger, we propose the use of bioreactors to create meat-like products with cultured cells as well.
I'm not sure I'm convinced about this whole insect thing. I never thought you'd put insects and tasty together. But what about radiation? I thought this could be quite dangerous.
You're completely right, Divya. You know, Mars just isn't as lucky as the Earth. It has a very thin atmosphere. It has no magnetosphere. And so the surface just gets pounded by radiation. You have ionizing radiation, so that's your solar particle events, your galactic cosmic rays. And you have the non-ionizing radiation. You might already have heard about ultraviolet light, UVBs.
Well, I could talk about it for hours, but I'm not so sure about our audience. So can you tell us a little bit more about it?
Of course. So ultraviolet radiation is obviously not great in excess, but we propose for the plants at least passive radiation shielding. This itself could be maybe 20 centimeters of water around the structure that the plants are in. Unfortunately, this wouldn't work for humans. And for that, we propose more research that's already going on actually into simulating like the magnetosphere and the electromagnetic fields around Earth with very large magnets. So there's some really interesting research there.
Wow. So this looks like quite a big structure, what we are seeing now on the screen. So how are you going to power all of these?
Well, yes, that is the next big question. You know, having all these structures, all these different cultivation techniques will require a lot of energy. We'd like to use solar power, but you just can't rely on that on Mars. You know, it's just too far away from the sun. There's also sandstorms, as you've heard. And so you need a backup, really. Solar will be your backup, but you need something more reliable than that. And we propose to build on nuclear energy projects such as the kilopower, so using nuclear fission and Stirling engines to generate the electricity that we need.
Oh, sounds like you guys have thought about everything. It's very, very interesting, and it sounds like it could all work. So we'd like to thank you today for being on the show and informing all of us about this. And we're going to take a short break, and we'll join you after the break. We're going to hear about the weather on Mars. Maybe it's a good time to plan your holiday. So we'll join you after the break, and another round of applause for Todju and Carol, please.
Welcome to today's Martian weather report. We have had a chilly morning with temperatures of minus 19.7 degrees Celsius. The forecast for the afternoon looks great. With temperatures of minus 6 degrees, it looks like a warm day on Mars. However, with radiation levels being extremely high this afternoon, it is strongly advised to stay inside the habitat. We also have an incoming sandstorm, so once again, please stay inside and enjoy a good Martian meal. Thank you for watching today's Martian weather report. Have a good day and see you tomorrow.
Now new in the spacebar, 3D printed cookies with real insects with new flavor. Open from sunrise to sunset in the habitat Oscar. Come along!
Okay, let's get down to business. Please welcome onto this stage our expert on financial and legal aspect, Lydia and Bastian.
Hello, welcome, Lydia and Bastian. Thank you so much for joining us on this very special edition of the Early Night Show.
Hi, DMP. It's actually our pleasure to be here again.
You believe it or not, but the both of you were here on this very show 20 years ago.
20 years ago? Oh, wow. Time flies. Yeah. Wow.
Well, as a matter of fact, we have a little surprise for you. Please take a look at the clip. Hello and welcome back after the break. Today I'm here with my friends Lydia, Johannes and Bastian, and we will be playing a game of word charades. Since myself and Lydia, we have the same stylist, who also happens to work here as a stage decorator, we will be team number 1, you will be team number 2. The rules of the games are as follows. Each player has 30 seconds to guess as many words as possible based on the clues given by your teammate. Whoever gets the biggest number of words right wins. Simple as that. Shall we start? That's it, partner. Let's go. Let's go.
Okay. Cost per meal per settler by plants and insects.
Plants and insects.
Yes.
This is what they are going to eat?
Yes!
My goodness. 230,000 euros.
Oh, yeah.
That's it.
Provided by governmental agencies, but also the private sector.
Money,
No,
resources,
yes.
funding.
Yes.
Next one. Come on.
Cost per meal per settler, but when you count plants, fish, and insects.
Ooh, like VIP. 300,000. 350.
More.
420.
More.
500,000.
Oh, nice.
Wow, great job.
Yeah.
Great job, partner. Okay, look at Johannes is very calm. Very calm. Okay.
It's a legal term for not being able to own the land on Mars.
Ooh, that's difficult. Non-appropriation.
Okay.
It's the cost of the cheapest nutritional meal per settler.
300,000.
It's a little bit less.
270,000.
So what do you call a system that you use in emergency?
Airbag.
And also you can use it for additional business opportunities.
Ah, the redundancy system.
Perfect. That was
Do you want to buy a new car?
What you call the harmful thing that you're not allowed to do.
Time's up.
Contamination.
That's
the count.
Okay.
You got
Good
this.
job, Bastian. Okay. I'm watching you guys. Okay, Lydia, are you ready?
Yeah.
You've got this. We've got this, huh? We've got this. Just win. Okay. let's start. So the cost of the development and production of the agriculture system
500 billion?
for 100 people on Mars.
400 billion?
Less.
200?
Yeah, more or less, 200.
Okay, great.
Okay, tell me the title of the first international agreement that governs outside the Earth, that governs the cosmos.
Outer Space Treaty.
Fantastic! We're on fire. Yeah, the person who is sent to the space.
A human being?
Okay, yeah, according to the Moon Agreement, the person who is on the Moon. Yes!
Yes!
You got this!
Yes!
Woo! Okay, Johannes, you go last. Okay, let's see.
Do I even have to go? All
I
right.
think it's a win. I think it's a win for us.
All right, we will start in 3.
Okay, Bastian, you ready?
1, and go. So, what do you call the authority that applies the law?
Jurisdiction.
Yes. And how much does it cost per meal per settler, plants and fish, no insects?
300,000? 350? 370?
Yes! And what does the state need to do in order to get stuff in space?
Register the object.
What's the planet called we're going to?
Mars.
What are we, when we get resources on Mars, what could we do for that?
Insecure resource utilization.
Yes, correct. And
Someone's on fire!
Did I hit the button? Oh, I think that the alarm went
the alarm
off.
went
Ooh. Well, great job. Whoa, okay. I see. Okay, great job. I think that we can all conclude that this is a tie, so we are all the winners. So thank you very much, and see you just after the break. Well, this is pretty embarrassing, isn't it? Well, folks, this footage was taken 20 years ago, and I'm looking at you, and you don't even look a day older. I'm still trying to figure it out. What is your secret? And believe it or not, I'm still having this jacket in my wardrobe.
Oh, and Pete, you're quite competitive, aren't you? It looked like it was really hard for you to say that it was a tie. So the mission is successful. There are 10 Martian settlers on Mars. Back then, what were your biggest concerns?
Yeah, from a legal point of view, we had a lot of issues to address because there was no framework yet on Mars. So for example, we had to figure out how could we place the biodomes on the Martian surface without appropriating the land. We also had to figure out, are the settlers living on the surface of Mars actually called astronauts or not, and the rights and obligations that come with it. And we had to get approval for the nuclear power plants that provide the power on Mars. So to solve some of those issues, we've actually implemented a multilateral agreement between all the interested parties.
It's more complicated than I thought. Lydia, what's your take on it?
Yeah, for us, mainly, we just needed to figure out what are even the costs of the whole agriculture system and who is going to pay for it.
Well, I hope it is not coming out of my pocket.
Well, I'm sorry to break it down to you, but it kind of is. It was because we wanted to establish the professional relationships between governments, between space agencies, and also private actors. And we saw how in the new space era back then, how it triggered the development in space technologies. And we kind of established that. And what we were even able to do was to provide additional business opportunities with the redundancy system. So isn't that great?
It really is. Patrick, you might have to stop spending so much money on these lovely suits. So Lydia, Bastian, thank you so much for joining us on the show tonight. Can we give them a big round of applause, and we'll be back right after the break.
Okay. Well, can we have the light on? Yes, thank you. So far, we have seen how this Martian biodome looks like, and we've been told how humans can cultivate crops and food on the red planet. Now, I don't know about you, Dee, but all these talks about food is making me hungry.
Doesn't take much to get you hungry, P.
No, it doesn't.
But lucky for us, this evening, we have with us a universally acclaimed Martian nutritionist and award-winning director, Peter Chai. We welcome him on stage, please.
Peter, welcome to the show and thank you for joining us. Now, just to start, can you tell us what are the key considerations for the Martian diet for humans?
Well, Patrick and Divya, thank you very much for having me on the show. It's quite an honor to be here. So, considerations for diet. So, firstly, on Earth, we'd like to consider all the nutrients, all the vitamins, minerals, and making sure that it's in a well-balanced, healthy diet. Now, when it comes to Mars, this becomes even more paramount, and other considerations get put into play, like food psychology and crew morale. At the end of the day, you could feed them a perfectly balanced, nutritious diet through supplements and things like that, but it might hurt crew morale, affect performance, and at the end of the day, that could cause dangers and affect safety.
Wow, I didn't even consider the psychology of food. So Peter, you've done a lot of research on nutrition and what the Martian settlers should be eating. And I hear you've made this into a fantastic show called The Martian Chef. Lucky for us, we'll be premiering your show tonight on our early night show. So let's not keep the audience waiting and let's roll the show. Thank you.
Across the seas, from continent to continent, we've lined up some of the world's best chefs and given them a challenge to create an extraordinary dish to send to Mars, and hopefully say their names in culinary history. We have 3 chefs. Lucas Wallace, one of Germany's youngest Michelin-starred chefs. Then Celine Irwin, an award-winning chef from Australia, known for her fascinating outback dishes. And finally, Maria Hart, one of Europe's most experienced and well-known chefs. Now judging them will be the esteemed, award-winning Shane Curry, one of the world's most renowned chefs.
Oh, hi there. My name is Shane Curry, and I'm an award-winning chef and entrepreneur. It's my pleasure to join you guys here today on this episode of Martian Chef. We've come here today to see what could be the next feasible Martian cuisine. We got 3 award-winning chefs joining us today who are going to cook us a variety of dishes, and let's hope that they're great, and we'll see where that takes us. Let's get to it.
I'm really excited to be here today. Today is my big chance to woo Chef Shane and show anyone that you can achieve your dreams. I hope whilst he is eating my meal that he loves it as much as I do.
Welcome. Tonight I've tried all your dishes, and I gotta say, I've been both amazed and disgusted. I'm not sure if all you guys are all show or all substance, but tonight we're gonna find out. Lucas Wallace, what do you have to say for yourself?
Thank you very much for being here on this show today. I've done some research in common issues I think the other chefs have forgotten, and that's why my meal is out of the most nutrition rich, the most useful foods I could find, and I combined them together to one beautiful meal. That's the one you just had. It is out of insects and yeasts, as they have a lot of proteins and a lot of essential vitamins like vitamin B6, vitamin B12. Also, this food is very easily to be cultivated on a Martian settlement, and they are the most sustainable foods you can get for a long-term duration on Mars. So I hope you liked it as much as I did.
So, I just came from the back trying your food, as you know, and I gotta say, it really stuck out to me. Unfortunately, it's for all the wrong reasons. I would have hoped that you would have taken into account the psychology of the food, but it's clear you did not think about the settlers' mental health whatsoever. It was, quite frankly, horrific. It looked and smelled disgusting. You need these settlers to be able to eat this long duration and not be able to affect their performance. When I tried it, a cockroach crawled off my plate. It was still raw!
But that's the research I've done.
Absolutely ridiculous. Was this some sort of joke? Were you trying to be funny? You know, people's lives are at stake here. Bloody hell, the future of humanity is even at stake here. You can't just shove supplement powder into yeast and serve it on a plate every day. What are you trying to be funny? What you really need to do is take into the account the psychology of the settlers. You need them to perform. And eating this every day, I don't even want to look at you. I don't even want to see your dish, let alone eat it every single day. Get out of my sight.
Now, Lucas had forgotten to research basic food psychology. Most settlers would not be comfortable eating insects every day, regardless of their nutritional benefits. The taste and texture of them would lose appetites and eventually lead to starvation. Stress would rise, and then the settlement would eventually descend into chaos and collapse. Now, let's hope our next chef, Celine Owen, can do a much better job for our Martian settlers.
I've been following Chef Shane since I was a young girl. I love his unique food and his Canadian cuisine. I really hope when he tastes my dish, he will be like, oh, cracky. And then I hope to be the next Martian chef.
Good day, Chef Shane. Oh, such a huge fan. I'm really excited to be here today.
We just came from the back room trying your dish. And why don't you tell us a little bit about what you made for us today?
Yeah, absolutely. So my dish, it was a healthy and fresher plate that could fit a wide variety of diets and easily made from the crops they're cultivating in a Martian greenhouse. So it was a vegan dish made with rice, a variety of veggies, with balsamic reduction and seasoned with pepper and salt, just to brush up all the flavors. Yeah, really hope it was pleasant to taste as well as to look at. And oh yeah, on another note, it contained no unethical animal byproducts. So yeah, really hope you enjoyed it.
Wow, thank you for that explanation. Now before we get started, I must say your dish looked a lot better than Chef Wallace's, and you had some actual real food on it. That being said, it didn't stand out to me. You really came all this way to the show and made a salad? A salad? Do you really want our settlers to slowly grow weaker and die from vitamin deficiency? There was no protein at all. And why on Mars did you add a balsamic reduction? Do you want them all to collapse and blame you for ruining $1 trillion international habitat? Also, why was there so much spinach? Have you ever had a kidney stone? I wake up and pray every single day that I don't have a kidney stone and I have access to hospitals. They have no medical supplies and no medical intervention if they get a kidney stone. Think of the bone loss. Do you really want to eat this every day and survive on Mars? I don't. There was so much more you could have done with this dish. You're such a disappointment. Salad.
Unfortunately, Celine focused on flavors instead of practicality. Her dish lacked protein and adaptability. Eating this every day could have caused kidney stones and led to bone loss due to the high concentration of oxalate in the spinach she put and due to the low gravity. The thought was there, but it lacked execution. Hopefully, our final chef, Maria Hart, is the most experienced. Let's hope she brings out the best dish.
I've come here to prove that I've got it. For me, my dish was an art piece that I carefully crafted. Shane is a world-renowned chef, so I hope he sees talent when it's right in front of him.
Welcome, Chef Hart, to the Martian Chef. Before we get started, why don't you tell us a little about your dish?
Hello, Chef Shane. I'm really honored to be in a show here today and have focused my dish on an adaptable and tasty way for our settlers to eat. So it's basically based on a variety of different vegetables from our Martian greenhouse, such as cabbage, potatoes, sweet potato, onions, tomatoes, and especially fresh lettuce. And together with that, you can have rice and or quinoa topped with peanuts for the perfect crunch, arranged in such a way that it looks like a piece of art, and most importantly, fresh fish. These will provide the settlers with all the vitamins and nutrients they will need, in addition to the protein and omega-3 fatty acids that's provided in the fish. So, and instead of just sticking to any ingredients that are non-exchangeable or unexchangeable, I actually made it as such that you can change it, and it's very adaptable and super tasty for the settlers for the long run. So I really hope you enjoyed it.
Chef Hart, having tried your dish, I just have one thing to say to you. Wow. Wow.
Oh,
it was
why
incredible.
Somebody understands me.
So far, it was much better than the other dishes, and it's good to see somebody thinking about what really matters. Your dish had exactly what we are looking for here today. You had protein, carbohydrates, vitamins, and you took into account the psychological aspect that the settlers are going to face on Mars. You had exactly what we were looking for in all of the categories, and it has been a pleasure to try your dish today. What I want to tell you is that congratulations, you have just won Martian Chef. Now wait here, one sec, we have something to give you.
I can't believe it.
Chef Hart, please remove your hat.
Thank you.
Congratulations on winning Martian Chef.
Finally, someone had done it. Maria used her experience and knowledge and created the perfect dish to take to Mars for our settlers. And with that, we found our first Martian chef.
Stupid salad.
I can't believe it. I won the Martian Chef. That somebody saw my talent is incredible, and I can finally prove that we can have a nutritious and healthy meal on Mars.
Well, as you can see here today, from those dishes that we experienced on screen, creating Martian cuisine is very difficult. A lot of considerations have to go into making sure the settlers can survive with the adequate nutrition, vitamins, as well as taking care of any potential health and safety issues, as well as psychological issues that arise with the taste, texture, and smell of those foods. It's a very complicated business, and hopefully we came up with a feasible solution. So I just want to thank Chef Hart for her amazing dish today, because it is a great contribution to the science of a future Mars habitat. Thank you.
Wow, OMG. Do people still say that? This was fantastic. You're a legend, and Chef Shane, well, he's just the best, isn't he? It is an honor to have you on our show, so people, please give him a well-deserved round of applause. I feel a certain connection with Chef Shane. I mean, I really like his bluntness and the way he crushed the chef's dreams.
Well, P, I'm not surprised you feel that way, but I think Chef Shane really doesn't hold back, does he? But maybe you're quite similar. You might get along, I think, perhaps. Yeah, and I would not want to be presenting to Chef Shane.
I see some best friend material for me on that.
I think so. Someone needs to cheer Chef Shane up with some good food, I think. So there were some really fantastic chefs on the show, some absolutely amazing meals presented. Peter, can you tell us when the next show will be out?
Well, thanks very much. Hope everyone enjoyed the show. Just to know, Shane found it really difficult to be nice to Maria at the end, so he tried his best. For the next show, we got great feedback from our Martian settlers when they tried the dishes, and they really enjoyed it. So we're filming the new season right now, and when it will come out, well, that's a secret. Thanks very much.
Well, thank you again, Peter. Thank you very much. It's been a pleasure to have you on the show.
So, folks, we hope you're ready for the final part of the show.
Yeah, let's welcome our terrestrial application expert, Sarah. Hey, Sarah, it's great to have you on the show. Thank you for joining. We've been told that you've been working on a very interesting project that will be debuting today. Is this right?
Hi, B&D. Thank you so much for having me at the show. And I think it's the second time me here. Well, yes, as you were mentioning, today I really want to show to you and the audience a documentary or a clip of it that I produced together with Jules Lancet. And this documentary is going to be about the benefits that the permanent settlement on Mars would have on Earth.
Well, we are all
We are all excited and very privileged to be the first one to see it. So without further ado, let's roll the video.
When humans invented farming, the planet was different from the one we know today. Today, as a result of our lifestyles and actions, we live with the consequences of climate change. Some of us are strongly impacted by such pervasive changes. Migrations, starvations, desertification. Our planet is different indeed. Since the invention of farming, we have learned how to dance with the seasons to produce food crops. What has followed, as we know, is history. Even though humanity has come a long way, we still strive for a better world. Let me guide you through history and show you where we are today. In 2016, the United Nations set up a roadmap towards a better future. 17 global goals that form the blueprint for a more sustainable future for all. That future includes the latest global advancements and a new adventure outside of Earth, exploring our solar system. At this moment, only a few rovers roam the surface of the red planet. Going to our nearest habitable neighbor Mars requires enormous technological innovation. Bringing this knowledge back to Earth was challenging as well. This film is our vision of how we will apply our lessons learned from this enormous journey back home. Let's listen to our researcher, Sara Venditti. She will walk us through this new present we live in today.
Can you picture a more sustainable use of land and resources? Let me show you how. Improving our quality of life on Mars is still a learning process. What we know today is that discoveries on health and diversity of food that we grow on Mars will benefit agricultural systems right here on Earth. The benefits will be in terms of efficiency, sustainability, and equality. Can you picture it now? I can.
Now that you can picture what Sarah has envisioned, let's zoom on us, humans, and our intrinsic need to regulate society and relations, but this time at a wider international scale.
International cooperation has never been stronger, both for humans in space and the ones who chose to be here, like me, on planet Earth. Such a level of unity of nations is fostered by treaties and agreements, and it is a direct consequence of a joint effort to develop the permanent planetary settlement we have right now on Mars.
And indeed, going to Mars requires enormous energy and innovation, especially to go back home. On Earth, fear not, dear listener, the pace of progress is unlike anything before.
Innovation in engineering and agriculture on a different planet is providing us with priceless insights for terrestrial applications. Just think about it. Production of clean water, waste management, and efficient land use. This is a game changer for countries with limited access to resources, which are living every day in difficult conditions.
If in the past we had very little understanding of how the living world actually worked, today we know that to sustain life on the red planet, we once again have to look at the natural world and its secretive yet omnipresent organisms on Earth.
Our planet has an immense variety of organisms used in off-world agriculture systems, such as algae, insects, and aquaculture. These organisms are the key to unlock solutions for problems that have accompanied humanity since the very beginning, such as poverty, inequality, and scarcity of resources.
How do we tackle these issues, though? Humans have always been dreamers, and some of them are pragmatic ones.
Let's talk business. Terrestrial application coming from Martian agriculture can be turned into great opportunities. The valuable know-how comes from the development of an agricultural system as complex and diverse as the one for Mars. This knowledge can be introduced to countries that have to rely heavily on food imports to sustain their population. Right now, we have the opportunity to create a better world for everyone.
This is an exciting time to be alive, with humanity taking the first steps to settle outside Earth. The future is promising, and space exploration is advancing at an unbelievable rate. This is the history of all humanity, and of the bright future it will shape for the next generations to rely upon. Today, all we need is the will to achieve so. Can you picture it? I can.
Wow. All I can say is, David Attenborough, watch out. And Joel, if you're around, I'd like to speak to you after the show. Or more like, yeah, I'll listen to you after the show. So, Sarah, you've heard about the recent protests. Can you tell me a bit more about what you think about this and some of the terrestrial applications from the Martian settlement that are helping towards this?
Yeah, sure. Well, we're all aware that such an ambitious space activity is very harmful for our planet's atmosphere. And let's think simply about launchers and the CO2 emissions. I think we're all aware of that. What I strongly believe in is that as a space community, we do have the duty to look for alternatives, greener, more sustainable ones, in order to fight climate change and not to accelerate it. And to your second question about terrestrial applications, well, as we saw before in the show, we do have solutions like waste management, closed loop, and vertical farming that could be applied to countries on Earth that have very limited access to resources or very limited farming land, like Suriname, for example. And by simply improving the diet of the populations on these countries, we could have a huge impact on the conditions of life of these people.
Well, thank you, Sarah. It's been fantastic to have you on the show. Can we give her a big round of applause, please?
Well, I don't know how about you, but I did not expect that I would ever say this. I am feeling a little bit inspired by today's discussion and convinced about this settlement. I think it is doable, it is feasible.
That's quite out of character for you, P. I'm loving the positivity, though. I feel quite convinced too, but I really would like to see more settlers on Mars. So let's see what happens there.
Well, and on that bombshell, thank you for joining us. And we hope you learned something, because certainly I did.
Good night, sweet dreams here on Earth, as one day you may wake up on Mars, and that day may be sooner than you think. So thank you again. Can we have TP Agriculture on stage, please?
too. Okay, we were told that we actually don't have any judges here. So we have, I believe, judges online. So yeah, can we take some questions? We're ready. We're ready.
Yeah, hello. Can you hear me?
No questions? All right, we'll be off.
Hey, can you hear me?
Yes, 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 now.
Hello. So I do not have a real question, but much more a remark. Considering that you choose to tell us about the settlement in 2061, I expected a much larger colony than just 1,100 settlers, which of course leads to a lot of logistical questions. So maybe you could explain your choice.
Shane?
Well, we traveled to the moon in 1967, and it's been nearly 60 years since over 60 years since we've been back. So trying to rely on humanity to keep a timeline that you set out many years in advance is not really feasible, for one. And for two, there are a lot of technological issues that get set up and one, need to be researched because we currently don't have a lot of research into human survival on Mars. And two, there's still the issue of significant bone loss that occurs in astronauts when they, even in low gravity, which still anticipated to be an issue, and the other health conditions that would occur that are not solved yet, including the radiation problems that would happen. So there's a lot of technological things that need to be solved before you can have people permanently living there with no hope to return. So right now, we wrote the report with the idea of the technological advances that are expected to occur given in the next 60 years.
Sure. And you don't expect to have this kind of information at the moment in 2061. So I understand your point, but I think we will have a lot of time to do some research and know have a better insight about the life there. But it was a real pleasure to see your presentation. You did a great job as a team, and yeah, congratulations.
Thank you so much. Can we take another question?
Can you hear me?
Yes.
Okay, so my question would be about water as a resource on Mars. So basically, the question is, where do you get the water from? How much water do you need per day? And what is the cost involved with it? Because I saw also the numbers, somewhere numbers for how much a meal costs. And does that somehow take into account water as a resource?
Cyril will answer this question.
Okay, before starting to answer, I want to inform you that I'm on Mars and this is my hologram answer, okay? For the water, you have two kind of sources of water. You have ice water, and it's a problem because you have to melt this water. It costs energy. And we don't know for the moment the quality of the water because there are no samples of this kind of water. And the second kind of water is underground. This is salty water found by the radar Marcis a few years ago. This is a liquid water. We suppose, because we have no sample for the analysis, that this water is highly salty and probably with a lot of chlorate. It's because in our report, we have a paragraph on the water treatment and regulate treatment. It answer your question?
Yes, thank you. But maybe you also have an estimate of how much water you need per person per day from agriculture, plants, and so on. And how much of it is reusable and how much of it would be lost?
Yes, the principle of the closed loop is, of course, that all the water is recycled. Principally, it's liquid water and vapor water. And the closed loop, we try to keep the amount of the water. I think we have something, but I don't remember the number of the needs. But the main challenge, from my opinion, is to melt this water or to pump this water at first. And after, when this water in the closed loop, we don't. We need, of course, to continue to pump and melt water, but this is a closed loop, and water turn with the organism. For example, a dead plant is a source of food for worms or insects, for example. But the water continue to be in the loop in the insects after, and for the human food.
And great job. I really enjoyed your presentation.
Thank you
Thank
so
you.
much. Thank you, Cyril. Can we take another question?
I can go next, if that's okay.
Oh, yeah, sure. We can hear you. Oh, hi.
Hi, everyone. So hello, SSP21. It's fantastic to see all of you again, both in Granada and Strasbourg. Hello, everyone. It's great to see you on stage. So special shout out to my Space Outs crew as well. So many of you are in TP agriculture. So it's very, very early here in Toronto, Canada, but I just had to be here for all of you. And it's wonderful to see all of you delivering a great presentation. First of all, I want to say a big wow. And second, a huge congratulations as well. Very spectacular and engaging presentation. Also detailed final report and an excellent executive summary as well. So I think while I was on site in Granada, I mentioned to some of you that during the TP phase, I often think that the process is the most important rather than the product. But despite all of the challenges and limitations that you had, you delivered an excellent final product, very detailed, interdisciplinary, and ambitious. Nevertheless, I do have a few questions for you. Hopefully you can still all hear me. But as you know, I'm very passionate about space applications and in particular about satellite technologies. I think in Vanessa's chair introduction, she referred to the use of remote sensing. I know that University of Granada has many strengths in drone technologies in particular. Your report addressed many human factors, detailed engineering proposals as well. But I was wondering whether your group considered satellite technologies and what role it would play in developing your agricultural system on Mars. And maybe a couple of hints of what I was thinking about is maybe things like site selection and also applications for precision agriculture. So if you could comment about that, that would be greatly appreciated.
Thank you for your question. And Tojo is going to answer it. So.
Yes, I will. Hi, Suyin. We had considered a few applications for satellites throughout the project, as you mentioned, remote sensing for site location, and also remote sensing for the plants themselves. In regards to site location, we made a few assumptions there due to the fact that the habitat itself, which is not what we were concerned with, we were predominantly concerned with the agriculture. The habitat would likely be one of your main reasons where you're going to be located, and other in situ resource utilization as well. So we assumed we're in a location where it was promising for either agriculture or water drilling and things like that. In terms of remote sensing for plants from satellites, at the beginning of the project, we weren't sure whether we were going to do anything underground or within biospheres, and that was a decision that was made maybe halfway through. So we thought not to explore the satellites for too long, and then once the plants were indoors, we thought we could introduce kind of drones for remote sensing and maybe just cameras around the place. And then we moved on to vertical farming, which has embedded sensors and things like that, which we thought was suitable enough. But we've recommended within our reports for further research into actual remote sensing of the plant vegetation themselves, either with integrated cameras. Satellite sensing is not something that we thought was viable at this stage.
Okay, great response. It's great to hear that your team did consider some of these aspects. Maybe something else to consider is maybe some navigation aspects as well. Because maybe in some of the talks that you've heard about precision agriculture is, and when you're talking about automation, then there may be a role for navigation satellites as well. So just another idea to put out for you. Maybe a very quick add-on question, if it's possible to. I was very impressed with your review of the different limitations and challenges that you have with Mars environment, like reduced gravity, the extreme temperatures, high radiation, and so on. I was wondering wondering that out of all of these significant challenges, and you've listed quite a lot in your report, a number of topics that your project, maybe didn't quite get around to and would love to explore further. And I was wondering if you had more time in your project, which is always, limiting for all team projects. Which topics would you love to tackle next? What do you think are some future directions for your team project?
I think that we might have many suggestions, so who wants to start? Okay.
Personally, from the engineering point of view, the spiral structure that we showed, we didn't get much time to research that, but the idea of essentially a centrifuge that recreates some sort of artificial gravity would be really interesting to look into, because we didn't really mention anything in terms of how crops are affected by microgravity or less gravity, but they are quite gravely affected. So that would be really interesting.
Maria?
So for us, like we mentioned, 3D and 4D printing also food, and we were also wanted to research more into how this may affect also the psychology of humans, how we can change that. What we say is like there's a lot of new technology out there regarding to food and how we can change things there, and we wanted to dip into that and also then see what specific kind of plants we can also change that it actually looks very appealing and still provides all the nutrition that we may need for the Martian people.
Perrin?
Yeah, so yeah, really good question as well. We've got a lot, there's so much we could have done more, obviously, if we had more time. And one thing you may have saw on the Martian Chef earlier was that we talked about a lot of foods, but we didn't really go into future technologies and stuff. That'll be in the next episode, don't worry. So part of that, one of the key considerations we were discussing during the original brainstorm, we were looking at 3D printing foods. Currently, a lot of companies are doing that. There's a lot of really good papers and stuff written on that. We were considering that earlier. That would be something we'd do in the future. Also, from a psychological aspect, there's so many things you could do compared to looking at psychological evaluation, monitoring, and trying to ensure that crew morale stays at the top and performance is kept. So we did some aspects on that, but there's so many future technologies coming onto that. One of the things we looked at was Boeing Sky, with what they do with their passengers. And hopefully, if we did go more into the habitat side, that would be something we'd look at. From the engineering aspects and stuff, like Toju said earlier, we would like to have done more habitat related stuff, but we focus primarily on agriculture and the nutrition side due to the time restrictions. And hopefully working towards radiation shielding would have been quite key, and monitoring the environment, possibly using the greenhouse as part of the closed loop as well. But yeah, I think that's good.
Carol?
Yes, sorry. Again, in addition to engineering, I thought we had a lot of really interesting lectures from University of Granada on drones. We also had quite a bit of fun playing with them. And we felt that we possibly initially had to put that aside because of what we learned about kind of flying in reduced gravity, thin atmospheres. We then thought being in enclosed habitats, we could include maybe mini drones like bees flying around and doing some of this remote sensing. But again, we had some time constraints, but we think that's definitely an avenue to look into.
Shane?
There was another topic that we discussed a lot, I think, in the beginning, but we didn't include it because it was slightly out of scope, which was what would happen if like somebody was born on a settlement, or what would happen if someone dies on the settlement, and like how do you really support that? Because it's bound to happen with a permanent settlement, especially when you start getting into the dozens of people. Like people will die, there'll be accidents, people will die because of natural causes and stuff. And we looked partially into ways to like reuse those remains to help the crops grow for agriculture, but we didn't investigate that too much, which I think is an important topic, both birth and death on like a Martian settlement, because both those things need to be considered into this scenario of what you'll possibly do with either the remains that are just going to be left around, or possibly reused, or the like caring for like an infant or something, or a pregnant woman that would happen, that comes with a lot of different human factor challenges, especially with the food system.
Maria?
And just to add on that, so we also thought that maybe a part of that person could be put into a special part of our biodomes and be like preserved and has a specific like very nice place there. So, and also one point we were actually looking into was also the design of a new habitat using colors and patterns, and how also kind of emotion aware, and all of these we actually took out because we thought that we are not focusing on the settlement itself, but there's a lot of research that can be done as well to kind of change also the mood and the psychology of our settlements, just with changing the color scheme or the pattern, or all of this is super interesting research.
Yeah, and if anyone else doesn't have anything to add, I actually wanted to add something regarding the business section that I was working on with Johannes as well. And there were many challenges, and because we needed to think far away from in the future, I think that if we had more time, we actually wanted to look into the business cases and create a proper business plan. And yeah, like if we had time, I wish that we did that, and we would for sure do that. But it was very challenging for us because, as you saw, the show was basically staged. It was in 20 years. But yeah, we know that there is no such settlement on Mars yet. So it was very hard for us to estimate the costs. So we tried our best, but if we had more time, yeah, that's what we wanted to do, to go into more details in terms of businesses and how to even sell everything, and yeah, how to do the pitches. So yeah, that's from my point of view. Anyone else? Okay. Okay. If that is enough, then we thank you for your question. Or do you have any more?
Thanks, everyone. No, yeah, just I want to say congratulations again. Excellent comprehensive responses. Looking forward to seeing what comes next for your TC. Thanks again, everyone.
Thank you so much. Thank you so much. Do we have another question or questions online? Oh, actually also here. Okay, we have one here, Susan.
How do you all feel finishing your TP?
How do we all feel?
Amazing.
Okay, can
Okay.
Can we read it?
Juan de Rama, we have read in your mission statement that you will look at benefits to Earth. Can you summarize what you have in the report on this topic?
Can you repeat the question, please?
Benefits to Earth. Can you summarize it, that what you have in the report?
Okay, Sarah and Jules.
Yes. So we try to follow the report scheme, in the sense that we tackled each issue that has been tackled for Mars, and then we moved that or translated it into Earth. We were talking about business lately, and we thought that we could translate the burial options developed for Mars into new business opportunities on Earth, both in terms of just business and in terms of recycling of human waste in its proper sense. As far as concerns the waste management and the closed loop, we really believe that could be a technology that could be applied to countries that are unfortunately living in situations with very limited resources, that are dependent on other countries in terms of acquiring external resources, and that could improve their conditions. The same goes for vertical farming and remote sensing. We really hope that this technology will be more democratized, so it will be cheaper, and that means that could be implemented in poorer countries, even though we really believe that smart cities might probably be the first ones to adapt certain technologies. And then in terms of food, but in terms of food, we also really believe that it's possible to integrate the 3D printing of food into the diet of humans, and that would mean also trying to avoid meat and go towards a more sustainable diet for everyone, not only into the smart cities where the awareness is greater.
Thank you, Sarah.
Hello, this is Strasbourg. Can you hear us?
Perfectly.
Thank you for the thumbs up. Hi, I'm Virginia Wittring, Human Performance in Space in Strasbourg. Thank you very much for your excellent presentation. We really appreciated the time and effort that you put into this. Y'all did a great job. I have a question, though, that relates to human health over the long term of the kinds of settlements that you are talking about. Human beings evolved in an environment that contains iodine. Where would the dietary iodine be coming from in your system?
Oh, we are just asking whether you can repeat the word. It was iodine?
Iodine, yes, the element iodine.
Yes, I spoke about a few minutes ago that we had no real samples and we had no real analysis from this water. We know that the amount of salt, we know in the salt there perchlorate. As you know, perchlorate is not complex molecule, it's a with oxygen. We know now that we can treat it with enzymatic process and with bacterial process. And we know also probably from the regolith, there's some part of sodium. And when the treatment is done, probably we have a connection with the sodium and chlorure. And this is this kind of environment that we have on Earth. For the iodine, we have to wait the analysis. We build a scenario. It's one of the three scenarios we had. It's possible to change the loop too if we have different quality of the water, and it's only supposition of the quality we have now.
Okay, thank you so much, Cyril. Okay, do you want to add to that,
Did that answer your question, Virginia?
Yes, thank you.
Okay, thank you. I see that we also have a question from Juan. Do you want to say it or shall we read it from?
Let me say it. Thank you. Excellent show. No one here fell asleep, I can confirm. We're all excited the whole time. Since you have been based in Granada and you've been doing a number of professional visits and you met with local experts, can you tell us how useful this was? And most importantly, whether you see any opportunity for follow-on work in Spain on your TP topic. Thank you.
Thank you so much for your question. Where shall we start? We learned a lot, so we just need to communicate now. So Maria is first one.
So yeah, we had an amazing amount of lectures. Really are very grateful for that, and are super interesting. We dipped in so many different areas. We had some about even artificial intelligence, but also we went to some of the visits where they actually also how you say trying to recreate the way how we actually consume food. And this is also very interesting, maybe to see if they can actually test the Martian food that we suggested in the system of the human body that they had. So they had basically the whole stomach and all the things, and they could actually see how it would be digested. That was very interesting to see, and they did a lot of tests there. And yeah, that struck out to me that maybe we can also see then how maybe on long-term basis, the usage also of insects and algae and just the diet they were proposing would have an effect if we could see that, for an example.
Thank you, Maria. Someone else?
I can just maybe quickly,
Patrick?
Yeah, add what was already mentioned about the drones, which was actually the presentation that we have received from the University of Granada, our host here. I think that they have shown how developed their technology is, and that actually that it can support very much the precision agriculture on Earth. So I think this was also quite an interesting lecture. So yeah, thank you.
Maybe I will also add to that we also, like, as you know, due to COVID restrictions, we actually didn't have a chance to go everywhere that was planned. But one of the places that we visited was Hispasat, and we really enjoyed that one because we could spend quite some time there. We could see all the satellites, we could speak to professionals, and yeah, we could also integrate, like, for example, from my background, I was more than happy that I had someone there to ask, how can it be actually applied to other fields? And yeah, when it was also mentioned the lectures, we also enjoyed the lectures, and for example, also the one from Paragon, because yeah, Grant also helped us a lot, and we really appreciated the fact that we could actually speak to him in person, and we actually could ask the questions that were bothering us regarding our project. And there's just few to mention. So if anyone else wants to mention anything else. Okay, Carol.
Sorry. So the question about kind of what future research could be done, I'm not an engineer at all, but something which I found really interesting from our project. We had a lot of lectures about, for example, farming techniques in resource poor environments, but it was often kind of focused on one type of agriculture. And I really enjoyed that we tried to integrate all of these different, aquaponics and insects and crops, vertical farming, and just trying to see how this can lead us towards a closed loop, having the biomass coming from one system feeding into the other one. I think that would be some really interesting research.
Thank you, Carol. Toju?
And also touching on what Carol mentioned earlier in terms of, we had a visit to a drone lab in the University of Granada as well. And in terms of remote sensing, we looked at the Flex satellite, which is going to go up into space in the next 2 years. It's going to measure vegetation through red wavelength. Being able to emulate this with drones within a vertical farming environment would be something really novel and really cool, and achieve a lot. So that's an area of really interesting research in the future as well.
Okay, I think we said more than enough. So maybe if we can, is that all right? And can we ask another question perhaps?
Question here in Strasbourg.
Okay, thank you.
Aiden here. I had a question about the business aspect specifically. You guys baselined some prices for fuel, for food meals around $300,000 or so. And baselining, like say half a kilogram, that would mean some $600,000 per kilogram that you would need to beat in order to deliver this stuff to the Martian surface. Are you worried that launch providers could deliver that instead?
Johannes?
Yes, I can speak to that a little. So these cost estimations are really rough estimations since we don't know very much about the system specific. They are based on assumptions what the development per kilogram system would cost. We did not consider the launching costs that are also included, since until the Martian base starts, we will probably have different transport systems than now. If you look at numbers now, you would get 1 million euros per kilogram. If you look at what current rover cost per kilogram are, if you look at tweets from Elon Musk, it goes down to 100 euros per kilogram in the future. So for an estimation here, you have a very wide area of numbers you could choose from. That's why we did not include it in the calculation. We just stated you need to transport this amount of system mass and provide this amount of money to develop the system. And if you assume then a mission duration, you can calculate how much euro per meal it would cost. Of course, you could also transport it, but however, transporting food comes to Mars comes with a long transportation way, and not all vitamins and micronutrients have this kind of shelf life. So you would need an agricultural system anyways in order to survive, especially long term. If you just go short term, if you want to go to Mars, boots on the ground and go back within 1 month on Mars, maybe you would not pack an agricultural system. We also did some calculations in how many years it would need in order to be actual, in order to start returning the investment in terms of Mars, in terms of transported mass. I hope that answered your question.
Okay, we can't hear you, Strasbourg, so.
And maybe I can also say something about other systems that would help if you have an agricultural system. For example, medical use. If you are with 100 people on Mars for several years, you would most likely encounter situations with, for example, a broken appendix where you need narcotics in order to operate or for medical procedures, and you cannot transport them on short notice since the transport is very long. And you can also not transport a large amount and store it then for a couple of years, since again, the shelf life is probably only the time of the transport. So then you would need a system in order to produce small amounts in order to be processed. So that would also be something to look at in the future in how to establish a medical supply on Mars. And of course, probably that would also start with some sort of plants and natural plants, and not with a whole chemical plant there to produce synthetic narcotics. So
Thank you very much. Thank you, Hannes. And if there are no questions, we actually have something to say if we can. So we wanted to, sorry, G2. We just wanted to thank our TP chairs, Vanessa, Francois, and yeah, if we can give them applause. Also, people who were helping us, Anderson and Jorge, who are our TAs. Thank you so much. We would actually also like to thank everyone from the ISU staff that actually was and that were here on site, that were helping us and supporting us in person as well as in virtual life, because yeah, like we tried our best. And another thing I would like to thank also TP Golden Record that actually has been going through this journey with us. So please also thank them. And Angela, of course, yes, for our editing, for our help.
Yeah. And Andrea, our lovely editor, he helped us throughout the whole journey with executive summary and the report. A big thank you.
And we would, yes, applause. And also we can, yeah, can I? I'm not that, yeah, we also want to thank IT team because they have been with us here yesterday, the whole day. And we just like really appreciate your help. And last but not least, I want to thank all of you because you did an amazing job and we worked as one team. And despite all the circumstances, we are so proud of ourselves. And yeah, I just want to thank you. So thank you so much.
Team agriculture. Team agriculture. Team agriculture.
Thank you to everyone.
Thank you. All right, ladies and gentlemen, so what incredible two presentations that we have watched this morning. So we had, TP Mobility take us on a journey, and we had a quick flyby on Mars and look into agriculture. And now we have a lunch break, and then after lunch, we will actually have another flyby, this time to the moon. And in Strasbourg, the team, Lunar Base, will kick off this afternoon. And finally, we will travel a little bit far away from that point on when we come to the Ethereal Eco. With that, okay, we have only 42 minutes to the next presentation. So please be on time for our number 3 presentation today, the Lunar Base. Thank you very much for joining. See you soon.
Okay, so what we're going to see is a series of events, different mechanisms being operated. The first thing we're going to see is two of the legs making the vehicle lose its. Okay, so what we're going to see is a series of events, different mechanisms being operated. The first thing we're going to see is two of the legs folding, making the vehicle lose its balance. It will then Okay, so what we're going to see is a series of events and different mechanisms being operated. The first thing we're going to see is two of the legs folding, making the vehicle lose its balance. It will then lean on the tension from the cables. The cables will then start to release the vehicles, increasing its tilt angle.
Check. Check. 1, 2, 3, check. 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 1, 2, 3. Check. 1, 2, 1, 2.
Prova, prova. 1, 2, 3, prova. Prova, prova. Prova, prova. Prova, prova, prova. Prova, 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 prova.
Hello from the children of planet Earth.
هل توجد حياة في كواكب أخرى في مجرات أخرى؟
If I had unlimited storage, I would want the next 10 years to figure out what I was going to put into it. We are here. We are here.
I know it's something like that. Lunar ready.
Well, hello, we're ready for the second half of our team project day. So it's already started out really amazing. Now we're going to do our next team project, which is on TP Lunar. And I would like to invite the chair, Rob Postma, to give a little introduction.
Thank you, Gary. Let's remove mouth cap. There's more than social distance at the moment. I'm Rob Postema, the chair for the TP Solutions for Construction of a Lunar Base. And it's a pleasure and a privilege for me to introduce, also on behalf of my co-chairs, Antonio Martello and Matt Sorgenfrey, and the teaching associates, Xiaojian Zhuang, to introduce the team project final presentation and the participants for Solutions for Construction of a Lunar Night. Just to give you a little bit of background, why is this title? The brief from ISU was that we see that there's a lot of initiatives for going back to the moon. They're on scientific level, on exploration level, they're on mining level, even on tourism. So there are several of that which lead to a plethora of use cases and a lot of interesting and nice designs. Question is remaining, can we build these designs? And this is one of the focus of the team project we are about to here present. Of course, they had to start somewhere with a design, and I think they found a very interesting design on which they built their TP. So I would say with no further introduction, being on time, before giving them the floor, I just want to, well, to be in theater terms, to wish them break a leg with this, and guys, hit it.
Spotlight and a special edition because we are during the week of the International Astronautical Congress, the best week in the year to issue a press release. And we have received news that a new contract has been signed to actually create a permanent, sustainable and habitable settlement on the moon between public and private parties. It's a very innovative concept originally developed at the International Space University, sponsored by Lockheed Martin. And I believe we have also the mission statement that we can show on the screen so that you can actually see what this was all about. So you can see sustainable, habitable, permanent, and they also addressed all the valid aspects that you need to address to encompass everything that's important. We managed to get one of the entrepreneurs who invested into this base, the Rosas Lunar Authority, to the studio. Please welcome here, Mr. Orion.
Hi, Alex. Thanks for having me.
Thank you for joining us on such short notice. It is the week of the IAC, but you are not there. Why not?
Well, Alex, this is a really exciting day. Today, we are embarking on an exciting journey. We are going to build a permanent base on the moon. And I just signed an agreement with the International Lunar Association, and we are going to do it as a public-private partnership.
This is really exciting. For our audience, what exactly is a public-private partnership?
We should remember the Apollo program and some other space projects. They were very costly, and governments paid for them. This was very good for space exploration, but now we are doing it differently. This time, the private sector is willing to step in. My company is going to invest $1 billion in this venture, and we will do it just in a number of years. We have a very modular and scalable design, and we are going to use the space vehicle itself as the building block of this lunar base.
Well, I believe I have not seen such an innovative concept before, and you claim to be faster and cheaper than any concepts that have been proposed so far. Has this methodology of public-private partnerships been applied in the space industry before?
Well, public public-private partnership was an excellent tool for exploring new grounds. We should remember when Christopher Columbus sailed the seas, he was looking for new territories. He was representing his queen, but he was also representing his own financial interests. And today it is very common in infrastructure projects around the world. So we are applying this same model now to this lunar base because we believe this is going to be the infrastructure for a new lunar economy. It would create opportunities for new science, new medicine, entertainment, tourism, a lot of new things. We are very excited.
Yes, it looks definitely exciting. And speaking of interests, I'm curious, why did you specifically decide to invest into the ROSA space?
Well, that's an excellent question, Alex. You know, I was sitting the other day here in Strasbourg in a coffee shop with some friends. And, you know, Elon and Richard and Jeff, they were asking me the same question. So, you know, I said, our company is always looking for big causes. We invest in solutions for global warming. We invest in solutions for world poverty. And we believe this lunar base will bring benefits to all humankind. This is a great investment.
Man, there should be more companies like yours to actually improve our wealth and well-being on Earth. Thank you very much for being with us here today in the studio. We wish you a lot of success.
Thank you, Alex.
And welcome to this exciting afternoon edition of Spotlight. Today is the day we are going to launch the SS ROSAS into space. And we have invited a couple of specialists on that topic into the studio. I would like to introduce the lead engineer of the rocket, Mr. I need to read this, Gauthier Bardi de Fourtou. I hope I pronounced that correctly. Hello, Gauthier.
Hello, Sandra.
Thank you very much for joining us here today. You are the expert on this particular launcher, and what can you tell us about the rocket?
Yes, well, today it's a very exciting day indeed because we are going to launch the SS ROSAS, which is the first rocket that's going to land on the moon and be transformed into a lunar habitat. I don't know if you can quite understand the size of it, but it is very, very big. The payload itself is actually 22 meters high and can carry 100 tons to the lunar moon. So this is very big, and this is where we put all our equipment that we're going to need to transform this rocket into a lunar base on the moon.
Yeah, it is indeed quite impressive. I see also it is called the SS ROSAS, and I believe there's some history attached to that.
Yes, actually, we decided to call it SS ROSAS in memory of our dear friend, Oscar Federico Rosas Castillo, who tragically lost his life in an accident during this program. And he was a really great support for all of us as a team.
Thank you very much for sharing this touching story. I believe that the team who has developed this concept, they were under a lot of stress and also emotional stress while finishing that project. And it's just amazing that we came until here to actually see it launch. And I'm sure that your friend would be very proud to give his name to the first rocket of quite a number. How many more are we going to see?
Well, actually, to build this base on the moon, we need two main launches. This one today, the SS ROSAS, that is the base itself plus some equipment. And another one that's going to be launched no later than tomorrow, the SS501, that is going to carry all our astronauts to the moon. And I don't know if you remember, but we also have witnessed 14 launches in the past few weeks.
Yeah, there were many.
Yes, 14 total. Thanks to them, we currently have 2 tanks fully filled up, orbiting the Earth. And our spaceships are going to dock to those ones to refuel before going to the moon. So it's 16 launches total.
Man, that is quite a number of launches. So it's like gas stations in space. And this is what enables us to go to the moon. I hear that the launch is about to begin. We're going to switch to the live stream to the launch site. And Gauthier, please feel free to comment on what we're seeing.
Okay, so this is Rosas on the launching pad right now. And we have liftoff.
Woo!
Rosas has cleared the tower, which is a great milestone for the team. Yeah, so here it's a critical part as well, stage separation. Yeah, going great. And now, as I said, SS Rosas is not going straight to the moon, it's going to dock, yes, to be refueled. So this is the refueling part of the docking. Refueling and undocking, waiting for the last injection, the translunar injection to go to the moon. Yeah, looking great. So I guess we're going to the moon now.
Wow, congratulations.
Congratulations to the team.
Right. Thank you very much for being with us here in the studio today. Looking forward to what's going to happen next.
Thank you, Alexandra.
We are just few days after the launch of SS Rosas, and today is finally the day. It's the day of the actual landing of SS Rosas on the moon. While we wait for confirmation from Mission Control, we have a very special guest here with us to learn something more about the landing site. Please welcome Adina.
Hello, thank you for having me, Gianmarco.
It's a great pleasure, Adina. You are the head of the team responsible of the choice of the landing site. So where are we going to land on the moon? I hope you selected an enjoyable site also for the future visitors of our lunar base.
For sure, one of the best ones. So the selected location for our lander is going to be the south pole of the moon and the rim of the Shackleton crater.
So just for our viewers' understanding, why exactly the South Pole? Couldn't we just land near the Apollo sites?
So there's multiple reasons for that. One is that we have continuous light at the lander location, which is good for power, of course, but also good because we can always see our surroundings. The second reason is that in the Shackleton crater, we have permanently shadowed areas where we expect to find ice water, which we can later use on the base. And the third reason is that we always have a view of the Earth, which is also good for the psychological health of the crew and for future visitors.
So thank you, Dina. Can you please describe us how it is being there at the rim of the Shackleton crater?
Sure. So first of all, the view is gorgeous because, of course, you can see the Earth all the time, but also the ground is really flat, which is one of the reasons why we chose this particular location, because the construction will go really smoothly.
Okay, thank you so much for your explanation. I wonder, once the second Starship arrives, will the dust be a problem for the rocket or for the astronauts themselves?
So the second lander, which we refer to as SS21, will actually land at a safety distance from the SS Rosas. So that means that the distance is going to be 5 kilometers. We calculated this based on the fact that all the dust and regolith, which will be thrown away at the landing zone when the second lander arrives, will not reach the base. So it will not affect any equipment or material. And once the crew arrives, they will be transported using a new innovative fleet of rovers to the location of the base.
I think it's wonderful. A lot of careful consideration have been made by the scientific and the engineering team together. So thank you so much, Adina. We now received confirmation that SS Rosas is about to land on the moon, and we can listen to the voice loop between Mission Control and SS Rosas. Let's listen to it.
Telemetry, we're go for the orbiter.
The orbit were started. Engines operating nominal on trajectory.
Trajectory is looking nominal. Begin main engine cutoff, prepare retro thrusters.
Main engine shuttering down. Adjusting firing normal.
Deploy landing legs, prepare for thruster cutoff.
Landing leg successfully deployed and contact light on.
Engines off. Welcome to the moon team. Commence surface operations.
Another step for humankind. Let's get to work.
Ladies and gentlemen, for centuries, the moon has inspired our cultures, inspired children, women, men, scientists, engineers, designers, artists, and every one of us. It took centuries of technological advancements, decades of peaceful collaboration and research to arrive at this point. From the Copernican revolution to Kepler or Galileo, they changed our vision and the aim to go beyond our terrestrial prison lights up. They paved the way to new horizons and new possibilities. And today, we witness the return of humankind to the moon, not to visit, but to stay. We are beginning to grasp what it takes to become a species that lives on more than one celestial body. The gigantic enterprise is already bringing together people across nations, cultures, and disciplines. To see all these people working together, forgetting their differences, and coming together to accomplish something so exceptional proves that the world that is opening up to us will be a place of peace and harmony. In a few years, we will see the fruits of this work in technology, science, and business models. Smart entrepreneurs will make the lunar economy a reality, and our artists, musicians, and poets will finally get the chance to live that dream and inspire future generations to dream bigger. In the next few weeks to come, the 12 astronauts will start preparing for the tipping of the SS Rosas, and the lunar base will rise from the lunar soil as the world has seen the rise of the Great Wall of China, the pyramids in Egypt, the Colosseum, or the Taj Mahal. It is with emotion and pride that I stand in front of you today. Be sure, this is a big day for all people around the world. Thank you.
And welcome back to the afternoon edition of Spotlight. Today we will write history, and this day is going to be called Groundbreaking Day. This is the day when the Starship SS Rosa will turn from a vertical position into a horizontal position. We have a couple of experts with us in the studio. I would like to welcome here Monica Ekel, the lead robotics engineer. Welcome, Monica.
Thank you, Alexandra. It's a pleasure to be here.
Thank you for joining us. And we also have a surprise guest with us. We managed to get one of the astronauts on the SS501 in our live stream, Shai Monat. Can you hear us?
Hello, I can hear you loud and clear.
Fantastic. I believe there's a little bit of a delay. So, Shai, what will happen exactly today?
Yes, so today is a very special day. We are going to do a very complicated maneuver where we're going to transform the SS Rosas from a vertical position to a horizontal position on the ground. That is important to enable the crew to access the vehicle or the future habitat more easily, and also to cover the whole habitat with regolith to protect it from radiation and micrometeorite impact. So to do this complicated maneuver, we've been working for 3 weeks since we've landed on preparing a very complicated system that will maneuver the vehicle sideways. So we set up all these different mechanisms. We also took a lot of equipment from inside the vehicle outside and put it on the surface, so it will lighten the load on the vehicle as it is being tilted. So we are now here I'm now at SS501, and I'm going to monitor the crew that is already on the ground, out on the site, the SS Rosa site, and they are going to verify that everything is ready, that everything that was installed properly, and we are then going to tilt the vehicle. So I'm now going to talk with the crew, see that everything is ready and performed nominally, and we'll talk in a few minutes.
All right, thank you very much. In the meantime, Monica, you can tell us a little bit what kind of preparations have already been made on the ground to enable this procedure?
Of course, as my colleague Shai explained, a series of steps had to be done in order to move the Starship SS Rosas from vertical to horizontal configuration. First step was to convert the body of the Starship into an empty shell. And for that, all the payload was unpacked. This consisted of solar panels, of reactors, of radiators. The next step was to detank, that is to drain fuel from the tanks. The next step was then to deploy all the supporting equipment, which would help us in the tipping procedure. So this consisted of, as you can see in the images, this consisted of deconnecting the elevator that the SS Rosas had and retrieving those cables. Those cables were then connected to the lunar surface using anchors and winches. Then we had the robots detank, that is drain the fuel. Then we deployed the hinges, which would support the robot, support the Starship during the tipping procedure. And the final step was to also lay down berms of regolith on which the body of the Starship would finally rest.
Wow, that looks really impressive. And I also understand, because you are the robotics lead, that not everything has been done by humans, but to a large part by robots.
Indeed, I'm very excited to talk to you about our Morocca's robotic system. So Morocca stands for Modular Robotics Construction Autonomous Systems. And as you can see in the figures, this is essentially a modular robotics base, which is compatible with a variety of construction equipments. And it is due to this that these rovers can transform themselves very easily into detankers, into regolith movers, into drills, etc. And as Shai and I spoke before, these rovers have conducted all the operations that have set the stage for the tipping procedures autonomously, which is why, as you might have observed, they saved the crew a lot of hours of extravehicular activity and getting exposed to lunar radiation. But that's not all. They are going to continue working even after the tipping process. They are going to cover the body of SS Rosas or Rosas base with regolith for radiation and meteorite protection. And it makes me very emotional to talk about the Morocca suite, given that all the hard work that has gone into it. I feel like they're truly a modern robotic marvel.
Yeah, absolutely. I will definitely need one of those for my home. Maybe there's a chance for a spin-off. In the meantime, I hear that Shai Monat is going to join us again, and he's going to tell us what the process is going to look like that we're about to see.
Okay, so what we're going to see is a series of events, different mechanisms being operated. The first thing we're going to see is two of the legs folding, making the vehicle lose its balance. It will then lean on the tension from the cables. The cables will then start to release the vehicles, increasing its tilt angle. It will tilt around the hinge, which connects it to the ground. The purpose of the hinge is to guide it in the right direction which we want it to land, and also prevent it from slipping on the ground. So at a very high angle of tilt, the vehicle is going to rest on the scissors lift, which is going to take most of its load at this point. And then the scissors lift is going to fold until the vehicle rests on the two berms of regolith, which will stop it from rolling. The scissors lift will then drive away from the vehicle underneath it, and that is when the operation will be concluded. So I think we're ready to begin. You will be seeing images from the ground. We'll be sending you images in sequence. We're going to maintain the bandwidth for communication between ourselves. So I hope you enjoy what you're going to see, and goodbye.
Thank you.
Ground control to 501. Do you read? 501 to control. Read you loud and clear. 501, all systems are nominal. It is a go for horizontalizing.
Roger, ground control, initiating procedure, stand by. 501 to ground control, legs retracted. Contact engine. 30 degrees tilt.
Ground control to 501, visual confirmation.
501 to ground control, tilt in progress. Contact with scissors lead.
Ground control to 501, visual confirmation.
501 to ground control, scissors lead folding. Contact with ground, removing scissors lead.
Project 501, process is horizontal, congratulations.
And welcome back to Spotlight. Today we have a special edition because now that astronauts are regularly involved in construction activities on the moon, general public on Earth has been raising concerns about the safety and the health of astronauts. To discuss about this, today we have a very special guest. His name is Giorgio Lorini. He's the head of the medical operation of this mission. Please welcome Giorgio. Giorgio, I'm pretty sure you have undertaken all the necessary mitigation strategies and the countermeasures for our astronauts. How dangerous is it really being a lunar astronaut?
Yeah, you're absolutely right. On the lunar environment has its challenges, and here we try to identify the main problems such as radiation, lunar dust, and hypogravity. Radiation does have its own exposure limit, and to ensure optimal performance and longevity of the health of astronauts, we try to identify the maximum exposure limit regarding radiation, and also we try to limit the time that astronauts can spend in space. Regarding to lunar dust, the main concerns are related to inhalation and also adhesion to the spacesuits. We try to identify also the maximum dosage of lunar dust that the astronauts can breathe without causing side effects. And also we try to propose a mitigation system for the dust. Lastly, we have to talk about the gravity, because on the ISS, our astronauts are spending their time in a weightless environment. On the contrary, on the moon, we have to adapt astronaut exercise and spacesuits to reflect the 1/6 Earth gravity and take this into consideration for human performance and medical practices. So to keep the health of our astronauts, we have to be sure that they can practice different type of exercise to protect their bone, muscles, and cardiovascular system.
I see. Thank you so much, Giorgio. The lunar environment is definitely challenging, but we can say that our astronauts are very well protected. And now we have another very special guest. She's Emily Apollonio, a human factor specialist and a spacesuit designer. Please welcome Emily. Hi, Emily. What would you like to add regarding how we are protecting our astronauts?
That's such a great question. So the health and well-being of our astronauts are of utmost importance. So we wanted to ensure that we took every precaution necessary to make sure that our astronauts were healthy and performing optimally.
And since you are a spacesuit designer, can you talk about the spacesuits they are using there? I guess they are a very important component of the work activities. And can you also please explain a little bit about plans or procedures in case of emergency situations or illnesses of astronauts?
Yeah, absolutely. So the spacesuits were definitely something that we needed to take a look at. They are absolutely the #1 system that helps protect our astronauts doing lunar EVAs. So some really cool features that we included in these spacesuits was the customizable boot traction for the astronauts to be able to adjust the traction of their boots depending on the activities that they're performing and the ground beneath them. And then also we incorporated the heads-up display that allows them to navigate across the lunar surface as well as monitor their consumables such as oxygen. And then as far as the medical stuff is concerned, they are doing some pretty risky tasks throughout the construction of the Rosa space. So we wanted to make sure that we cross-trained all of our astronauts on proper medical procedures on a fundamental level. But we also have 2 dedicated crew members that are going to be strictly performing any kind of medical emergencies.
Oh, thank you so much, Emily. That's very interesting. And I wonder, how is the tight schedule affecting the astronaut performance? And what can you say about that?
Yeah, there is a lot of there are a lot of time-sensitive tasks that need to be done, but one of the big things is ensuring that rather than being time-focused, we're project-focused. That way, the astronauts don't have such a high temporal demand. We also took into account their schedules, made sure that they had time for leisure activities and stuff like that.
And how do we take care of the psychological and psychosocial well-being of our astronauts? I guess we all want happy and motivated astronauts there on the moon.
Yeah, absolutely. We love to have fun here on Earth, so why not on the moon, especially on the moon? So having leisure time and having fun is a key component to our psychological well-being. So we did make sure that we included a lot of leisure activities or opportunities for leisure activities for our astronauts to take advantage of on a daily basis. And some of that includes doing some sport games to kind of approach both aspects. They can receive exercise while also having fun.
Yeah, that sounds great. I think we can all agree our astronauts are in very good hands. And now, thank you so much, Emily, for being here. We have a special surprise for you because in the past few days, we had the opportunity to record a video interview with astronaut Charlotte. She is inside the SS Rosas, so let's watch it all together. With this, I'm talking with an astronaut on the moon. Astronaut Charlotte, can you hear us?
I can hear you loud and clear. Hello, Earth.
And hello to the moon. Oh, I've always dreamt to say that. We are very honored to have these few minutes with you.
It is so nice to hear you, and I can't believe that this is such a milestone that is happening now. As you may notice, we have some bandwidth issues because we still need to set up some subsystems. And in addition, we have the 2.5 seconds delay because we're on the moon.
Yes, we hear that you are very, very busy up there. And this is exactly why we wanted to talk to you. Today, you will be entering the horizontalized empty Rosa space for the first time to refurbish it. How is it going to go?
So today we're going to open up the hatch. And when we have opened up the hatch, we're going to go inside the tanks, inside the fuel tanks, and actually connect the tanks, because that is where the crew will be living in. And in addition, it will be very dark inside, of course. But luckily, our EVA suits are well equipped with some really good lights that can help us see in these dark tanks. And when the tanks are connected and finally done, we're going to put in some flooring and walls so that the crew have different living quarters and living areas, because the human factors is, of course, really important in this.
That sounds like a lot of work for you. When you can start living inside the Rosa space?
So our crew of 4 who are doing the main side of the construction next to the Moroccas who are working outside at the habitat are actually going to live already today inside the Rosa's base. But they're going to be in the upper part, which is already pressurized and is already living quarters, but it's only for 4 people. The other 8 astronauts at the SS21 will come later when we finish up the work. So first we need to set up the ESLS living support systems. We need to check if it's radiation shielded enough. We need to check if there's thermal insulation. And of course, it needs to be a pressurized cabin so that the crew can actually survive in.
Oh, I see. This is such an exciting project. And we actually have a footage that was shot back in the days during the team project concept site at ISU. Starting from connecting the two tanks to bringing in equipment, the habitat promises to accommodate 12 astronauts for a sustained presence on the moon. Can you confirm that, Charlotte?
Yes, I can definitely confirm that. It is really great that the Rosas base is such design that it has enough space for living quarters, for nice private rooms, enough for all the systems to be there. Research opportunities are growing, and of course, most important, the kitchen.
Yeah, exactly. And finally, what's it like to be working and living on the moon?
It is absolutely amazing. Having the Earth's view every day from outside of the base is stunning. It gives such an amazing perspective of our big blue dot that is having the humankind all on there living together. But this also is a very big step for all future explorations, as we all know that the moon is only a small step for us, but a big step for humankind.
This project is so inspiring, and we wish you a lot of success with that. We shall be following it here on Earth. Thank you so much, Charlotte, for having been with us.
And welcome back to Spotlight, the late night edition. We have just received a press release from the Lunar Authority that the construction on the lunar base has been halted. The main reason for that is an interference caused by a probe, Dasha-1. As many of you remember, the Dacian Republic has launched a lunar lander, and it was supposed to land yesterday at the rim of the Shackleton crater. However, due to a malfunction of unknown cause, it has actually landed in the middle of the construction site of the SS Rosas. The lander luckily is still functional, and the Dacian Republic intends to carry out all its experiments for in situ resource utilization, converting water ice to water, and also looking for helium-3. Now we got a hold of the legal advisor of the Rosas Lunar Authority. Welcome, please, Mr. Tian, for a statement.
Yes, thank you for consulting me on this matter. So the accident occurred on the surface of the moon. According to the liability convention, fault liability applies to damage caused in outer space. For the unexpected landing of Dathia-1, more technical investigations have to be made to figure out whether Dathia is at fault. Meanwhile, I'm very astonished to hear that Dathia intends to continue its scientific experiments within the safety zone of our lunar base construction. This will seriously interfere with our activities and pose risks to the life and health of our astronauts. Therefore, Dathia should be considered at fault for any potential damage that could be caused by its scientific experiments.
Can you maybe give some insight into what the safety zone is about?
Yes, that is a very good question. So the reason for us to declare a safety zone is to avoid harmful interference. As our technical experts have explained, due to the peculiar physical characteristics of the lunar regolith and the harsh lunar environment, activities on the moon can create lunar dust. Therefore, we have informed the public of our safety zone to ensure the safety of both our activities and those of others.
Yeah, and we also heard that actually some damage has been caused. Can you confirm that?
Yes, at the current stage, we are still doing investigations on how many Morocco's rovers have been damaged and whether they can be repaired. Also, the unexpected landing of Dathia 1 causes delay to our lunar base construction. In particular, it hinders the extravehicular activities of our astronauts.
Why is it not possible for the astronauts to just work around the probe?
Yes, on this point, we have to recalculate the risk, and our scientists and engineers are working hard to find out alternative solutions. Meanwhile, we have to remind Dathia that our mission is a crewed mission. Astronauts are regarded as envoys of all humankind under the Outer Space Treaty, and states have the obligation to render all possible assistance to astronauts in distress. What Dathia intends to do goes in the opposite direction of this principle. Therefore, we ask Dathia to immediately suspend its activities and to undertake appropriate international consultation with us to solve this matter together.
So that means that the astronauts up there on the moon need to wait until we have cleared our earthly matters?
Yes, for now, I'm afraid so, because there are still so many uncertainties involved. Humanitarian considerations are always our priority, and we will make every effort to assure the safety of our astronauts. To this end, we are trying to coordinate with Dathia to find out the best way to avoid harmful interference. On the other hand, for any loss we sustain, we will claim compensation from Dathia in accordance with the Liability Convention.
Thank you very much for the statement, Mr. Tian, much appreciated.
Yeah, thank you.
Hello. I'm Aidan O'Leary, head of the Roses Lunar Authority. I'm here today to rectify a few assumptions and statements made on TV and over social media over the Roses missions and activities on the lunar surface. There have been a number of concerns over crew safety, but this is and always has been our #1 concern. They're all currently in good health and going about their normal activities. All investigations and operations have been in support of this cause. On the topic of taxpayer funding, the SS Rosas has ample volume and utilities which can be rented out from the Rosas Lunar Authority by nations and businesses worldwide to make the space financially sustainable. For the past 3 years, we've been partnering with governments to research and develop the critical components, and we are proud to announce that as of last month, Rosas Base is generating revenue and is financially independent. All investments previously made are now being used to host international astronauts, payloads to support science, education, lunar infrastructure development, business development, and activities of public agencies for the good of the people, as you can see from the diagram next to me. In exciting support of this, agreements have been made with the Republic of Darthia for full collaboration and cooperation with Rosas Base. They've signed an agreement with us to rent out a dedicated lab in the completed Rosas Base to continue their research and commercialize this technology. They are promising first results on extraction methods for water ice to provide water to astronauts and as well as fuel for the fuel economy, and helium-3 to generate clean power. Additionally, on the topic of public space, new offers are coming in from private entities, which include pharmaceutical companies, agricultural biotechnology, construction manufacturing, as well as art establishments and space tourism to utilize Rosas Space for the maximum good possible. We're very excited to see how this plans out and see how the lunar economy continues to grow as this space will expand. Thank you very much for your time, and I hope you guys have a good night.
Welcome back to Spotlight. Today is another historical day when we are actually inaugurating the Rosas Base. It is finished and we can start using it. And this time we have a lot of guests in our studio. The first one you might remember, the entrepreneur who originally invested into the base. Please welcome with me, Ori on.
Hello, Alex. Thanks for having me again. I remember how 3 years ago we met here, we spoke about our lunar base, and I'm so excited today that we are inaugurating this base. And I would like to thank our incredible space engineers and architects, the human performance experts, our legal advisors, our managers, everyone that has worked so hard on making this come true. It's a dream.
Yeah, it was definitely worth the effort. But when I ask you, was it worth it?
Absolutely. As our CEO just said, numbers look terrific. We are generating revenues. We signed sponsorship agreements. And I would like to share with you and with our viewers exciting news. Next week, we are starting to broadcast live television from our lunar base. So we will be launching our new program, Lunar Brother. You can watch our astronauts 24/7 with a reality show. Please tune in. And one more exciting news, 2 weeks from now, the first lunar tourists are going to reach our lunar base. So Mr. Gary Martin and his family are going to reach and to stay at our 6-star Rosas resort. They will be able to go on sightseeing on the lunar surface with our special rovers, of course, and do incredible things there. So I encourage you, all our viewers, please call our agents, book your flights for the most incredible experience of your lives. It's going to be great.
Yeah, you're making a good case. You're definitely selling it. So please reach out to Mr. On if you want that ticket or if you want advice on how to invest into the lunar economy. Thank you very much for being with us here today, Ori.
Thank you, Alex.
And while this endeavor has, of course, been a commercial one, also the science community is looking ahead what to now do with the Rosa Space. And we have here today the lead scientist of the Rosa Space, Leonard Lidgard.
Hello, Alexandra.
Leonard, you know what's going to happen in the labs of the Rosa Space. What kind of experiments are you going to perform?
We are planning to do lots of exciting experiments. You know that we wanted to go to the South Pole because there's water and we want to use this resource. So first of all, we are planning to use water to obtain hydrogen and oxygen in a way that we can obtain fuel in a sustainable way. But then we also want to purify water. Could you imagine having astronauts drinking moon water? That would be crazy. And then we also want to have water inside our base, the Rosa base, in a way that we can create aquaculture. We want to create plants, to have plants grow in these pools with fish in a way that we can use the organic matter to have plants grow and then astronauts eat plants. But we don't want just to use water. We want to use regolith, not only to shield from the radiation, but because regolith is very interesting. We can find lots of different minerals and metals. And we also want to extract helium-3. And do you know, Alexandra, what helium-3 is?
Not exactly. And I believe all of our audience would be very interested in that.
Yeah, of course. Helium-3 is an isotope and is one of those elements that has the highest ratio for energy and mass. So we want to take it and bring back to Earth in a way that we have a source to obtain fusion energy. And so we want to have a clean way to obtain energy here back on Earth. But also we want to do other experiments, also on biology, because we know that in low gravity, we can crystallize protein in a better way. And so we want to find cures for those problems that we cannot fix. We cannot find cures here on Earth, like tumors or genetic problems. And we want to do that on our base. So a lot of different activities, interesting experiments.
Well, it definitely sounds like you have a number of candidates signed up for the next breakthrough prize, or maybe a couple of them. I personally am very much looking forward to the results of your research. Thank you very much for sharing that with us.
Thank you, Alexandra.
Now, science and commerce have been inspired and have been involved in the lunar base, but also popular culture has been very much touched by it. And you might not know him by his real name, but rather by his social media name. And I would like to therefore welcome Zayden with us here in the studio.
Thank you very much for having me here today, Alexandra.
We have a lot of fans in our studio here. Zayden, your background is in fashion design. How did you come to be inspired by the moon?
That is correct. Well, I've always had a passion for the ethereal. In particular, there was a groundbreaking album that came out recently, Carl Bogren's Rise from the Regolith, which really touches upon all of humanity's hopes and dreams for this future goal, utilizing the moon, expanding into the stars. I drew a lot of inspiration from it, as I believe many have. And I hope that we can continue this lineage.
Yeah, heavy metal has never been so high in the charts, and I'm really happy it inspired you. What can we see in your next fashion line?
Well, as you can see, I'm wearing one of our fine decor at the moment. I call this Lunar Chic, a new statement of fashion which brings together all the aspects of space we're going for. No longer the bulky EVA suits of the past. Fast, sleek, slim, faster, bolder. We're going to accomplish so much together using this new, efficient, sustainable ideology.
Fantastic. And your followers, I forgot how many followers you actually have.
1 billion as of last week, breaking records on Instagram.
Fantastic. Your 1 billion followers will be sure to follow you now even more. Thank you very much. Excited to see your new fashion line very soon.
Yes, check us out on Lunar Shark Tank coming up soon.
And I hear that we're about to go into the live stream from the ROSA space where it will be inaugurated. Before that, we will jump into the United Nations for an inauguration speech.
My fellow people of Earth, about a year ago, my predecessor announced a great achievement, the construction of a lunar base within only a few years, what some would have called an impossible dream in our lifetime. Because of this, we have started a new age, an era where humanity shall not live on one, but on two worlds. We've all seen what this has brought to our economy, our culture, our sciences, and the benefits it brought to millions across the world. Because of this, I see Rosa's base as a beacon of hope for all humanity. As we speak today, I announced that we plan further expansion of the base to increase its size tenfold with its modular design and bring further benefits for us all. So when we see today opening a hatch, we do not see only a hatch, we see a doorway into our future. Therefore, I wish to ask for all of the best for these brave people up there on that faraway place at Astra.
We welcome humankind back to the moon, and this time we're here to stay. I announce the Rosa Space officially open.
Gary, I think you wanted to do the introduction.
So now we do the fun part. You're going to look at the questions and give the answers, and it's all you that run it. So it's
All right, thank you. So in addition to the credits, I want to thank all those people that we got to work very closely with. That would be our chairs, Rob, Antonio, and Matt, and our lovely TA, Xiao Chen, and of course our sponsor, Lockheed Martin. And now it's my pleasure to moderate our Q&A session. And if we have any questions from our viewers, we can start from there.
Thank you. Wow, that was a really, really well done presentation. You should be extremely proud and extremely impressed with what you've been able to achieve. My goodness, you've absolutely blown my mind. Yeah, goodness. Okay. I am by no means an expert, but I do like to dabble in a few things. So I was just wondering, you mentioned briefly the big issue around exposure to lunar dust, because if you're going to be, say, digging up dust and covering your base with it, and there will be the EVAs involved, it's very important to limit any risks to your astronauts. I was just wondering about the metric you used to determine how much exposure was too much. It was briefly touched upon, but I'd love to hear about that more. Well done, guys.
So yeah, that answer is best, that question is best answered by Giorgio. He's been doing our audio and backstage. So please in a second. Here you go.
Thanks, Stefan. Actually, we base our studies on some articles that have been published, and all the studies that have done till now are based on mice. So obviously all the data that we have should have been, I mean, we will have to confirm them once we will be there. And so that's all.
Okay, like Alex, I thoroughly enjoyed the presentation. Heartiest congratulations. And to say one enjoyed your presentation, what better accolade is there, honestly? So very, very well done. I've just one question, if I may. You discussed lunar safety issues, including dust and radiation problems. But what about ethical issues relating to astronaut well-being and the challenge of respecting planetary protection protocol?
So there are two components that your question touches on. One would be the humanitarian one, and one the legal one.
Ethics. Ethics of astronaut well-being, and the other protecting or respecting planetary protection protocol, which is well established internationally.
Let's start maybe with the second aspect, with the legal one, and then Carl might want to join us right here. Carl, go ahead.
We did not include an ethics chapter in the report, but of course we plan to follow the planetary protection rules. Yes, it's not something we have on it, I'm afraid.
But are you familiar with planetary protection, the concept of planetary protection?
Yes, so it's the concept of not transferring, we're making sure the things we send are sterilized, and we're keeping the lunar environment.
Yeah, forward and backward contamination.
Yes.
So I think Oliver has a few words on that as well.
Yes, thank you for this very good question. So yes, as you have mentioned, we have addressed both forward contamination and backward contamination. So this refers to the COSPA planetary protection policies. It consists of 5 categories, combining of the mission type and also the type of planet we are going to visit. So the moon is listed in the type 2, meaning that the risk of contamination is not very high. So it has listed some requirements about documentation and also the inventory list. And also, as far as I remember, in June this year, the COSPA has updated its planetary protection policy and to add 2 subcategories about lunar activities. So subcategory 2A and subcategory 2B. So for our activities, because it is near the South Pole, it is listed in the subcategory 2B of the COSPA planetary protection policy, and we will abide by its requirements. Although it is not legally binding, but it is very important for us to avoid contamination of other planets.
Thank you so much.
Yeah, thank you.
Please, do you have another question?
Thank you. This is Joan from Strasbourg. The answer to these questions might be in the report, but let me ask them so that you can help us live. Only 2 questions. The first one is on international collaboration. Your proposal is to use primarily US hardware. Have you considered how other countries could contribute and what the barriers to technology transfer might be and how one could solve them? And question 2 is, has any member of your team talked to someone from SpaceX? Thank you very much. Congratulations for a wonderful story. Really, very well done. We enjoyed it. We should post this all over the place. Thank you.
So for our online audience and for the folks in Granada, there's the answer to the second question is we're trying. We reached out on multiple channels and we have some contacts, but did not fully get in touch yet. About the first question on the internationality of this endeavor, the starting point of ROSA's mission, or one of the key constraints, was that we want to be able to achieve this soon. And the available technology that we saw drove us into the direction of the Starship. But there's a lot more to it, and I'll hand off the microphone now to.
Yeah, so we actually had a look at the dedicated lunar budgets across different agencies that have signed the Artemis Accords. And well, of course, a lot of them are already allocated to particular types of missions or to particular programs. However, there are also a few that are still open. So the goal would be, of course, if you start such a mission, that you need to reach out to, in particular, to these nations, and also talk on the international level regularly to make sure that these budgets are allocated in time to the project that we are proposing. So in particular, Luxembourg and Canada have at the moment very interesting programs with yet unallocated budgets. Of course, some has already been won, but we hope that through proper communication and public affairs, we can actually raise interest in this program, and that in the next budget round, other budgets will become available.
And Joao?
So just to add one more thing, as Stefan said before, our goal was to be focused on feasibility, and we didn't choose a particular company. We chose the best available option. And we see that this might be a possibility for other companies, for other countries to consider the idea of wet workshop, the idea of building these solutions as an example. So this is kind of our one data point based assumption, but we truly believe that given our studies that this could be a viable option. So yeah.
Did that answer the question? Do we have any more questions from the jurors?
Yes, please.
Please go ahead, Virginia.
So I'm excited to hear about your mission. You did a great presentation about this. I have some concerns about the mental health of your crew members. I'm glad to see that you had some ideas. You mentioned some things about how to handle the workload. How would you deal with the lack of sensory stimulation that astronauts have reported on ISS missions or in Antarctic missions? How would you deal with that, and also the lack of exposure to natural environments that we humans seem to need?
I'll hand this question to the rep of our HPS team.
Thank you, Virginia, for that question. There's quite a few things that we take into consideration with that. One of them is the platform that we had called Oscar. I can't quite remember what this stands for, if someone, okay. But it is essentially a platform that all of the crew members can go to be able to view Earth from the inside of the lunar base. And then in addition to that, I mean, we took a look at a lot of the exercise training that we can do to help improve their overall well-being, their mental, their physical aspects, and also their mental aspects, and then being able to incorporate that in a sports-like environment. And then unfortunately, one thing that we didn't get quite a lot of time to research was designing the interior of the space station. So that was something else that we would like to expand on a little bit more to discuss how the interior environment could benefit the astronauts.
Thank you, Emily. I have some questions in the chat, if that's okay. Yep. So this is from Professor Peters. He asks a few business questions that the public would be interested in or not answered, such as how are the costs for the whole endeavor estimated and how reliably are they estimated? He also asks, helium-3 is mentioned as a promising product, but we are still far from using it on Earth commercially. So is there a market now? And his third question is, PPP has not been very successful until now. Why did it fail for Galileo and why would it work in this case?
I give these questions to Ori.
Okay, so regarding the costs, we made a quite detailed breakdown of the costs and a bottom-up analysis from which we derived the P&L and the cash flow analysis. We went item by item. Obviously, for some of the items that are still yet to be developed, we made estimates, but we took references from other projects, from known budgets that have been spent. So we did it and we tried to make it as accurate as we could. So we strongly believe in these numbers. And that's for the first question. Regarding the PPP, I will hand over to Aidan.
Yeah, so PPP has a ton of examples of success on Earth and a number of examples of success in space. The exact methodology of PPP can differ greatly. Sometimes it's just a public-private partnership where the government pays into a certain company a certain amount of R&D, and then the company has to fund a certain amount themselves in order to develop a product. We've seen that a lot applied to space. What we haven't seen as much is that an international authority was actually established. And we've seen great success with this for trillion-dollar projects here on Earth. For instance, there's a great example with the Tennessee Valley Authority, which was able to establish huge R&D development within the Tennessee Valley to bring in a bunch of different private companies and providers that could establish a lot of really great infrastructure. And we see examples of this in different models with CERN, which developed fantastic scientific benefits to the overall community. We believe that this has a unique opportunity with these economies of scales to be applicable in space, where the R&D costs for actually setting this up, since a lot of the technology is now reaching maturity, aren't that high comparatively to what they may have been during Apollo era and things like that. In particular, we're reaching a point where, very excitingly, we had around 600 million per year in operation costs. We did a breakdown within our document which talked about how this could work out long-term and analogs to the ISS in particular with the volumetric utilization. with around $3 to $4 billion in funding going to operating the ISS per year for the American segment, and around 77% of the utilization for research. We end up getting that you get around $4 million per cubic meter on the ISS, and just to cover our operational costs, we could do $0.6 million per cubic meter per year for Rosa's base, which means to be within those two values, we have a lot of room to play with to generate revenue and open this up for potential expansion and more opportunities. Again, that P&L that Ori talked about drove a lot of those different operating costs, but we're pretty confident in them, at least the rough order of magnitude. And regardless, it's very promising considering the number of players that Alexandra mentioned.
Okay, but helium-3, Tamiana has a few words.
Yeah, the question is if it was like an activities that they are doing like just after the development of the base. The answer is no. Indeed, we added it in as a future concept next to the building of basically a telescope on the ground on the moon ground. Instead, as an activities that they're doing just inside the base, we consider the aquaculture, the growth of plants, and the growth of plants with the moon soil. So the extractional helium-3 would be a future concept just because it has to be developed in a better way. So it has to be studied.
Good answer, thank you. Do we have any more questions from the online jurors?
Yes, if we could go over to Philomena, please.
Thank you. First of all, thank you very much for your presentation. It is such a tribute to Oscar. Tremendous. My question has to do with, I think, what Hugh said with regard to the planetary protection, because there is no away, even on the moon. We can't throw things away. We can't put them away. So my question is, with regard to lunar protection, maybe it says it in your report, like Juan said, but I'm going to have to read that for sure. Mining knowledge. Is there any use of mining knowledge with regard to putting things away, as in our garbage, as in our waste products?
So could you expand on the concept of mining knowledge, what you mean by that?
Because we're going to be using the moon potentially as a resource for helium-3, like Walter was saying, there's a lot of knowledge that comes from reclaiming the natural environment. Because as human beings, we tend to go in and take everything we need and take everything we want. And then we sort of try to solve our problems after that. So the mining industry in the north of Canada has done a lot of work with regard to making sure that they leave, potentially you're familiar with no trace camping, where you leave things better than when you first came. Because in your mission statement, you talked about the future, the sustainability. And I think what the question I'm asking is how are we going to deal with the garbage that we make? How are we going to deal with the problems that we create, because we are not lunar people? So that's my question. And I'm suggesting that perhaps there would be something in with mining and how the mining industry has done that.
Joao actually wants to say a few words about that.
Thank you. Thank you so much, Philomena, for the question. It is indeed a big part of what we baselined on our mission. So the actual concept of operations is important here. As the previous question mentioned, we assumed a lot based on the numbers and the system that is being currently developed by SpaceX. And so a lot of the things we actually aimed to do was not to actually do in situ resource utilization of anything to build the base. So when you see, for instance, back in our concepts, some use of regolith, we're not actually taking materials out of the earth. We're just changing their position because we first of all, it was a technical problem we found that for the near future, we wouldn't be reliably dealing with the extraction of materials because the technology is not there yet. So for a purely practical reason, we decided not to use that. And the second is actually comes from this connection between the economical and the ecological, which is the use of this Starship equivalent system makes it so that given the numbers we of course are given on the various sources that are of course questionable, right? These sources are usually Twitter or something like that. I mean, we are currently reading tweets to know how much the launches will cost, but they give us an interesting example that perhaps sending water to the moon, sending 100 tons to the moon's surface might be cheaper than actually mining it from the moon's surface itself. And using our cycles, our closed cycle systems or our near closed cycle systems, just as a processing system, and then take back the waste production that is the waste that's happening on the moon. So I think that the baseline of our architecture, if it brings this sustainability as its source on the concept of operation using this vehicle, using this type of transfer, it really ties in with what you're saying, at least from my perspective. But yeah, so a great remark. We do not have this, I think, in these wording in our report, so you'll probably not find it. But thank you. Yeah.
Thanks again for the question. We have still time for some more. Do we have more questions online? From
We
the viewers?
do. If we could go over to Maurizio now, please.
Hi, everybody. It's Maurizio here from remote. First of all, I would like to congratulate for the excellent report. I read it yesterday, page by page, quite carefully, and believe me, despite of ending up last night after dinner, I still was enjoying, and I'm sincere. It's well written, better I would say than some of the spacefaring agency reports sometimes, and it's comprehensive, it's thoroughly, is thorough, I mean, is really addressing many points and educational. And also your presentation today kept the same level. So congratulations to all of you. And if you allowed me to your chairs, starting with Rob and the other. Then I have a small proposal to do. I mean, we are talking in the space community worldwide about astronauts, cosmonauts, taikonauts, and now we start talking about lunar astronauts. I would propose that we call from now on the lunar settlers selenonauts. Is a name, is a new name for the lunar. Now, going to the discussion points. First point, you address the arrangement of the interior. You gave some sketches of the footprint, and you also had the nice animation, the nice movie. Now, the question is very mechanical, very engineering oriented. Did you think about the mechanical connection between the floor and the upper stage and how to pass through the airlocks, which are quite narrow, the different elements of the floor and the walls? That's the first point. Second point, I really want to thank you for having addressed the Dartia example, which is very, very on the point. Now, as you have been brave in addressing that, I try to be brave addressing two discussion points on this element. Safety zones. So far in the community, we all have been using the expression, we declare safety zones. Now, the question is how to operationally handle a safety zone on the moon. On Earth, if you think, for example, a military building, you have the building, you have the safety zone, and then what we do, we put barbed wire and big banners saying, don't trespass, we shoot at you. Now, not going to this point, but on top of declaring a safety zone, operationally, what can be done to manage a safety zone? And the second point, still on the same example, you mentioned rightfully that the Outer Space Treaty declare the astronauts or also selenonauts envoys of all humankind, and all the signatories countries commit to provide all possible support to astronauts in distress. Now, let's assume, and that's a very serious question, let's assume that one of the Dartia or whatever astronauts and who has trespassed the safety zone is really in troubles, and the Rosas inhabitants genuinely want to help him or her. Now, the point is that unless the Dartia of this world and the Rosas of this world have agreed and implemented ahead of time a set of common interfaces, standard interfaces, and standard operational procedures, I am afraid that the inhabitants of Rosas can by no means, or would be very difficult, help, despite of the goodwill, the lost Dartia astronauts. They are my 3 points. Thank you.
Thank you for these great questions. I think we start with the floor and with the with the construction procedure. We most definitely thought about that a lot.
Yes, thank you for the question. Well, this was the biggest challenge we tried to solve at the beginning, because we said we just need the vehicle to be horizontal. Everything would be much easier after that. So we had a lot of ideas, and eventually we said, well, we have the 2 elevators going out of the airlock anyway. Like this is in the suggestion for the HLS by SpaceX. Why not use this system, use these cables, use the winches, use the fact that it's inside the airlock and is connected to the body of the vehicle to take the load from while it's being tilted. So the idea is the elevators are either really strong, or we over-engineer them to do this role, to carry the load while it's being tilted. So the cables have extra length on them, more than they need to just reach to the ground with the elevator, and they are anchored to the ground further away using the Morocco system, the drilling system. The assumption here is that we drill an anchor into the ground. I don't think it's too complicated. Might need some geologist to check how deep we need to go. And when it's being tilted, after a certain angle, the tension on the cable becomes very big. And there's a calculation of this in the appendix. So at about 30 degrees before it reaches the ground, there's the scissors lift mechanism that carries the load of the vehicle at this point, because at some point the cables theoretically need to have infinite tension on them.
Okay, thank you very much for your interest in our case of Dartia. And I'm very glad to answer your question. And if I miss anything, please remind me. So we have talk about the concept of safety zone. So this concept is not entailed in any of the outer space treaties. So the outer space treaty mentions that outer space is free for exploration and used by all countries in respect of their level of economic and scientific development. States have the free access to areas of the celestial bodies, and also states have the freedom to conduct scientific experiments of outer space. That is something that Dartia, in our case, wants to do, because it sends a scientific probe to want to conduct some scientific experiments within an area. So we are not we don't say that, we respect their right, respect their interest, but what we want to emphasize is that the safety zone concept is for 2 purposes. One is to tell us that we are conducting activities here, so we might create some lunar dust. If you come here, we might interfere with you. And if you come here, you might also interfere with us. So it is a mutual notification. And how to deal with this issue? I'm thinking to register to notify the UN that we declare this area as safety zone. We are not restricting access of any other country to go inside this area, but we are saying that if you go inside, there might be some interference, and it is good that you carry out some consultation with us to carry out some coordination to avoid this kind of harmful interference. So the safety zone concept is only to avoid the mutual damage caused by these countries. And for your second question, in our case, there's no astronauts in the Dartia probe, so it is a robotic probe. But your point is very interesting. If there's any astronauts in the in the Dathia. So if they are in distress, but at that point, the Outer Space Treaty says that astronauts has the obligation to mutually help each other in the case of distress. So our astronauts in that case will try our best, as long as the safety of our astronauts are not threatened, to render help to their astronauts if there's any. And I'm thinking that even if there's maybe no prior arrangement, but we can always prompt consultation on this, as this is human life, humanitarian considerations behind these concepts. I hope I've answered your question.
And on the hardware side,
may I still ask for on this last point? I understand the goodwill, of course. I totally understand. And the example I brought was in case of course, Dartia is unmanned. But my point is that despite of the goodwill, would be impossible or extremely difficult, almost impossible, to help somebody on the lunar soil by somebody else unless interfaces and procedures are not being agreed on Earth well ahead of time. Because, for instance, it's impossible to enter a different space station, a different station, if you have not defined compatibility. So my suggestion is that that's a strong, not a request, a strong suggestion to all the actors worldwide to meet and agree at least on these basic elements in order not to be confronted later on with the impossibility to help each other.
thank you. So there are similar situations happening already on the planet with orbital refueling and other situations where you need compatibility before you can do anything. Otherwise, you're just out of luck. You can't help at all. And Aidan has a few words on that.
Yeah, so this is one of the reasons we established the Rosas Lunar Authority rather than going with a completely entrepreneurship route, that it can better handle all the international channels and try to strive for the creation of international agreements, which could create universal interfacing standards. One of the things in particular with astronaut rescue that we thought about was how the pressure differences work upon entering the airlocks. So different international spacesuits have all had different internal pressures and different atmospheric compositions. One of the great things is that Starship is rated above 1 atmosphere pressure, which is far higher than any spacesuit would be, and that within the airlocks, we could change the composition and pressure of the air so that they could slip out of their spacesuits in the case of an emergency. And from there, we could lower the pressure down or raise it up to the internal pressure of
Just
the
2
actual
minutes
cabin,
left now.
bring them in.
Apologies for interrupting. 2 minutes left on questions.
But yeah, international interfacing standards are a big topic that we would like to explore more, and we have some safety measures in place that can help mitigate those.
So maybe to round it up, maybe we have one more question from Granada.
We have a David Kendall online as well. If we could go to him, you have 1.5 minutes, I'm afraid.
Okay, I'll be very quick. Thanks very much for the presentation. It was very well done. 2 questions that I have deal with governance and the whole issue that we're dealing with right now is the resource extraction and who owns it. So who owns the resources that you're going to get from your mining or your processes that you will be using? And how are you going to manage the governance of the Lunar Authority, which seems a real mess to me? Sorry to be blunt.
So that is a long question. That requires a long answer.
You have a minute.
1 minute left. Oliver, Aidan, who wants to go? Oliver, go.
So the Outer Space Treaty does not prohibit or allows the mining of the space mining activities. So in case there's no specific prohibition, we can say that we can interpret that mining is within the freedom of exploration and use contained in the Outer Space Treaty. So in this point, Luxembourg has made a very interesting analogy that is fishing in the high sea. So So although no one owns the high sea, like no one owns outer space, still countries can carry out fishing in the high sea. That is how our philosophy or analogy that we are drawn, that we can mine in outer space. We are not claiming any sovereignty over any land of outer space, but we are only like for the use of the resources for the support of our missions. Yeah, thank you.
There you go. Thank you very much. Your time up, I'm afraid.
I just want to congratulate this team. They did an amazing job. So really enjoyed the whole thing. And David, we'll have to get back to you on the authority question. That was a really good one. Anyway, we're going to have our half-hour break right now, and then we have our last TP in 30 minutes. So thank everyone. Thank you again.
No problem.
Because the other team says, yeah, we're just going to take it. And I said, well, that's how we usually do it. And then you weren't there. So when you asked me, I figured I wasn't put out. Yeah, you did a good job.
Two. Okay, fine. Sound check, sound check. Blue one, blue one. Sound, sound. It's okay.
Can you please make Letitia host of the Zoom room, please, Strasbourg?
Strasbourg, can you guys give us host? There's nobody in Strasbourg.
Yeah, the audio is working. No, on the video.
Okay. He's coming in, he's coming in. Give us a minute, give me 2 minutes. 2 minutes, it's too long.
Fiona, can we turn the blue level up, please, for the videos?
Hello from the children of planet Earth.
هل توجد حياة في كواكب أخرى في مجرات أخرى؟ أنا برأيي أكيد في لأنه مش معقول ربنا خلق كل
progetto sia qualcosa di
آینده
fondamentale
تاثیر
importanza
بذارن
per tutta
کم رنگ بکنه. بنابراین شاید اگر اطلاع رسانی بهتری از طرف دانشمندان و مهندسین اتفاق بیفته، آدمایی مثل من بتونن اعتقادشون رو به زندگی فرزندی بیشتر کنن.
Yaşadığımız evrenin sınırlarının da daha da genişlediğine şahitlik edeceğiz.
Granada, can you hear us?
Hey, Tam, I can hear you.
Thank you.
Okay, perfect.
Hey, Tam, can you make us the host?
I just did. The Wirecast
Ah.
machine is the host.
It has reverted back to your son. Make our son the
Okay.
host. That's okay, that's okay. Hey, Tam, it's the other one that you have given. You have
Are you more relaxed now?
Hey, Tam, can you hear me? Strasbourg.
We are here.
Hey.
Strasbourg, can you reassign host to us?
What do I say?
Okay, once again, welcome, ladies and gentlemen. So today we had 3 fantastic presentations so far for the team projects, and here comes the final one, team project number 1, hosted here in the University of Granada, Granada, Spain. So today we had a long journey, and now it's time to say eternal echo. So it's my pleasure to introduce you the team project chairs of the final team project, Reinhold Ewald, Niv Shao, and Adelia Drago.
Thank you. That was a good start. Actually, a couple of years ago, I think 2-3 years ago, I had to overcome a certain hurdle, a steep hurdle, that was logging into one of these innumerable databases of ISU and giving my proposal for a team project. And I proposed to go back to the times when Carl Sagan was sending messages into space and do it as a Mark II, as a 2021 version of it. I couldn't have imagined that that would lead me to walk along the Granada Cathedral almost every day with its coat of arms of Charles V saying, plus ultra, we can do more, we can go out, we can reach the stars. That was his motto. I couldn't have imagined that I would persuade my dear friend, colleague astronaut Gerhard Thiele to come and accompany us in our team project. He was the creator of the European Astronaut Charter, a thinking mind. I couldn't have imagined to meet those excellent co-chairs with me, Adelia and Niv. We were complementing each other in our abilities and our motivation to bring the team forward. And I couldn't have imagined that we would finally, after devising a journey out into the interstellar space, find us humans and the essence of us humans. So I'm very happy that those 18 young participants in the team project, actually it was 17 young and Guillaume, would take ownership of this idea and turn it in a marvelous journey out into interstellar space and back to us humans.
Thank you, Reinhold. So we've had 3 beautiful presentations so far. So congratulations, Strasbourg, and congratulations, our awesome co-teams here, TP Ag. Beautiful presentations this morning. And we're all about looking at the human message of space. So it's no coincidence that our presentation is slightly different, is that it's very human focused, because we've already seen today that some humans have already gone to Mars and back already. I'm a little bit out of breath, so is Adelia, and so is Reinhold, because we were just playing a game, because that's what we've been doing every morning for the last 3 weeks. At 9 a.m. we turn up and we play ball together, and we were bonding and we were spending time together, and the conversations we had in our TP room were really special. And we had fantastic guests join us and experts, and they all said they were astounded by the level of thinking and thought and care that went into every single decision that was made as part of our team. So we're tremendously proud of you all, including TP Ag, but we're especially proud of our 18 Eternal Echo Messengers. And we really want you to enjoy this presentation. It's the last of the day. This is your last time spending time together. Throw that ball of energy to each other. And thank you so much for giving me 9 weeks of tremendous fun with you all. Adelia.
Thanks, Neve. I'm going to end on the words of the original golden record creator, Carl Sagan. So inspired by Carl Sagan's notions of Voyager spacecraft, our only hope for this team of 18 dedicated participants is that beyond our civilization perishing even after, we hope that Eternal Echo stays largely intact and travels through the vast unknowns of this universe, carrying the message of what makes us human. Thank you.
Curtain up.
Susan, over to you.
Thank you to our amazing chairs and co-chairs. Hello, a big hello and welcome to everyone here with us in Granada, everyone watching in Strasbourg, and everyone watching online. We want to give you a huge, big, warm welcome from the team Golden Record 2.0 Eternal Echo and welcome you to our presentation. We are super excited to show you what we've been working on this summer. Before we begin, we're just going to reiterate, because of the COVID-19 pandemic, the team has taken some precautions like regular testing and isolating ourselves in a bubble for over 14 days. And we're also going to keep sanitizing our hands through the presentation. And this is to allow us the flexibility to take our masks off so we can actually enjoy presenting our work to you today. So let me give you a quick preview of what you expect to see today. We've implemented a 3-act structure. So we're going to start by posing a very intriguing challenge to you. Then we move on to the expression we chose to take to tackle that challenge. And then we finally end with our big reveal. So we want you to get comfortable, get excited, and we hope you have a great time with us today.
Hello from the children of planet Earth.
Hello. Hello, everyone. My name is Joshua. And to start us off today, I'm just going to take us through a small snapshot in history. In 1977, the Voyager mission was launched to the outer solar system. It consisted of 2 spacecraft and taking an opportunistic alignment of Saturn, Jupiter, Uranus, and Neptune. The spacecraft were able to fling themselves not only into the outer solar system, but into interstellar space. Given this fortunate encounter of the planets, the visionary Carl Sagan brought together a team of artists, scientists, engineers to perhaps create a message for any form of extraterrestrial life that may encounter these spacecraft. Known as the Golden Record, the object tried to encapsulate humanity and the Earth for a series of sounds, images, etchings, pictures, to any form of extraterrestrial life that may encounter it. Inscribed on the surface were instructions that may be interpreted from beings that may be or may not be similar to our own. Given that this happened more than 40 years ago today, we took it upon ourselves to give a contemporary perspective of how we would encapsulate a message to those beyond our Earth. To introduce you to the team and to give you some initial introductions to ourselves, I'd like to invite Caroline to the stage.
This is us. This is Team Eternal Echo. We are 18 participants, 4 chairs, and 4 teaching associates. We represent 14 different nationalities and come from 7 different disciplinary backgrounds. We were fortunate enough to have an engineer, a science communicator, and 2 astronauts guide us on this project. Looking at this map, you can see that we come from many different nationalities. The dots, the scattering of dots highlights our diversity, but it also emphasizes that we're only covering the tiniest fraction of our globe. In our attempt to capture what it means to be human, we need to acknowledge our own biases and limitations. We are all academically trained and scientifically fluent. And just like you, our audience today, we are space geeks and we believe in the intrinsic value of exploring the universe beyond our own horizons. And in our attempt to be the first to contact extraterrestrial intelligence, we are assuming that there's no alien beings among us here today. And let's not forget that we are human, and ask 7 billion people what that means, you would get 7 billion different answers. But today we present you with ours. This is the Golden Record Mark II. This is the Eternal Echo. And now, to show you some of our initial considerations, I present you with Lena, David, and Elif, who will go over some of those.
Thank you, Karan. By going through the process of creating the message, we considered that in order to have the message being understood by potential recipients, it has to be captured and decoded in the first place. So we assume that their technology and intelligence level has to be similar to ours. At the same time, we also consider us, humanity, as recipient, because thinking about a message which should represent humanity forces us to think about what it means to be human. David.
Thank you. Philosophy. About philosophy, we're going to tell you just a couple of conclusions, since in the end, philosophy is everywhere. A small part of our philosophy is present at any section that we are going to show you today. But we would like to highlight now that there is an inherent possibility that our recipient could be malicious, which calls to some caution in the content of our message. However, we think that the message should not be dominated by fear or concern. We seek to send a message to foster mutual collaboration in which both parties could balance without damaging or degrading the other. Liv?
Thank you, David. Well, where there is an attempt to communicate, there is obviously diplomacy. The Eternal Echo aims to build a unique model of diplomacy, emphasizing internationality, interculturality, and interdisciplinarity. We hope that it will be contributing to reveal our current barriers in both earthly and exopolitics. Our approach is to have a peaceful communication with our cosmic neighbors while showing human capabilities. David?
And now, for the knowledge of the humankind, our mission statement reads like this. Our message aims to portray our human essence as part of the universe, with the hope of connecting with other intelligence among the stars, and to allow our existence and memory to endure forever throughout the cosmos as an eternal echo.
Our goals and intentions are rooted in exploring potential and successful communication methods for 3 reasons. First, we want to make sure that our message is understood by alien species in the highest chance. Second, we want to project a good snapshot of Earth. And finally, we hope to establish a peaceful interplanetary relationship. But how is it possible? Is peaceful relationship guaranteed? What do people think about it? Let's look at it.
هل توجد حياة في كواكب أخرى في مجرات أخرى؟
Personalmente credo che il vostro progetto sia qualcosa di fondamentale e importante per tutta
کم رنگ بکنه. بنابراین شاید اگر اطلاع رسانی بهتری از طرف دانشمندان و مهندسین اتفاق بیفته، آدمایی مثل من بتونن اعتقادشون رو به زندگی فرزمینی بیشتر کنن.
Yaşadığımız evrenin sınırlarının da daha da genişlediğine şahitlik edeceğiz. Bu başlı başına çok
Cela fait évidemment appel à la science, mais soulève aussi des questions philosophiques autour de la transmission et de notre place dans l'univers. Quand je regarde votre projet, je me demande ce qui fait rêver les gens dans
Zum Beispiel Arthur C. Clarkes Geschichte vom Sentinel auf dem Mond, der ein Signal schickt. Heute überlegen wir, wie wir ein solches Signal schicken können, und wir geben es
If I have unlimited storage, I would want the next 10 years to figure out what I was going to put into it.
Huge responsibility. Where do you even start? How about we start with a concept, a fundamental concept, time. Some people would say that time is the most precious thing a human can have. And we don't have a lot of it. I mean, in comparison to the age of the universe, 13.77 billion years, the lifetime of a human being is not that much. And also, it's finite. So how do you explain time? How do you explain the fact that our life is finite? If you look at the comparison in the universe, we can look at stars. Stars are born, they have their life, and then they die. The same goes for us humans. We get born, we live our lives, and then we die. This is our cycle. And on average, our cycle only lasts 80 years, 80 rotations around our sun. And everything we do fits in those 80 years. We laugh, we cry, we love, we do all these things. And everyone does it differently. We have 7 billion people on Earth that experience those 80 years completely different. So what is it that connects us? What makes us human? Jacqueline.
Much of our humanity is actually based on small, very incremental evolutionary steps that we've taken as humans along the path with other species. However, what makes us uniquely human is how our evolutionary steps have created us to be uniquely human. Whether that be specifically where our femurs attach to our hips, causing us to be able to stand and run, or the curvature of our lower backs, which makes us be able to run fast and far and actually stand for longer periods of time, all the way up to the way that our spinal cords connect to our skulls, in a way that has evolutionary made us be able to process more sensory nerves coming into our brains and then motor nerves coming out. All of this is our unique processing power. And fascinatingly enough, through our greatest point of challenge, through the Ice Age, was when we ended up growing the most. It's when our bodies and our brains grew to the capacity that we actually see them similar to today. Within that increased processing power, specifically within our forebrain, is where we actually find the brain behavior echo. The information of all of our sensories, of all of the knowledge, all the communication coming into our minds, being processed, and then being executed through our behaviors as the echo into our societies, our lives, our families, our stories that we tell. And it's that specific echo that we find to be uniquely human in our ability to believe, both in the real, things that we can physically sense, touch, feel, but also in the unreal, things that are not physically in existence, our ability to create abstract thought, as well as collective fiction. As we were researching this topic, the term collective fiction came up time and time again, as it's the belief in something that we cannot physically hold or know in any capacity, which makes us uniquely human, the ability to be able to think at that level. And being able to think at that level makes us be able to tell stories to one another about religion and government and currencies and create these abstract concepts that guide our humanity forward, that push us forward, while also creating great harmony within our societies and occasionally tragedy. As aside from that, that collective fiction that we create within our societies fosters great emotion, fosters great action, fosters that brain behavioral echo that we see through all of our emotions that are being displayed on an ongoing basis.
As a species, we host a fantastic and eclectic array of cultural diversity, but we all have a shared common experience from birth to death and our collective fictions. On the fundamental genomic level, the percentage of differentiation between us is minuscule. It is our mind, our thoughts, and our feelings that makes each one of us unique. That we are all so different, yet also the same. This is the paradox of humanity. And how do you encapsulate such a paradox into a message? That was the challenge of our team project. So consider with me, what makes us brilliant? It is our consciousness, our individuality, our personality, our capacity for the intimate. This is our essence. At the heart of all art is the effort to communicate the intimate. That is why, for our message, we decided to include intimate artifacts, echoes of our emotional inner world. And as a species capable of contemplating vast concepts like the extent of universal timescales, our own individual mortality, and the one-day potential demise of our species and civilization, we can consider it a responsibility to create such artifacts. So enduring evidence of our consciousness, emotions, creativity, curiosity, our endeavors and our hopes and our dreams can endure, can go forth in the hope of one day meeting another form of consciousness with the purpose of saying, we are here, we feel, and you are not alone. So now I'll introduce Isa, who's going to take us deeper into our emotional worlds.
Thank you, Ina. And yes, as you said, we feel. And now I want to do with you a little experiment and feel all together a special emotion at the same time. We will start a little journey into the inner human universe. So follow my instruction here in Granada, in Strasbourg, and audience online as well. All together, close your eyes. Close your eyes and think about your greatest achievement in your professional or personal life. Could be when you had your desired job, or when you saw your dreams start to become true, when you faced up and overcame a very difficult situation with just your own interior strength. So take the first moment that comes into your mind, close your eyes and focus on that moment. Focus on the visual aspect. What do you see? Where are you? What do you hear? What was the smell or the taste of that moment? Who is with you? Focus on your physical feeling, your position in the environment, the temperature. Leave that moment in your mind. Now switch your focus on your inner feeling, your emotion. What do you feel? Maybe you are very happy and proud of yourself, very satisfied, or maybe surprised of your own abilities and capabilities. Or maybe, almost in tears of emotion. So find where this emotion comes from into your body and focus on it and let it grow stronger and stronger with every breath you take. Feel it. Now I'm going to count down from 3 to 0. Keep your eyes closed. And as soon as you feel and remember that emotion, please stand up. So 3. Let the emotion grow. Feel that moment. And 2. Breath. Feel the emotion. 1. And slowly stand up. Now, open your eyes and look around you. We are all different. We came from different nationalities, culture, traditions. We are all different, but similar at the same time. We share common emotion, common experience. So let's go beyond our cultural diversities or physical diversities and send our common experience through the universe. Thank you for your collaboration. And now I let Joshua continue our journey into the inner side of the human and let to present the 6 fundamental emotions of our life.
When I was young, I used to like to explore, something I still enjoy today. When I was growing up, I went to my friends and an abandoned factory. We knew it was haunted. We did, but still exploring anyway. Some loud winds, large steel doors opening and closing, and I was scared. I was scared, not just of being hurt, or being attacked. Susan?
My grandfather and I were very close. He helped raise me. One day he got very sick and it just kept getting worse. I stopped seeing him. They said he had to be in the hospital. But I insisted I wanted to see him. I found a shell, a ghost, a very thin version of a man I used to know. I was very scared and I froze. Habibat Elbi, love of my heart, he reached out to me. Everyone panicked, he wasn't supposed to move. Those were the last words I ever heard. And that was the last time I saw him. I won't forget that moment.
Thank you, Susan. I remember stepping out of the car and suddenly there's dappled sunlight on my face. And I see chickens, sheep in the field, and there's a pen of piglets in front of me. And in the distance, I can hear the whoops and cheers of my friends swinging from a swing under the most beautiful tree I've ever seen. I go over to them and we play together and we run through this meadow like the Garden of Eden and we spend the rest of the day playing under a waterfall. That was one of the most joyous and free days of my life. Christian?
Now, I remember on one of my travels a couple of years ago, I was visiting a zoo and I decided to go through the monkey key. But when I got there, I found the place in very ill repair, quite desolate, and the monkeys frantically screaming or lethargically sitting in a corner behind the cage. And as I was walking through, one of the monkeys approached the cage doors and stretched out his hand. And I looked at it and it had these very empty gaze in his eyes. And in that moment, I felt a very hollow feeling coming up in my stomach. And I had this deep disgust with what humans would do for entertainment. Sasha. Hello? Oh, hey, I haven't talked to you in, what, must have been like a year or something? How you doing? Oh, slow down. What do you mean sign papers? I'm not signing any papers. Look, I'm not signing anything until you tell me. I'm going to be a father. What a surprise. Oh, Miles, my child.
Thank you, Sasha. When I was 6 years old, I made a huge mistake. My mum had recently crashed a car, and we had a brand new hire car parked on our sloped driveway facing the house. And she was struggling to put down the handbrake in the last few days. So one morning, I decided to go out to the car nice and early and put the handbrake down for her. But then the car started to pull forwards, going faster, gaining momentum, getting traction. It was heading towards the front door, and then suddenly,
you almost killed me! Naughty boy!
All right. Thank you, everybody, for sharing these emotional stories with us. But how might we capture such an elusive concept like an emotion? How do emotions materialize? For that purpose, let us take a look at the brain. And for demonstration purposes, we have invited with us tonight a very special guest. And he has kindly agreed to be dissected live on stage, ladies and gentlemen. Not to worry, he will not be harmed. Please, I give to you Andrew, our virtual android. Right, it seems Andrew lost his keyword a little bit there, but he will be summoned in a second. There you go. Hello, Andrew. Now, the app has provided us with a male specimen. And as we look at the brain, if you might zoom in, please, Guillaume, we can see the outer layer, the cortex of it. And the cortex is typically associated with perception, with speech, with personality, with complex thinking. But then, as we go into the deeper layers of the brain, we reach areas that are evolutionarily much older. And these areas comprise the limbic system. The limbic system is absolutely central to the projection of our emotions. So it is in these structures and in the interplay between all of these structures that our emotions project onto the brain. And we share these structures as humans between us. We might hope with modern brain imaging technology like functional magnetic resonance imaging to capture brain activity that is associated with this interplay in emotion. And it is in this way that we hope to capture and to portray on our eternal echo the inner worlds that make us human. I give it on to you, Guillaume.
Thank you, Christian. Since more than 100 years, since Charles Darwin, we used to consider that humans were the top of the evolution. You always have seen this at school, the monkeys and the human and the bacteria at the bottom. But since 20 years, with the progress of genetics, we know for sure that we are a part of 8 million species that we know for now. And we know that we know just a little of this enormous biodiversity on Earth. Behind me, this is a phylogenetic tree. This is the most accurate, for now, representation of the tree of life. And we are here. This little blue arrow behind me is the representation of the genome of the human. You may think that this is a simple representation, but this is not. Because if we took a deeper look in 3D, we can understand the complexity of life. This is just a simple representation of a little part of the phylogenetic tree that I just show you. This is just a few, less than 1%. I mean, you can see how many ways life can take. And here we happen. We don't know exactly how, we don't know exactly why, but here we are. On the top of this branch, of one tiny branch, there's our human genome. This is just the beginning of the complete sequence of the human genome, 4 gigabits of raw data that we collected since 20 years from the Human Genome Project. This is the latest one. And this raw data doesn't mean anything. This is why you choose this representation with the chromosomes and the data attached to the chromosomes, because we are both physical and metaphysical beings. These chromosomes are cells, in definitive, are complex molecules. And the representation behind it shows the amount of data that each chromosome contains. Thus, this is just a way to represent what we are at a biological level, just our common ground, and also what makes us, every one of us online at Strasbourg here, unique, because you never existed and you will never exist after because of this complexity of the genome. Yeah, so here's Ina. I just explained to you where we are in the tree of life, but we are on the planet, and this planet in the universe. So Ina will explain to you where we are in the universe. Thank you, Ina.
Thank you, Guillaume. So yes, as you've heard, the basis of our message is we are here. But where is here exactly? When you try to comprehend our position in the galaxy, you're confronted with immense distances. That is why we chose to use a logarithmic map to show the scale from the very core of our planet to our outer solar system, to the heliopause, to the Oort cloud, all the way to the edge of our Milky Way galaxy. With this, we can give an accurate picture of where we come from. But this representation alone is not enough to locate us from anywhere in the galaxy for the timescales we require to be eternal. That brings us back to an ingenious concept devised for the Pioneer plaque and the original golden record, the pulsar map. But with one very important update from over 40 years of pulsar astronomy, the discovery of millisecond pulsars. Millisecond pulsars are not only so much faster than regular pulsars, but they spin down so much slower, 1,000 times slower. That means that their unique frequency fingerprints encoded on the map in binary will remain recognizable for not a mere 10 to 100 million years like the original pulsar map, but billions upon billions of years. That is what it means to be truly eternal. So now you've heard our message from what makes us uniquely human, our perception of time, the inner workings of our emotional world, our neurology, the biodiversity of Earth, our genome, and finally our place in the universe. This is our eternal echo. So now you can listen to the eternal echoes of the pulsars that are going to help find us.
Wow, okay. This is difficult. So we've got to try and work out a way to encode that much information into something that we're going to send into interstellar space. Right. The original golden record had a gold-plated vinyl record and some information scratched onto a cover. That's not enough. We need more than that. We can't do what we want with that limitation. All right, how could we possibly do this? I'm not coming up with anything. Has anyone got any ideas? Eloy.
Can we put a video on a USB stick?
A video on a USB stick. It's not a bad idea. It's a lot of storage capacity and it's quite cheap. The problem is that they don't work very well in space and it's probably not going to survive much beyond Earth orbit. So I think that one's a flat no, sorry. Anyone else? Caroline.
Can we maybe send some tasty food up into space to represent the taste and smell that we have down here on Earth?
I think the aliens would probably appreciate the gesture, but all of the foods that we eat are composed of very fragile molecules. They're going to disintegrate in cosmic rays really quickly. Also, flat out, no, not going to work. All right. Anyone else? Nina.
What about sending messages on electromagnetic waves with different frequencies?
Electromagnetic waves broadcast from the Earth. I mean, it's not impossible, but the problem here is that we have a really bright beacon very close to the Earth. It's called the sun. It's broadcasting in all the radio waves and all the waves of the electromagnetic spectrum already. For us to have a beacon that is brighter than that to be obvious to the aliens, we'd have to have a power source better than the sun. And no, we don't have one of those. So that's also a flat out no. Oh crap, all right. This is more difficult than I thought. Anyone else? Christian.
Paul, what about more modern storage technologies? For example, I've heard of crystal cubes being used as storage.
So this is like the 5D crystals. Right. Yeah, the problem with those is that they create, the data is stored by creating imperfections in the crystal. These are unstable locations, so that's not going to last either. That's not a suggestion. Try again.
So what about DNA then? DNA is pretty stable.
DNA is pretty stable in a stable environment like on the Earth, but it's not going to work in space. No, that's not a suggestion. Oh, geez. I'm really starting to run out of ideas. Have we got anything at all? Anything?
What do you suggest? That we carve stuff in stones then, or what?
Hang on, could you repeat that one more time?
Carve stuff in stones.
Carve stuff in stones. This is inscribed matter. You know what? I think you might be onto something. I think this might just work. What we could do is encode the data that we're trying to send into deformations on the surface of a material. And as long as the material is up to the task, then we can send anything we like. I think we've got a winner.
But wait, isn't that exactly what they did on the Golden Record?
I mean, well, yes, but we're going to do it way better.
Woo! Woo!
And this is our eternal echo. So on the outside of the disc, you can see the big versions behind me. On the outside of the discs, you can see we've got a lot of the information that we've talked about already encoded, or engraved rather. We have the human genome, we have the figures of the humans, the shape of the DNA, the phylogenetic tree, and some of the representative species from there. On the other side, we have the key and our location in the galaxy. And to go into a little bit more detail of how we came to the conclusions for the rest of it. Oh, sorry, missed a bit. On the inside, ooh. This is where we put all of the high density information. So this is where all of the videos, the images, the MRI scans, the exhibition of experience, and everything else is going to go in here, etched into very small scale details. So to go into details of how we came to these conclusions, I'll pass it on to Nicola and Dor.
Thank you, Paul.
so many emotions when we look at the eternal echo, right? Don't you agree? So let's have a look at the structure, the physical structure of the eternal echo first. Okay, as you can see, the eternal echo is made of 2 disks, but already the size is an additional information. It's a clue to the extraterrestrial intelligence. The diameter of the disk is 21 centimeter, which is a reference to the wavelength for the hydrogen spin flip hour encoding key. So these disks are made of gold. You must ask, why again gold? Well, if you understood, as we understood with Paul, only stable metals, also called noble metals, will survive 100,000 years in outer space. And for instance, nickel is not one of them, because at some point in time, there will be an oxide layer at the surface, making the message totally unreadable. Gold is one of them, and gold is the heaviest, meaning that it can resist the best to radiation in space. So at the surface, as you understood, we're going to engrave the information, and for this gold, we're going to use manufacturing techniques inspired that were used and developed in microelectronics that just didn't exist 44 years ago when they created the golden records. And this information, these manufacturing processes can enable us to engrave information until the sub-micro scale. This is what we can store so many informations. Additionally, this information will be protruding, meaning that we can touch it, you know, a bit like the Braille writing system. Surrounded, there will be like 5 boxes, and in these boxes we'll have radioactive elements that will be at timestamps for them to know when the spacecraft was sent in space through the radioactive decay. And finally, as you see in the animation, we will have some multiple 1 millimeter thick aluminum shields that will give extra protection, in particular to absorb the impacts from any micrometeorites. So this was for the technical. Dor, the floor is yours.
Thank you. So we talked about the physical form of the golden record, of the eternal echo. Now we need to talk about how do you actually encode the data on the record. So how do you communicate with a life form, an intelligent life form that you cannot even imagine how it feels like, how it looks like? It's a difficult question that we had to think about a lot. How do you communicate with somebody or with something that you cannot even imagine? So our idea was to use mathematics. And this is because mathematics are commonality all around the universe. Mathematics is not something that you develop, it's just something that you adapt to. Mathematics should be common all around the universe. So we devised a system using binary system, which is probably the easiest and simplest way to represent mathematics. And as you can see on the top of the slide, we created a dictionary containing all our numbers from 0 to 10, hinting that we also use in the decimal system, 10. Below that, we deceived the basic arithmetics, providing them a way to understand how we use our mathematics, multiplication and addition. And we also provided 3 ways to validate the understanding of the arithmetics using commonalities of geometry, like Fibonacci series, circumference and area of a circle, and Pythagoras theorem. Below that, in order for them to able to understand how we decoded the images, the pictures on the golden record, we devised another system using 16 grayscale levels, and also using grid of semi-prime number amount of bits, in order for them to be able to guess, even if they did not understand the bitmap, did not understand the idea of a bitmap, they will be able to understand the factorials of the bitmap, and by that method, be able to reconstruct the image and to decode the image. So this is what our idea of the decoding system was. And after now we discussed the physical aspect and the logical aspect, I would like to call Susan to compare the 2 golden records, the previous golden record and the current golden record, and to summarize the entire solution.
Thank you, Dor. Isn't it pretty? So, to summarize, you can see that we've drawn inspiration from the golden record. We see similarities. For example, we are also using radioactive isotopes as our timestamp, but we also see some changes, both in content and technology. For example, in our technology, we have used micro and nano etching to store more data, and we're using an improved millisecond pulsar map as our eternal location. And for content, we chose to focus on what unites us and what makes us human. So that is why we chose to include how the brain reacts to human emotions. This just truly shows how brilliant the design of the original record was, and we hope our work pays tribute to its mark. I'll now pass on to Miles and Guillaume, who will tell us what's next for Eternal Echo.
Thank you, Susan. Okay, how are we all feeling? We all excited? Yeah? Excellent. So me and Guillaume are here to tell you about the future of the Eternal Echo project, because it's in our hands and we want to do stuff with it. So basically, if we are able to implement our vision, which is being able to integrate the Eternal Echo onto a mission and launch it, then we believe that this will represent one of the most culturally significant moments of the 21st century, to rival that of the golden record in the previous century. But how do we do this? Well, we need to transition from being an ISU project to being an independent organization that is capable of creating the record and then integrating it in the future. And so in order to do this, we've been searching outwardly to identify potential mission opportunities that we could integrate with, research funds as well to support us on this journey, and then also key partners as well to help us along the way. But additionally, we've been looking inwardly and trying to work out how do we sort of continue as a team, how do we organize ourselves, how do we structure ourselves, given that everyone will, after this SSP ends, be most likely going back to their day-to-day job or back to academic studies. So we've been trying to work that out as well. And all these things that we've been doing at the minute are sort of the background activities before we create our business plan. So in the near term, what we'd like to do is to join a pre-incubation scheme, form our business plan, and then join an incubation scheme later on, and then continue off into the future. So in terms of our general plan, we've got 3 main stages. So this includes the announcement phase, which is exactly what we're doing now. We've got the organizational phase, and then we've got the research phase. And in terms of our announcement phase, we've already begun organizing all these different communication methods and things that we're going to be doing to share Eternal Echo with the world. And this includes, conferences, events, podcasts, radio slots, and even news articles. So we're really, really excited to be part of. And then it would be a shame not to also mention our open call that we're going to be announcing very soon at the IAC. And within this, what we're going to be looking for is the support from the global space community to identify research funds for us, to identify mission opportunities, to help us communicate the Eternal Echo with the world. And also within our open call scheme is our open science project.
Exactly, Miles. We are a team from many countries. We are intercultural, but we also are very open-minded. And this is exactly why we don't want to keep this project for ourselves. Many scientists around the world agree on the fact that the future of science is open science. We don't want people, teams of people around the world to redo what we've done during this 9 very intense week. We want them to start their own projects on what we did to improve it and update it. Because if we have a launch in the next 2 years, or 1.0 message could be the right one to represent humanity. But if it's happened in 20 years, technology will have evolved. Society will evolve too. So this is very important that each year, iteration of the project happens. So the project is always ready when the launch window can open. The many platforms exist, and we really want to make this project bigger than we are as a team, as individuals. Also, I would like to ask you a last question before the end of this presentation. And if you can go back to your home with this question in your mind, we would have succeeded in something. What does your eternal echo would sound like But before finishing this presentation, we would like to introduce you to our own version of the personal echo.
We are here. We are here. We are here.
Who are we? Humble or selfish, to wanna leave our legacy. Where are you? Are we all on for all eternity? Are you listening? Are you listening? United, we are here. United, we are here.
Thank you, everyone. We are now open for questions. Any questions here from Granada? Does the jury have any questions?
Yes, online.
Is one hand up? Lamina?
Thank you. I really appreciated the whole concept of an intimate artifact. I love when I learn something new. And I liked and appreciated how you sort of mimicked your thought processes and you invited us in so that we could almost understand your struggle. Like that one time where one of your colleagues was saying, oh yeah, no, that's definitely a no, and food and how can we do this? My question for you, when your one colleague said, yes, it is similar to the original record, but we're going to do it better. Can you define at the end of your project now how you did it better? And even what is the definition of better? Thank you.
I guess that's one of the advantages of using vague terms. You don't necessarily have to define them. What we were aiming for in making it better, and what we were referring to specifically, is mainly there were a few weaknesses in the original design. For example, it was a vinyl record that was gold plated, and the vinyl is actually going to decay relatively soon in the journey of the record. The gold plating itself will remain, but it's going to be a very fragile artifact at that point, and any information encoded on it is going to be really quite difficult to get out. So what we've done is instead used a solid piece of gold and etched directly into the surface of it, rather than having any sort of plating layers or anything to get in the way. We've got a much higher data density, so we can fit a lot more information on there than was possible to do with a vinyl record as well, of course. But that's the kind of things that we were aiming to improve upon.
Hi, thank you. I think this is a very great question, and I think it actually echoes one of our other big struggles, which was defining certain terms. When we're talking about a peaceful collaboration, we had many discussions within our team what peaceful means, because even on Earth, we have so many different definitions of this, and what does life mean? So I think really the essence of our project is thinking through all these terminologies that we use. So even though we might not always be able to give a simple explanation, we do hope that we have at least showcased what our intentions were on this one.
We also try to focus on what unites us rather than what separates us. And we really had to dig down deep to what that means. Any other question?
If I may, from Strasbourg, Walter Peters here. I very much appreciate the philosophical background, the way you tackle it, but allow me to come back to my my trade, which is business, legal. I really appreciate that you say we're going to go into a more pre-incubation time, and you're welcome here in ISU. You will be really welcomed here. But then there are a few things which I think you will have to think about. To try to find scientific support for this and scientific grants for this is probably a little bit idealistic. Look what happens with SETI and what about other projects. I think they are you're missing one place on your design, which is the logo of a sponsor. You probably need a sponsor, and most of the time I'm thinking for a project like that on somebody who wants to have a legacy, who wants to have his name traveling for millions and millions of years. I immediately think about people like Bill Gates, who are buying books of Da Vinci, so he's able to spend a lot of money. That's probably all your best chance. I don't give you a big chance via research grants, to be very honest. So that's one indirect question, or what direct question referring to my financing lectures. Have you thought about how to approach a very, very rich person to sponsor this, or a company like Google, who are also sponsoring a number of things? And the second thing linked to that is, have you considered or have you thought about patenting your design? Are you not afraid that somebody finds this a very brilliant idea and is going to steal the intellectual property of your design? So if you go into incubation, will you patent? And what would be your approach to find a sponsor and not research money?
Yes, I completely agree that approaching a high net worth individual or organization could potentially lead to funding the key research elements, and then also the integration and manufacturing of our golden record. So eternal echo. But having a look at industry and what other research foundations have done in the past, for instance, the Arch Mission Foundation actually crowdsources a lot of their time capsules that they have launched previously. So, for instance, they've launched time capsules to the lunar surface through partners with SpaceX to the Lagrange points, and then also into low Earth orbit as well. So that was one potential funding source that we examined. We would also approach these organizations, as you mentioned, by being able to announce this at things like IAC, asking for funding. Then I think this is a good opportunity to do that. And then in terms of the patenting and such like, it's not something that we've considered so far, but it is something that we'd have to think about if we're going into an incubation scheme.
Okay, thank you very much. And as I said, if you want a place to be, the real good place to be as an incubator, come to ISU. We will be welcoming you with this beautiful project, I can assure you.
Thank you, Walter.
Any other questions? We have a question from YouTube. Will you release the artwork as open source Creative Commons? This way more people can share it.
Hello. This is Joan calling also from here.
We can hear you. Hello?
Calling from planet Earth. My question is, has any member of the team read the ISU Credo? And if so, how has it inspired your work? Very, very good show and inspiring presentation.
We are very familiar with the 3 I's of ISU, and we try to showcase them to the best of our ability. Whether we read it word for word is a mystery that will remain between us.
If I may try an answer, the interdisciplinarity of this project is gigantic. This contains both biology, philosophy, engineering, diplomacy, interculturality, interdisciplinarity. The 3 I's are in it, and there's no project possible that because we try to capture the human essence. So all humanities, I mean, the history, the literature, the painting, the sculpture, all the arts are included. Also, this is a statement of technology, because I was amazed how the team were able to manage or to find a way to encode literally gigabytes at least of data in a piece of gold. I didn't think it was possible, but they tell me, well, we can put some hundreds of gigabytes. How did you do that? So yes, maybe this project is the most possible, the most I was about to say interplanetary, because this is also interplanetary. So we're adding a 4th I, which is interplanetary. Yeah, yeah. Interstellar, yeah, even better.
Any more questions?
Hi, this is Gary Martin. Can you hear me?
Yes, we can hear you, Gary.
Oh, great, thanks. This is kind of a question that whenever I hear things like this, I really liked what you had. It's a very hard subject, and it must have been a lot of fun to work on. And I really like the solutions you came up with. But there's something I always wondered is there a danger to telling other intelligent forms of life too much about us, that we exist, that we're here? We tell them exactly where we are. We tell them give them a lot of information about what we do. Did you have any discussions about that?
Yes, we have thought a lot about this question. And to answer this question, we must start doing an assumption that is that we as humans, we are part of the universe. We are made of matter, energy. So we are the universe itself. Due to our intelligence, we are the universe itself trying to understand itself. And who are the others? The others are similar to us. So they are also the universe itself trying to understand itself. So the question is, do we have the right to avoid this communication between both parties? Because at the end, the communication between both parties, because both parties are the universe, will foster the evolution of their own universe and the understanding of their own universe. So we think that we need to foster this communication between us and the aliens, and we will help the evolution to take place in a natural way, as it has happened in the past. For example, when all civilizations enter in contact, and sometimes some civilizations are damaged, other times other civilizations are not damaged, but at the end, the evolution of the universe happens always with the contact between different life forms and different parts of the universe.
Thank you for the question. That is an amazing question, because we had to deal with this part of the regulation and legal and policy framework a lot. There's an additional point actually to what David said. We are actually apparent. Our place in the universe is already apparent. So we already had previous missions that had few attempts to communicate, to just reveal our presence in the universe. And also we have many radio waves. So we're also apparent, we're already apparent. So the question was, why we're doing this? Because we're already apparent. I mean, like, what is the point? The point is, we are trying to make a good impact in a change, in a really beautiful, peaceful direction than actually the previous missions had. So this is our way to change the direction for a good impact.
Thank you very much. Appreciate your answer.
Any other questions?
Well, if everybody's hesitant, I allow myself another question, if you don't mind. And it's a question I've already been asking myself for many years, even when Carl Sagan explained the rationale of his first plate. We build up the rationale that other people understand it based upon our rationale. Give you an example, we have a decimal system because we have 10 fingers. So if we send a plate to a species which has, let's say, 8 fingers, they will have a complete different system probably, not a decimal system. So the basic philosophical question is, how can we be sure that the message that we are conceiving with our experience and with our mind can also be understood by completely different people or completely different species, which maybe are not even based upon a carbon thing, maybe on a silicium, or have a complete different way of brain structure, looking at different. So how sure are you, or how sure was Carl Sagan that his message was going to be understood by completely different species?
If I may take this one. The short answer is we can't guarantee that they will understand what we're sending or that they will decode our message the way we expect them to. We had a lot of discussions about the type of intelligence that these extraterrestrial intelligent life forms would have, the assumptions that we are making, that they would even understand the methods or the keys that we're encoding. And we had to come to a conclusion of, well, we cannot assume and we cannot guarantee the type of intelligence that they have. What we can do is go with what we think would give us the best chance, which is what we know we have in common, our shared universal laws of physics and math. Because the only thing we can guarantee is that they share the universe with us and they're under the same laws.
Also, on the more technical side, we did not assume that they have any counting system less than binary because as you said, we do not know what they look like, how they count, how they think. We try to give some clues that we use the decimal system. We included the picture of our 10 fingers on the dictionary, and we all provided a dictionary containing 0 to 10, just to give the idea of our counting system, but we do not rely on it. We rely on binary system only. This is because binary system should be, or with the highest probability, will be understood universally because it's the lowest counting system possible with integers, with 0 and 1 logic. And this is just to increase our chances to be understood. We cannot assume any other counting system.
Thank you for the honest answer. It's correct. You can only do a best attempt. You have no guarantee, but at least you're aware of it.
This was one of our basic assumptions, that they have to be in the same intelligence and technology level as we do, because we can't think of something more advanced than our brain gives us, or less than what we have. So it has to be in a certain range. We try to explain what we do. We give them keys and hints, but we can't think of something more intelligent than we can. It's like a usurper.
And in a way, it echoes the whole sentiment behind the golden record and eternal echo, which is hope. We always came back to, we just are sending this on the hope that someone will find it and they will understand.
And what we try to do with our dictionary is to provide as many ways as possible to validate understanding, using multiple clues from geometry and math for them to be able to understand that they got the message, that they understood what we were trying to say, using commonalities like geometry, like prime numbers, things that should be understood everywhere to every intelligent life form that understands math and is capable of creating and to capture a spacecraft. This is our assumption. Also, it doesn't matter how much time it takes the life form to get the message. If it takes years, it's okay. We're talking about completely different time spans, millions of years, and a few years is negligible comparing to the millions of years. And lastly, we try to encode the data in as many forms as possible, using tactile information, visual information, and also we discussed a little bit about using sound in order to be able to encode it in as many ways as possible. If the recipient does not have visual capabilities, it might have tactile capabilities or hearing capabilities. We try to provide information in as many forms as possible.
Yes,
Thank you very much. I see Philomena also has a question.
Thank you. I just don't want to take anyone else's opportunity. May I go ahead? All right. Can someone remind me, there was the announcement phase. What were the other two phases again, please?
Yes, there's the organization phase and then the research phase as well. So the organization phase is really where we create our business plan within an incubation center. And the research phase is really where we conduct our key research activities. This includes sort of the material science, the MRI scanning, and then the potential integration into a mission as well. Thank you.
So given that, I really appreciate this whole notion of taking this project, like Walter said, ISU would welcome this, like the open call and the open for science. I'd like to understand, how are you going to choose or sift through or work through all these open calls? I mean, I suppose you might be just thrilled that people will participate, but at some point you'll need some kind of mechanism that sort of governs all of this data, because as a species, that's what I believe we're experiencing now. We have too much information. we have so much information coming, how we can't discern. So do you have a governance method, a mechanism that you will use to go through all of this, the open calls, the open for science, this announcement / organization phase that you're sort of on right now?
Yes, absolutely. That's a great question, and something that we had thought through with the project as we were also seeking other voices to contribute to our project. So one thing that we had discussed, we do have a website readily available right now where we have an area where people to contribute to the project. How we would continue to advance this, especially as we go into the conference in October, would be to open that up to see all of the visible responses and then have individuals have the capacity to upvote specific ones that they believe would have the greatest contribution to the record moving forward. We would then also have a specific council which would review them for governance purposes.
Okay, excellent. So upvote and a council. Thank you.
Can I ask a question in a practical term? I don't know if you can hear me on this, but you're proposing a 4 kilo record here, or a 4 kilo subsystem. That means that 4 kilos of something else can't fly. You know, you've always got very restricted space within a spacecraft. How are you going to justify that your 4 kilos of your record should fly in comparison to someone else's spectrometer? You know, the cost of something is not how much you pay for it, it's what you don't do with that money.
It's a very, very good point. The idea is, so the 4 kilo idea that we have was based on being less than 1% of the mass of a comparable spacecraft. And we used New Horizons as a comparable spacecraft to get that number.
Is that dry mass or wet mass? So with fuel or without fuel?
I believe it was the launch mass, so the wet mass.
Okay, so because you got a lot of fuel there.
Yes, correct. The idea is scalable to a large extent. So if we were limited to a much lower mass, we can make a lot of adjustments to the physical structure. The physical design, it will mean that we will lose some of the data that we're wanting to send, but yeah, the design is flexible in that regard. So we would try to minimize the possibility of the host mission having to cut out anything to put us on there.
Okay, thanks.
We have a few questions here in Granada.
So I'm not well versed in space law, self-admittedly. What's to stop a private company from starting a golden record company where you produce this for corporations, you produce this for individuals that are maybe a bit vain, want to throw their own records in space? Is there some organization, some law that stops that from the ground up, or could a company like that be started?
Yeah, unfortunately, I'm not too well versed to be able to tell you the answer as to whether a company could just pop up and compete with us, if you like. By embedding ourselves within the global space community, we hope that we can use the IFC alumni network to be able to use the research grants and be known as the people who are making the golden record and are looking for those mission opportunities. For instance, 2 upcoming opportunities that we've identified include the Interstellar Express mission organized by the Chinese National Space Agency, and then also the Breakthrough Starshot mission. If we're able to get a good relationship with both of those mission organizers early, it means that potentially we could integrate with them early as well. So it's all about relationship building, I think.
There's no law currently right now that would stop someone from building something similar. I think that, to Walter's point, it would be most advantageous to patent it specifically, at least our design of it, and then potentially sell that patent to a specific company or like SpaceX, any kind of launch company that was be launching into space, and put their logo on it.
Looking into how we could make the Eternal Echo as flexible as possible to as many missions as possible, we found out it's actually quite difficult and expensive to find something that is durable, that would guarantee the highest chances of a successful mission for something like a golden record or Eternal Echo. So it's actually not that easy as well to just spin up, even if you did have the means and the legal capacity to do so. So.
Hi, so I'm not sure if it was answered or not, but my question was, did you guys determine where exactly you were going to send it, how fast, like what location in space it was going to be shot, and how did you come to that determination? Also, the second question is that depending on like how far you're getting into the solar system, won't the information that you're putting on it be completely obsolete by the time it reaches even outside of our own solar system?
That's a good question. Thank you. We will rely on a scientific mission. This is the first plan. Exactly like with Voyager 2 and Voyager 1 probe, the mission was first an interplanetary mission with scientific goal. And Carl Sagan and Frank Drake tried to make it, you know, the public lost interest on space since the end of the Apollo program. And Voyager made the attention of the public more focused on science and space in particular. This was all it was about. And we were, the teams in charge of Voyager were not sure that the probe, will be an interplanetary probe and an interstellar probe. But in the end of the program, they decided to go outside the solar system. So the first idea to include ourselves, include a message on an existent scientific mission. But also, we don't know if one day, we talked about billionaires, Elon Musk or Jeff Bezos will decide to send a probe to the outer space. And if it happens, then here we are. But the message is not designed to go to a particular part of our galaxy. It's meant to be universal, really universal, and we will adapt. Does it answer your question? It's a bottle in the ocean, exactly.
Okay, so there wasn't a specific direction that it was being sent?
Absolutely not, and this was the requirements on the design of this message.
Okay.
Also, as you may have heard reiterated in our presentation, even though we are trying to design this with a timeless and eternal concept, anything we launch will intrinsically be a time capsule, so it will be dated.
Thank you. Any more questions online? Or Philomena online, do you have a question?
Yeah, I just put it in the chat. I've heard this quote that, you know, Einstein said, "I want to know the thoughts of God, the rest are just mere details." And I understand from the movie, a very reliable source, Stephen Hawking said that it was not that he believed in God, it was just he couldn't prove he didn't exist. So my question is, in this presentation, and because I may have missed it, or maybe I just don't understand, is there any spiritual component? Because there would be a sector of our population of Earth that would say that we're not alone. We already know that. So that's my question, is where in your presentation or in your paper, perhaps I need to look at that, is the spiritual component of humanity addressed?
Thank you very much for that question. I think it's a very good one, and we might not address this explicitly in the report, but the approach that we're taking with what we call the exhibition of experience, we will allow participants from all over the world to choose the experience that they want to include on the Eternal Echo. So we would send up in space their point of view imagery of that specific experience, correlated with their brain activity during that experience, and we would not limit this. So if individuals would choose specific spiritual activities or things that would evoke spiritual emotions, we would highly encourage that. So by actually opening up the possibility for individuals to choose their own experiences, we hope to not limit ourselves to just a singular point of view, but rather open up for the spectrum of what humanity is.
I think we just have two other comments on that as well. So the only other component included within our report regarding spirituality and religion is specifically centered around the idea that humans have the capacity uniquely to think abstractly about concepts that do not physically exist, which is the concept of collective fiction. We can think of these collective fictions and they become real, so real that we're willing to act on them in multiple different ways. So we have highlighted that as humans, we are able to think abstractly about these specific religions and concepts that do not physically exist, yet are very, very real to many people.
If we may just give a quick round of thank yous. A huge thank you to our co-chairs, Reinhold, Niamh, and Adelia, especially Niamh with all your help. You've been incredible to us and we really appreciated having you here. And we also appreciate you helping Team Agriculture as well. A huge thank you. We also have our expert advisor, Gerhard, who we hope is watching, who was also helpful to us as our expert advisor. And all the TAs that have helped us, Adolfo, Leticia, Charles Aimé, and Mara, thank you so much for all your help. We want to help. Please join us on stage. I have a big list. We also want to thank the IT crew. They stayed up with us till 1 a.m. yesterday practicing. Thank you so much for your help and your patience. And the ISU staff, all of you, especially Ken for editing, thank you so much. Thank you everyone in Strasbourg and online, all the other participants, especially here, our Team Agriculture. We love you. And a huge thank you to everyone in Golden Record. Amazing team. And we wouldn't have sounded this way without all of you here with us.
And also, I'd just like to give a big shout out and thanks to the original thought from Carl Sagan and Frank Drake and all the creators of the original record. We were lucky enough to commune with Nadia Drake about all these concepts and also contributions from Scott Ransom with his updated Pulsar map. That was amazing for us.
All right. So, ladies and gentlemen, what an amazing journey it was today. Since 9 a.m. in the morning, we have watched 4 fantastic presentations. We have started with TP Mobility, and then TP Agriculture, TP Lunar, and TP the Eternal Eco. I also want to acknowledge actually the 5th team project, which was part of this SSP for the online program, the TP Suborbital, who had presented 3 weeks ago, as I mentioned. So with that, this basically concludes the final deliverable of this summer, the Space Studies Program 2021. So as I told before, and as you actually noticed, so these presentations was just a teaser of a very hard work. So I once again want to encourage all of you in a few days to just go to the ISU library website, download the reports, download the executive summaries, and have a good read through to all the 5 team projects of this summer. I also once again thank all the assessors, all the jury members that we have with us, either online, virtually from all over the world, and also in Strasbourg and Granada with us. And also for all the audience who are watching us, again, online on YouTube. We hope that you really enjoy these sessions, and thank you very much for your time as well. So what is next is indeed the closing ceremonies, which is happening tomorrow. So we want to invite you tomorrow to join us once again online virtually at 5:30, where the sessions here in Granada and there in Strasbourg will be interconnectedly coming to an end. With that, once again, thank you very much for joining us and see you tomorrow. Take care.
Should I leave? Did you? Should I leave?
Yeah.
Hello to the Golden Record team. Can you listen? Just give me a thumbs up. So folks, this is Gerhard from Germany. You did just wonderful. I wanted to